Tonight, as the world beyond your window gradually grows quiet and even the familiar sounds begin to dissolve into stillness, we are about to embark on a journey unlike any voyage we have taken before. Perhaps you have looked up at a sky filled with stars and wondered, beyond this familiar Earth, what other extraordinary worlds might exist? Somewhere in the vastness of the cosmos, could there be planets with violet skies, storms that rain diamonds, oceans of molten lava, or distant realms where an entire year lasts only a few hours, or, conversely, where a single day stretches longer than the youth of a human lifetime? Yet perhaps the deeper question is not simply how such planets exist, but why human beings have always felt compelled to search for them. Carl Gustav Jung once suggested that whatever we seek in the outer world often reflects something that already exists within our inner world. Perhaps every distant planet is also a symbol, a mysterious mirror that quietly reveals those parts of ourselves that have never been fully explored. In tonight's video, we will journey together through 100 of the strangest planets ever discovered in the universe. Each destination will unfold a remarkable story filled with seemingly impossible natural laws, breathtaking landscapes beyond the reach of human imagination, and gentle reflections on our own small place within the endless cosmos. This is not a hurried adventure in search of sensational discoveries. Instead, it is a slow and peaceful journey, where science meets imagination, where astronomical discoveries blend with quiet contemplation about the meaning of existence. My hope is that, as each distant world slowly emerges from the darkness, your own mind will gradually become calmer, allowing the burdens of today to drift away like thin clouds crossing a star-filled sky. Welcome to our channel, a place where stories of the universe, psychology, and the hidden depths of the human soul are told in a slow, soothing rhythm, helping you relax, reflect, and gently drift into sleep. If you enjoy journeys that are both intellectually enriching and deeply comforting, I invite you to take a moment to subscribe, turn on notifications, and join us again on future nights. And now, settle comfortably into your pillow, take one slow, deep breath, allow your body to completely relax, and let us begin our voyage to 100 of the strangest planets humanity has ever discovered, where every distant world quietly whispers a story meant for those whose hearts still hold a sense of wonder before the infinite beauty of the universe. A journey to the strangest planets. There is something quietly fascinating about human nature that Carl Gustav Jung returned to again and again throughout his reflections. We are rarely curious only about the world outside ourselves. Whenever our eyes are drawn towards something distant, our minds are, at the same time, turning inward. Perhaps that is why, long before telescopes existed, before spacecraft or modern observatories, human beings could never stop gazing into the night sky. They looked upon the stars with awe, but also with a deeply personal hope, as though somewhere within that boundless darkness rested the answers to questions that the heart had not yet learned how to name. Tonight, before sleep gently finds you, I would like to invite you on such a journey. There is no need to leave the quiet comfort of your room. There is no need for a spacecraft forged from metal or powered by engines strong enough to cross millions of light years. The only things you need to bring are your curiosity, an open mind, and a slow, steady breath. Allow your body to soften. Let the lingering thoughts from today drift quietly away like delicate clouds floating across the night sky. From this moment forward, we will leave behind the familiar sounds of Earth and travel together toward extraordinary worlds that silently exist within the immense ocean of the universe. For many centuries, humanity believed that our solar system was all there was to know. Familiar planets, such as Mercury, Venus, Earth, and Jupiter, seemed more than enough to inspire our imagination. Yet only in the past few decades, as science has advanced with remarkable speed, have we begun to realize that our solar system is merely a tiny island within an ocean so vast that it is almost impossible to comprehend. Every star scattered across the night sky may be surrounded by planets of its own. And among the hundreds of billions of stars in the Milky Way, together with the hundreds of billions of galaxies beyond it, the number of planets may far exceed anything the human mind can comfortably imagine. What is especially fascinating is that the more astronomers discover, the more they realize that the universe seems to have little interest in repeating itself. The rules we once assumed were universal, because they govern life on Earth, now appear to be only one small possibility among countless others. There are planets so hot that metals can evaporate into clouds. There are worlds so dark that they rarely, if ever, receive the light of a sun. There are places where rain is not made of water but of glass, iron, or even shimmering carbon crystals that resemble diamonds. Some giant planets are so remarkably light that, if an ocean vast enough existed, they could float upon its surface. Others wander alone through the endless darkness of space, belonging to no star at all. At first, all of this may sound more like mythology than science. Yet perhaps that is precisely what makes the universe so beautiful. It is always larger than any framework humanity attempts to place around it. And perhaps Jung would have smiled at that truth. He believed that the human psyche grows not only through what is familiar, but also through encounters with mystery. Mystery does not exist to frighten us. Rather, it gently reminds us that there will always be realities extending beyond the limits of our small sense of self. Perhaps that is also why strange planets continue to captivate us so deeply. They are not merely enormous spheres of rock or gas revolving around distant stars. Within the deeper landscape of imagination, each planet becomes a symbol. Some remind us of the blazing emotions we have spent a lifetime trying to suppress. Others remain wrapped in darkness, resembling the shadow in Jungian psychology, that hidden realm containing memories, fears, and longings we rarely allow ourselves to face. And then there are peaceful worlds where everything moves with extraordinary slowness, quietly reminding us that stillness itself can also be a form of wisdom. Of course, these connections are not scientific conclusions. They are symbolic ways of seeing the world. Much like the approach Jung often embraced to help people reflect upon their inner lives through images and stories. And just as dreams do not always require a single, definitive interpretation, neither does every planet we are about to visit. The journey we are about to take may awaken different feelings in each of us. What matters is not discovering one absolute meaning, but simply allowing yourself to quietly observe whatever thoughts arise along the way. Throughout this journey, there is no need to hurry. We will not chase numbers or become lost in complicated astronomical terminology. Instead, each planet will become a quiet, resting place where you can discover the wonders that science has revealed, while also giving your mind permission to rest, drifting gently with the rhythm of the story, as though you were sitting beside a window, gazing into the night sky. Every world will offer something unexpected, but it will also offer a moment of stillness, a chance to breathe, to imagine, and simply to feel. Perhaps, by the end of our journey, you will realize that the strangest thing in the universe is not merely the distant planets that lie thousands of light years away. Perhaps the greatest wonder is the human mind itself. With only a few stories, a handful of images, and a little curiosity, we are able to cross unimaginable distances and reach worlds where no human foot has ever stepped. And through that same imagination, we sometimes discover quiet, deeply authentic corners within our own souls. So, while the night continues to gently embrace the world outside, allow this voyage to unfold slowly. There is no destination that demands haste. There is no answer that must be found before tonight comes to an end. There is only you, the star-filled sky, and 100 extraordinary planets patiently waiting for their stories to be told. And perhaps, as you listen to the tale of some distant world, you may unexpectedly realize that what you are discovering is not only the immense universe beyond, but also a vast, peaceful, and profoundly mysterious space that has always existed within your own mind. Planets with unbelievable weather. In the previous chapter, we had only just begun to leave Earth behind, quietly observing distant worlds as tiny points of light scattered across the darkness. Now, let our journey carry us closer to one of the most astonishing discoveries of modern astronomy. Planets where the very idea of weather extends far beyond anything humanity has ever experienced. Here on Earth, we naturally think of rain as water, wind as moving air, and clouds as condensed water vapor. Since childhood, the memory of rainfall has often been tied to the scent of damp earth after a sunny day, the gentle rustling of leaves, or the peaceful feeling of sitting beside a window while listening to raindrops falling one by one. These images have become deeply woven into humanity's collective unconscious, yet the vast universe gently reminds us that what feels familiar on Earth represents only one tiny possibility among countless others. Imagine a storm where every raindrop is not water, but molten iron. Imagine a sky where metal does not rest beneath the ground but floats through the atmosphere like water vapor drifting across Earth's skies. At first, such an image sounds more like mythology than science, yet it is one of the leading hypotheses astronomers have proposed from their observations of WASP 76b, an exoplanet located hundreds of light-years away from Earth. WASP 76b belongs to a class of planets known as ultra-hot Jupiters, enormous gas giants comparable in size to Jupiter, but orbiting astonishingly close to their parent stars. They orbit so closely that an entire year on the planet lasts only a few Earth days. This extraordinary proximity allows the planet's dayside temperatures to soar beyond 2000 to 2400 degrees Celsius, hot enough for many familiar metals to begin vaporizing. Under such extreme conditions, elements such as iron and magnesium, along with certain silicate minerals that form rocks on Earth, can no longer remain solid. Instead, they become vapor, mixing into an atmosphere intensely heated by radiation from the nearby star. Powerful winds, racing across the planet at thousands of kilometers per hour, continually carry these metallic vapors toward the hemisphere that remains in perpetual darkness. There, temperatures fall just enough for iron vapor to condense into droplets of liquid metal. It is through this process that researchers proposed the remarkable hypothesis that iron rain may fall on WASP 76b. Of course, when scientists speak of iron rain, it is important to understand that this description is based on current physical models and spectroscopic observations. No spacecraft has ever directly witnessed such storms. Nevertheless, observations of the planet's atmosphere have revealed vaporized iron, along with evidence consistent with large-scale atmospheric circulation and condensation between the planet's permanently illuminated and permanently dark hemispheres. Together, these findings paint a picture so extraordinary that it leaves the imagination quietly astonished. Perhaps it is in moments like these that we truly appreciate what Carl Gustav Jung meant when he wrote, "The least of things with a meaning is worth more in life than the greatest of things without it." It is not because a rainstorm made of iron carries symbolic meaning in itself. Rather, its very existence invites us to broaden the way we see reality. Each time science uncovers something that once seemed impossible, the human mind is gently encouraged to step beyond the boundaries of what it once accepted as obvious. One thought worth reflecting upon is our tendency to treat personal experience as though it were a universal standard. We assume that water must always be water, rocks must always remain solid, and metals must always lie buried beneath the ground. But the universe is not constrained by our experiences. It follows only the laws of physics, and the outcomes of those laws can vary almost without limit. A change in temperature, pressure, or chemical composition is enough to give rise to an entirely different world governed by entirely different rules. Viewed through the symbolic perspective that Jung often embraced, This reflects something equally true about our inner lives. Sometimes we resemble people who have known only one kind of emotional weather. We believe feelings should move in predictable ways, and that people ought to respond according to familiar patterns. Yet, like the universe itself, the inner world is far richer than conscious awareness can fully perceive. Within the unconscious are hidden regions that operate according to their own quiet laws, slowly transforming memories, sorrow, and hope in much the same way that enormous atmospheric currents carry metallic vapor from the blazing dayside of WASP 76b into its endless night. Jung never regarded the unconscious as a chaotic place that should be eliminated. On the contrary, he saw it as the birthplace of creativity, symbolism, and psychological growth. What first appears unfamiliar or difficult to understand often serves as an invitation to expand our awareness. Perhaps that is one reason strange planets continue to fascinate us so deeply. They teach us not only about astronomy, but also remind us that reality is always far larger than what we have become accustomed to calling normal. Among the ultra-hot Jupiters, WASP 76b is far from the only planet to astonish scientists. Many others reach temperatures high enough for the very minerals that form rocks on Earth to vaporize. Compounds rich in silicon, magnesium, and iron may exist within their atmospheres as immense clouds of mineral vapor. If a human observer could somehow watch safely from a distance, a purely imaginary possibility, the scene would likely resemble a surreal painting rather than a planet. There would be no familiar white clouds drifting beneath a gentle blue sky. Instead, there would be a world glowing beneath unimaginable heat, where even stone itself could become vapor. It is remarkable to realize that all of this unfolds within the very same universe that we call home. While Earth offers gentle rain that nourishes life, somewhere unimaginably far away, the very same physical laws create storms of molten metal. Neither world is more right nor more wrong than the other. Different conditions simply give rise to different realities. Perhaps there is a quiet lesson here for us as well. Every soul possesses its own unique climate, shaped by different memories, experiences, and circumstances. Rather than rushing to judge those differences, perhaps we are invited instead to observe them with patience and seek understanding. As the night grows deeper and our slow narration continues to guide us across these distant regions of space, allow the image of iron rain to become nothing more than a gentle reminder that the universe is always larger than our imagination, just as the human mind is always deeper than what appears upon its surface. And perhaps, within the stillness of this very moment, you may come to feel that the greatest wonder is not a planet where iron falls from the sky, but the extraordinary capacity of the human mind to continually expand its awareness to welcome what once seemed impossible, both throughout the boundless universe and within the quiet depths of its own inner world. Extraordinary planetary systems. When we were children, most of our earliest pictures of the universe began with a familiar scene. A single sun resting at the center, while planets quietly revolved around it in stable orbits. That is how we first learned about the solar system. And it is also how our minds gradually formed the assumption that perhaps every planetary system in the universe must resemble the home to which Earth belongs. Yet the more deeply astronomers have observed the heavens, the more they have come to realize that nature never intended to repeat a single blueprint. Each newly discovered planetary system seems to whisper the same quiet message. What you consider ordinary is simply one possibility among infinitely many. Tonight, let your mind continue to drift slowly among the stars. Imagine that our imaginary spacecraft is quietly leaving behind the familiar regions of the solar system, traveling toward places where sunrise and sunset unfold unlike anything we have ever known. There are planets where not one sun, but two, illuminate the sky. Their light comes from two different stars, each moving to its own celestial rhythm, creating skies so extraordinary that, if we could stand upon their surface, we might feel as though we had stepped into a dream. One such world is Kepler 16b, the first confirmed exoplanet. discovered to orbit both stars. In a binary star system, a configuration astronomers call a circumbinary planet. Instead of circling a single star as Earth orbits the Sun, Kepler 16b follows a vast orbit that encompasses both stars as they revolve around one another. From the planet's hypothetical surface, an observer would never witness the familiar sight of a single sun rising and setting each day. Instead, they might watch two suns sharing the sky, sometimes close together, sometimes drifting far apart, creating an endlessly intricate dance of light across the heavens. The idea of twin sunsets had appeared in countless works of science fiction long before Kepler 16b was ever discovered. Yet what is remarkable is that reality has proven to be every bit as beautiful as imagination. As space telescopes gathered data from this distant system, they delivered more than just another astronomical discovery. They expanded the boundaries of what humanity believed nature itself was capable of creating. It turns out that the universe has never been concerned with whether we are accustomed to having only one Sunday. It simply follows its own quiet laws. And within those laws, a planet illuminated by two suns is entirely possible. Carl Gustav Jung once wrote, "The privilege of a lifetime is to become who you truly are." That sentence is often understood as an invitation to embark upon the journey of self-discovery. Yet in a broader sense, it also reminds us that everything in the universe follows its own unique path of existence. Kepler 16b does not need to resemble Earth in order to possess meaning. It simply exists as itself, following the remarkable orbit that belongs to it alone. Perhaps human beings are not so different. We spend so much of our lives trying to fit an ideal pattern, while nature quietly reminds us that diversity is not the exception, it is the very essence of life. If planets orbiting two suns astonish us because they possess more than one source of light, then at the opposite extreme of the universe, there exist worlds that seem to have no sun to call home at all. These are known as rogue planets, sometimes called wandering planets. The name itself carries a certain quiet beauty, touched with a hint of loneliness. Unlike Earth or Kepler 16b, rogue planets orbit no star whatsoever. They drift freely through the immense spaces between stellar systems, like solitary islands floating across the endless ocean of our galaxy. Some may have been born within ordinary planetary systems before powerful gravitational interactions with giant planets or other cosmic disturbances hurled them into interstellar space. Others may have formed through entirely different processes that scientists are still working to understand. Take a quiet moment to imagine such a world. There is no sunrise, no sunset, no sun slowly lifting itself above the horizon. Only an almost eternal night, scattered with countless distant stars. If you could stand upon the surface of a rogue planet, the sky would likely possess a beauty unlike anything we know on Earth. Not the radiant brilliance of daylight, but the profound stillness of darkness itself, where every distant star shines with breathtaking clarity. For many people, such an image might evoke a feeling of loneliness. Yet Jung repeatedly reminded us that solitude is not necessarily the same as loss. Throughout the process of individuation, a person often passes through periods of stepping away from the crowd in order to encounter the deeper self. As he famously wrote, "Who looks outside, dreams. Who looks inside, awakes." What is remarkable about those words is that they do not encourage us to turn our backs on the outer world. Instead, they invite us to find a balance between exploring the universe around us and exploring the universe within. Perhaps that is why rogue planets awaken such a distinctive feeling. They no longer receive the comforting light of a nearby star. Yet precisely because of that, their skies reveal countless other lights shining from unimaginable distances. Sometimes, when one familiar source of guidance disappears, we begin to notice how many others have quietly been there all along. Of course, Most rogue planets are believed to be unimaginably cold. Without the steady warmth of a parent star, surface temperatures may plunge hundreds of degrees below freezing. Yet some scientific models suggest that if these worlds are sufficiently massive, possess thick atmospheres, or retain internal heat left over from their formation, they may still harbor unusual environments hidden beneath deep layers of ice. This remains an active area of research, but even the possibility is enough to carry the human imagination farther than ever before. There is something quietly beautiful that the universe seems to teach us again and again. Not every world needs to resemble another in order to be extraordinary. Some planets live beneath the light of two suns. Others have no sun at all. Some experience days and nights shaped by twin sources of light. Others remain wrapped in darkness that seems almost endless. Yet each of them represents a different chapter in the same vast story of the cosmos. And perhaps the human mind is much the same. Some people grow up surrounded by abundant love, like a planet forever bathed in sunlight. Others must learn to find their own way through longer seasons of darkness. Some carry many sources of inspiration and countless places of belonging. Others must slowly learn how to become their own light. Every journey is different, and it is precisely that difference that gives the inner life its quiet beauty. As tonight gradually slips toward midnight, and our gentle narration continues to guide us through these extraordinary planetary systems, perhaps the most memorable discovery will not be that somewhere in the universe there exists a world with two sunsets, or a lonely planet silently wandering through the endless darkness between the stars. Perhaps what is even more meaningful is the quiet reminder offered by the universe itself. Through its limitless diversity, it gently tells us that there has never been only one way to exist. Just as every star follows its own orbit, and every planet carries its own history, each human being is also walking a path unlike anyone else's. And sometimes, simply accepting that truth allows the mind to become a little lighter, a little more peaceful, gently closing the chapter of a long day and opening the door to a deep and restful sleep beneath a sky filled with stars. Planets that resemble hell. By this point in our journey, you have perhaps begun to sense something truly remarkable about the universe. The farther we travel from Earth, the more we encounter worlds that seem to leave human language struggling to describe them. We have visited planets where iron falls from the sky like rain. We have imagined worlds illuminated by two suns at once, and lonely planets wandering through the endless darkness without belonging to any star. Yet even more extreme worlds await us, places where scientific measurements alone can scarcely convey what is truly happening. Tonight, let your imagination continue to lead the way. This time, however, we will draw closer to a planet that has left many astronomers both astonished and humbled by what seems to be nature's limitless creativity. That world is 55 Cancri E, a super-Earth located about 40 light-years away in the 55 Cancri star system. Although it is called a super-Earth because it is larger and more massive than our own planet, nearly every similarity ends with its name. If Earth is a symbol of the delicate balance that allows life to flourish, then 55 Cancri E stands as a reminder that the very same laws of physics can also create a world unlike anything we have ever known. This planet orbits astonishingly close to its parent star, so close that if it were placed within our own solar system, its orbit would lie well inside that of Mercury. Such an unimaginable proximity subjects its surface to an overwhelming flood of stellar energy. Observations suggest that its daytime temperatures may exceed 2000 degrees Celsius, hot enough to melt most of the rocks that shape Earth's mountains and continents. Pause for a moment and picture that scene as slowly as you can. There are no snow-covered mountains, no shimmering rivers, no forests, meadows, or deep blue oceans. Instead, vast regions stretch endlessly across the landscape where rock no longer exists in the form we know. It has melted into brilliant oceans of glowing lava, flowing continuously, like immense waves of liquid fire. The star's fierce light reflects from those molten surfaces, making the entire planet appear to glow against the darkness of space. In many popular science articles, worlds like this are often described as hell-like. It is a vivid comparison, yet it is important to remember that this is not hell in any religious or philosophical sense. It is simply an environment so physically extreme that life as we understand it could scarcely survive there. From a scientific perspective, 55 Cancri E is not a place of punishment. It is merely the natural outcome of orbital distance, planetary mass, and the relentless energy radiated by its parent star. Perhaps even more astonishing is the speed with which this planet completes a single orbit. 1 year on 55 Cancri E lasts only about 18 Earth hours, while Earth requires more than 365 days to complete one journey around the Sun. An entire year on this distant world begins and ends more quickly than the span of an ordinary day in our own lives. Suddenly, the idea of time itself becomes wonderfully intriguing. We often think of time as something fixed and universal. We divide it into days, months, and years until those units begin to feel like eternal truths. Yet in reality, they simply reflect the rhythm of Earth's own motion. Step onto another world, and even our most familiar understanding of time begins to change. A year is no longer marked by 4 changing seasons. It becomes merely one brief circuit around another star. Carl Gustav Jung once wrote, "Time is a child playing like a child playing a board game. The kingdom belongs to the child." When recalling this quotation, it is worth remembering that Jung was drawing upon the philosophy of Heraclitus as he reflected on the nature of time and the movement of consciousness. What is fascinating is that both philosophy and astronomy lead us toward a similar realization. Time is far less absolute than our everyday experience suggests. The universe does not measure time with clocks. It measures time through motion. If it were somehow possible to stand upon the surface of 55 Cancri E, a scenario that remains entirely impossible in reality, the sky above would be both magnificent and overwhelming. Its parent star would no longer appear as the small luminous disk we know as the Sunday. Because of the planet's extraordinary proximity, the star would dominate a vast portion of the sky, radiating an almost unrelenting torrent of light and heat. It would not be a gentle sunrise welcoming a new morning, but an immense sphere of blazing fire, filling the heavens with an intensity almost beyond imagination. Such a landscape naturally evokes thoughts of destruction. Yet through Jung's perspective, perhaps another layer of meaning emerges. Jung did not regard powerful images in dreams or ancient symbols merely as signs of danger. He believed they often represented profound processes of transformation. Fire, throughout many symbolic traditions that Jung studied, embodies both destruction and purification. It brings one state of existence to an end so that something new may begin. That does not mean we should romanticize suffering. Quite the opposite. It reminds us that even the harshest circumstances can become opportunities to understand ourselves more deeply. Jung once wrote, "There is no coming to consciousness without pain." This statement is not an endorsement of suffering. Rather, it suggests that the expansion of awareness often requires us to face the most difficult parts of ourselves. Just as 55 Cancri E was shaped by the universe's most extreme conditions, many of humanity's greatest qualities, resilience, compassion, wisdom, and perseverance, are often forged during life's greatest challenges. Of course, this comparison is purely symbolic. A planet covered in molten rock is not a perfect metaphor for the human psyche. Yet sometimes the images offered by the universe help us express emotions that are otherwise difficult to name. There are moments when our own feelings resemble an ocean of lava, intense, overwhelming, and seemingly impossible to control. Yet just as every planet continues faithfully along its orbit, those emotions, too, will eventually change with time. Perhaps the greatest gift 55 Cancri E offers us is not its harshness, but its ability to stretch the boundaries of our imagination. It reminds us that the universe creates far more than gentle worlds like Earth. It also creates places where rock becomes liquid, where a year is shorter than one of our days, and where the parent star fills nearly the entire sky. And somehow, all of these astonishing worlds coexist within the same universe. Once we truly appreciate that, perhaps it becomes easier to extend the same compassion toward our own lives. Not every journey unfolds under ideal conditions. Not every soul experiences endless seasons of spring. Some chapters of life feel as though we are crossing a planet covered in molten lava, where everything seems unbearably intense. Yet those very chapters often teach us endurance, adaptability, and the remarkable human capacity for renewal. So, as our imaginary spacecraft quietly leaves 55 Cancri E behind and continues its voyage among the stars, carry with you one gentle thought. The universe does not divide worlds into good or bad, heaven or hell. It simply gives rise to countless different ways of existing. And perhaps our inner lives are much the same. Within every human heart, there are places filled with gentle light, and others burning with fierce intensity. Both belong to the same lifelong journey of becoming who we truly are. And perhaps, once we understand that, we can close our eyes a little more peacefully, allowing the fires of a long day to gradually fade, making way for the quiet stillness of sleep that is now drawing gently near. Worlds of endless darkness and vast oceans. As our imaginary spacecraft quietly leaves behind those blazing worlds of molten lava, the universe opens onto an entirely different landscape. Gone is the dazzling brilliance of enormous stars filling the sky. Gone are the oceans of fire rolling beneath temperatures of thousands of degrees. In their place comes an almost perfect stillness, a beauty created not by light, but by darkness itself. At first, that may sound like a contradiction. Since the earliest days of human history, light has symbolized life, while darkness has often represented the unknown. Yet if we spend enough time gazing into the night sky, we begin to realize something quietly profound. It is darkness that allows the stars to shine. Tonight, we arrive at one of the most extraordinary planets ever discovered. TESS 2b, a world famous for absorbing almost all the light that reaches it. This gas giant orbits extremely close to its parent star, placing it among the family of hot Jupiters. Observations made by space telescopes reveal that TESS 2b reflects less than about 1% of the light falling upon it. That remarkable property makes it one of the darkest planets humanity has ever observed. Role confirmed. I will act as a professional Vietnamese English literary translator, specializing in long-form YouTube narration. I will translate your manuscript faithfully and completely, without omitting, shortening, or adding any information. The English will be written in natural American English, with a calm, reflective bedtime narration inspired by the contemplative spirit of Carl Gustav Jung, making it pleasant to listen to before sleep. Imagine it very slowly. If you were standing far out in space, gazing toward TESS 2b, you would not see a brilliant sphere shimmering like Earth viewed from orbit, nor would you see bright white cloud bands reflecting sunlight as you would on Jupiter. Instead, the planet would appear as a quiet patch of darkness drifting silently among the light of distant stars. It is not entirely invisible, because its intensely hot atmosphere can still emit a faint, reddish glow produced by its tremendous heat. But for most of the time, TESS 2b resembles a giant drop of ink suspended in the vastness of the universe. Scientists believe this remarkable darkness is likely connected to the planet's unusual atmosphere and the absence of reflective clouds like those found on more familiar worlds. Its extreme temperatures prevent many bright cloud formations from developing. As a result, most of the incoming starlight is absorbed by the atmosphere instead of being reflected back into space. What is fascinating is that, Although atmospheric physics can explain this phenomenon, the image of TESS 2b naturally reaches another, deeper layer of the human imagination. A planet so dark that it seems to swallow nearly all light becomes an almost perfect symbol of what Carl Gustav Jung called the shadow, the hidden dimension within the human psyche. It is important, however, to understand what Jung truly meant by the shadow. It is not evil, nor is it simply the negative side of human nature. The shadow consists of those aspects of ourselves that our conscious mind has not yet recognized, accepted, or integrated. Jung expressed this beautifully in one of his most celebrated statements. One does not become enlightened by imagining figures of light, but by making the darkness conscious. Perhaps this remains one of his most frequently quoted reflections because it does not encourage us to flee from darkness. Instead, it gently invites us to understand it. Astronomers do not turn away from TESS 2b simply because it is too dark to observe with the naked eye. They patiently study its spectrum, analyze countless measurements, and gradually uncover its true nature. Sometimes the deepest truths are not found in what shines most brightly before our eyes, but in what reveals itself only to those who observe with enough patience. Leaving behind that world which seems to swallow almost every ray of light, our journey now carries us toward an entirely different kind of planet, one where darkness no longer reigns. Instead, water becomes the defining element. Here on Earth, oceans cover roughly 70% of the planet's surface. To us, that already feels almost endless. Yet elsewhere in the universe, scientists believe there may exist ocean worlds, planets where water covers not merely most of the surface, but nearly the entire globe. If one day we could quietly hover above such a world, the view might be astonishingly peaceful. No continents stretching across the horizon, no mountain ranges rising from the sea, only a vast ocean extending endlessly in every direction, meeting the horizon wherever the eye can see. The surface reflects the light of its parent star, creating the gentle illusion that the entire planet is breathing with slow, endless waves. Yet beneath that peaceful beauty lies a reality profoundly different from our own. Planetary models suggest that on some ocean worlds, the water may reach depths of hundreds, or even thousands, of kilometers. Such numbers almost exceed our ability to imagine them. On Earth, the deepest point of the Mariana Trench lies about 11 kilometers below the surface. On these distant planets, however, the oceans could be hundreds of times deeper. The farther downward one travels, the more dramatically the pressure increases. Eventually, water no longer behaves in the familiar way we know. At such extraordinary depths, although temperatures may remain extremely high, the immense pressure forces water molecules into remarkable crystalline structures known as high-pressure ice. What makes this especially fascinating is that this form of ice does not require freezing temperatures like the ice we know on Earth. Instead, it forms primarily because of overwhelming pressure. It is a beautiful reminder that the same familiar substance can take on completely different forms simply because its physical surroundings have changed. Perhaps the human soul is much the same. Different experiences give rise to different expressions of the same essential nature. Someone raised in peace may come to see the world one way. Someone shaped by hardship may see it quite differently. Human nature itself does not fundamentally change, yet circumstances can transform how its familiar qualities reveal themselves. Carl Gustav Jung once wrote, "Who looks outside, dreams. Who looks inside, awakes." As we contemplate these immense oceans scattered throughout the cosmos, it is easy to become captivated by their breathtaking scale. Yet Jung's words gently redirect our attention toward another ocean, the vast ocean of our own inner life. Just as science has never directly explored the deepest flaws of these distant ocean worlds, neither have we ever fully explored the deepest layers of the human unconscious. We approach them only gradually, through dreams, symbols, memories, and the sincere practice of observing ourselves with honesty and compassion. One of the universe's quietest gifts is that it never demands we understand everything. TESS 2b will continue silently absorbing light hundreds of light years away. Ocean worlds, if they truly exist as current models suggest, will continue carrying seas deeper than any humanity has ever known. And beneath those unimaginable waters, immense pressure will quietly continue shaping extraordinary forms of ice that no human eyes have ever directly witnessed. Perhaps this offers us one final, gentle lesson before this chapter of our journey comes to a close. Not everything profound must be illuminated immediately. Some darkness deserves our respect. Some depths ask to be approached with patience rather than haste. For billions of years, the universe has calmly guarded its mysteries, never rushing to reveal them all at once. And perhaps that same quiet patience is exactly what our own minds need tonight. Like a dark planet silently circling its distant star, or an immense ocean gently embracing the mysteries hidden beneath its deepest waters. Every human being carries within them landscapes that remain unexplored. There is no need to fear them. We need only be gentle enough to listen, patient enough to observe, and peaceful enough to accept that perhaps the greatest beauty of both the universe and the human soul has always resided in what has not yet been fully seen. A planet being torn apart. If the worlds we have already visited filled us with wonder through iron rain, oceans of molten lava, and seas thousands of kilometers deep, then the next destination on our journey brings us somewhere quieter and perhaps even more moving. Not because it possesses the gentle beauty of distant stars, but because it reminds us of a truth shared alike by the universe and by human life. Nothing exists forever in exactly the same form. Tonight, let your imagination carry us to WASP 1-2b, an exoplanet located roughly 600 light-years from Earth. It is a giant gas planet belonging to the family known as hot Jupiters, orbiting so close to its parent star that it completes a full revolution in just a little over one Earth day. If WASP 1-2b were placed within our solar system, it would orbit far closer to its star than Mercury does to the Sunday. That astonishing proximity has created one of the most dramatic scenes modern astronomy has ever observed. When we think of a planet, we naturally imagine an almost perfect sphere. Earth is slightly flattened at the poles. Jupiter and Saturn share much the same shape. In our minds, the word planet almost automatically suggests a stable globe quietly traveling through space. But WASP 1-2b tells a very different story. The gravitational pull of its parent star is so powerful that it does more than simply hold the planet in orbit. It actually stretches the planet itself. Instead of remaining nearly spherical, WASP 1-2b has been distorted into an elongated oval, often compared to an enormous egg or a giant rugby ball. This happens because of tidal forces, the very same physical principle responsible for Earth's ocean tides caused by our moon. On WASP 1-2b, however, these forces are unimaginably stronger. Pause for a moment and picture that extraordinary scene. A giant planet, no longer allowed to preserve its own natural shape. It is continuously stretched by the immense gravity of the star at its center. Its outer layers of gas are gradually torn away and drawn into space. That escaping material does not disappear. Instead, it slowly falls back toward the star itself. Like an invisible river flowing in reverse from the planet toward the star that has held it captive within its gravitational embrace for millions of years. Observations made by space telescopes reveal that WASP 1-2b is indeed losing its material. According to current scientific models, the planet is slowly being eroded by the very gravity of the star around which it revolves. If this process continues long enough, WASP 1-2b may eventually lose much of its mass and perhaps, in the distant future, be destroyed altogether. There is something strangely moving about realizing that a planet, something we instinctively associate with permanence and stability, can slowly fade away piece by piece. And perhaps it is here that science and the reflections of Carl Gustav Jung quietly meet. Jung once wrote, "Everything that irritates us about others can lead us to an understanding of ourselves." At first glance, these words seem to concern human relationships. Yet on a deeper level, they reveal one of the central insights of analytical psychology. What moves us? What unsettles us? What fills us with awe in the outer world often reveals something equally important within our own inner world. Watching WASP-12b stretched and slowly losing parts of itself, many people naturally feel a quiet sadness. But that feeling does not arise from the planet. It arises from us, because human beings long for beautiful things to last forever. We hope familiar things will never change. We cherish stability. We want to believe that orbits will always remain unchanged, that forms will always stay exactly as they are. Yet the universe has never promised us such certainty. Even enormous worlds, far larger than Jupiter, are not immune to change. They are born, they evolve, and, in time, they transform. The only real difference lies in the scale of time. What unfolds during a human lifetime may take only years. What unfolds in the life of a planet may require millions or even billions of years. Yet the essential nature of transformation remains the same. What happens to a planet may unfold over millions or even billions of years. Yet the essential nature of transformation remains the same. Jung repeatedly emphasized that human maturity is not the process of preserving the self exactly as it once was. Rather, it is a process of transformation. In his work, Symbols of Transformation, he explored how symbols of death and rebirth appear again and again throughout mythology, religion, and dreams as expressions of psychological change. What is especially striking is that death in these symbolic traditions rarely signifies an absolute ending. More often, it represents the closing of one state of being so that another may begin. Seen in that light, WASP-12b quietly invites us to contemplate something rather beautiful. What is disappearing is not the order of the universe. It is simply one form of existence making way for another. The matter escaping from the planet does not vanish from the cosmos. It becomes part of its parent star. In the unimaginably distant future, those very atoms may one day participate in the formation of entirely new worlds. The universe wastes nothing. It simply continues transforming. Carl Gustav Jung once wrote, Gustav Jung, "In all chaos there is a cosmos, in all disorder, a secret order." Perhaps no quotation captures what is happening on WASP-12b more beautifully. From a human perspective, the planet appears to be dying. From the universe's perspective, it is simply undergoing a natural process governed by the laws of gravity. What we call chaos is sometimes only a greater order that our understanding is not yet wide enough to perceive. Even our idea of what defines a planet becomes softer and more flexible. We often imagine planets as stable spheres, quietly circling their stars. Yet WASP-12b reminds us that no definition is truly permanent. A planet may become stretched. It may gradually lose its mass. It may spend millions of years slowly coming apart, while still remaining a planet all the same. In many ways, this echoes Jung's understanding of human identity. He never regarded a person as something fixed and complete. The ego, in his view, is not a finished statue carved in stone, but an ongoing process, something continually moving, changing, and unfolding. We are not only who we are today, we are always becoming someone new. Perhaps that is the gentlest lesson WASP-12b offers us tonight. Not every change is a loss. Not every distortion is a failure. Not every ending is truly the end. Some things are simply changing from one form into another. Just as water becomes clouds, Clouds become rain, and the substance of a distant planet gradually merges with the light of the very star it has circled for countless ages. As our imaginary spacecraft quietly leaves WASP 12b behind, the planet will continue its silent journey around its star, slowly surrendering layer after layer of its atmosphere beneath overwhelming gravitational forces. The process will unfold with extraordinary patience, so slowly that it lies almost beyond the reach of human time, and perhaps, within that unhurried rhythm, there is one final, gentle reminder for each of us before sleep arrives. Life does not ask us to remain the same forever. Like the planets scattered across the universe, we, too, are changing every day. Sometimes those changes are obvious. Sometimes they are almost impossible to notice. What truly matters is not resisting every transformation. It is learning to trust that even in the moments when everything seems to be falling apart, a deeper order may still be quietly guiding us toward the people we are meant to become. The cotton candy planets, after leaving behind worlds slowly being torn apart by the immense gravity of their stars. One might imagine that the universe has already revealed nearly every strange possibility it could offer. Yet, much like one of Carl Gustav Jung's dreams, where new symbols emerge just when we believe we have understood the old ones, the universe surprises us once again in an entirely unexpected way. This time, not through blazing planets, not through oceans of molten lava, not through rain made of metal. Instead, it astonishes us with worlds that seem to challenge our deepest intuitions about matter itself. In everyday life, we tend to hold a very simple belief. The larger something is, the heavier it must be. A large rock weighs more than a small one. A truck weighs more than a bicycle. This intuition has accompanied us since childhood, becoming so familiar that we almost mistake it for a universal law. But the universe, as it so often does, quietly smiles at the things we take for granted. Tonight, our imaginary spacecraft arrives at a remarkable family of planets that astronomers affectionately call super-puff planets, or, more playfully, cotton candy planets. Even the name evokes something soft, light, and gentle. Hardly what we expect from enormous worlds drifting through the cold darkness of space. Among the best-known members of this extraordinary family is Kepler 5.1b. At first glance, there seems to be nothing especially unusual about it. It is enormous. Its radius is nearly equal to, or according to some measurements, even larger than that of Jupiter. Judging only by its size, one might naturally assume it is an immense gas giant containing an equally enormous amount of matter. But when astronomers calculated its mass by studying its gravitational influence on neighboring bodies, they discovered something almost unbelievable. Kepler 11b is astonishingly light. So light, in fact, that its average density is only a tiny fraction of Jupiter's, and dramatically lower even than Saturn's, a planet already famous for having a density lower than water. People often say that if an ocean large enough could somehow exist, Saturn would float upon its surface. Kepler 5.1b is even more extreme. Of course, no such ocean exists. The comparison is simply a helpful image, allowing us to appreciate just how unusual this distant world truly is. Yet that image naturally stretches the imagination. How can something so enormous be so remarkably light? Current models suggest that Kepler 5.1b possesses an extraordinarily thick atmosphere that has expanded to immense proportions. Most of the planet's volume consists not of dense material, but of light gases heated and inflated by the energy of its parent star. As a result, the planet appears gigantic, even though its actual mass is surprisingly modest compared with its immense size. It is fascinating to realize that even in astronomy, appearances can deceive our intuition. Perhaps this is where another famous observation by Carl Gustav Jung comes to mind. Thinking is difficult, that's why most people judge. Simple though it may seem, This insight extends far beyond human relationships. It also reflects the way we approach the universe itself. Simply by looking at Kepler 5.1b's immense size, we instinctively conclude that it must be tremendously heavy. Yet careful scientific observation reveals something entirely different. Our inner lives often work in much the same way. Some people appear strong while carrying extraordinary fragility within. Others seem quiet and unremarkable, yet possess remarkable depth and resilience. If we look only at the surface, our judgments can easily lead us astray. Jung consistently reminded us that what truly matters is not the image the ego wishes to present to the world, the persona, but the deeper reality that exists behind the mask. In that sense, Kepler 5.1b is more than an unusual exoplanet. It becomes a gentle reminder that size is not always the same as substance, just as outward appearance does not always reveal inner truth. If we could somehow approach a world like Kepler 5.1b, the view would likely seem almost dreamlike. Its atmosphere might extend astonishingly far from its core, wrapping the planet in countless layers of soft, mist-like gases. There would be no solid ground upon which to stand. The deeper one descended, the greater the pressure would become, as the gases slowly grew denser, before giving way to more compact layers hidden beneath. It is, in many ways, a planet almost defined by emptiness. And strangely enough, it is that very emptiness that allows it to become so vast. This naturally calls to mind a familiar idea found in many Eastern philosophical traditions, where emptiness is not viewed as absence, but as the very condition that allows all things to exist. Although Jung never identified his psychology with any single he once wrote, "The meeting of two personalities is like the contact of two chemical substances. If there is any reaction, both are transformed." Perhaps the most meaningful word in that sentence is transformed. The universe itself seems to operate in much the same way. A planet does not need to resemble the worlds we already know in order to possess value. Precisely because Kepler 5.1b is so different, it is helping astronomers better understand how planets form, how atmospheres evolve, and where the limits of our scientific models truly lie. With every new cotton candy planet that we discover, we are reminded that nature is always more imaginative than any theory humanity has yet devised. And perhaps the human mind is much the same. We often try to fit people into neat little categories with simple labels: strong or weak, successful or unsuccessful, introverted or extroverted. Yet the longer we live, the more clearly we realize that no human being belongs entirely within a single definition. Every soul resembles a planet carrying within it hidden layers, mysterious cores, and vast spaces that even it has not yet fully explored. Carl Gustav Jung once wrote, "The shoe that fits one person pinches another." There is no recipe for living that suits all cases. Perhaps that is exactly what Kepler 5.1b has been quietly telling us from thousands of light years away. There is no single blueprint for every planet. There is no single formula for every human life. What suits one world may not suit another. What is true for one life may not be true for the next. When we hear a planet affectionately called a cotton candy planet, it is easy to smile at the charm of the name. Yet behind that gentle nickname lies a profound lesson in intellectual humility. The universe constantly reminds us that intuition must always be illuminated by careful observation. What appears incredibly heavy may in fact be astonishingly light. What seems almost empty may be quietly holding its deepest secrets. And perhaps that is the gentle gift this part of our journey offers before sleep slowly closes your eyes. There is no need to rush into judging yourself or anyone else based solely on what appears on the surface. Like Kepler 5.1b, every person possesses invisible layers that only time, understanding, and patience can gradually reveal. Just as the universe will always be larger than any map we draw of it, the human soul will always be deeper than anything visible to the eye. And perhaps it is through gently accepting that truth that we can finally loosen the judgments we have carried throughout the day, allowing the mind to become as light as a drifting cloud beneath a sky full of stars, peacefully floating towards sleep. A planet with eternal day on one side and eternal night on the other. The deeper we travel among the universe's extraordinary worlds, the more we begin to realize that nature never seems to repeat itself. Some planets are covered by oceans of molten lava. Some are as light as cotton candy. Others are slowly being pulled apart by the gravity of their own stars. And somewhere else within our galaxy, we encounter another kind of world that is perhaps even more remarkable. A planet where sunrise and sunset, companions of humanity since the dawn of history, have almost ceased to exist. Tonight, imagine our spacecraft slowly approaching a planet, orbiting extraordinarily close to its parent star. From a distance, it looks much like thousands of other exoplanets astronomers have discovered. Yet as we draw nearer, something remarkable becomes clear. This planet no longer rotates the way Earth does. Instead, it has entered a state known as tidal locking. Tidal locking is one of celestial mechanics' most elegant phenomena. When an astronomical body orbits another, much larger object, at a sufficiently close distance for a very long time, gravity gradually slows its rotation until its rotational period becomes exactly equal to its orbital period. The result is extraordinary. One side of the planet always faces its star. The opposite side remains forever turned away from the light. In fact, we already know a familiar example much closer to home. Earth's moon always presents the same hemisphere toward us. That does not mean the moon does not rotate. Rather, it is tidally locked to Earth. Likewise, many exoplanets orbiting extremely close to their stars are believed to exist in this very same state. Now imagine such a world. On one hemisphere, the light never fades. There is no afternoon, no sunset, no gentle arrival of night. The enormous star hangs motionless in the sky, day after day, while millions of years quietly pass with scarcely any change in its position. Meanwhile, on the opposite hemisphere, darkness never leaves. There is no dawn, no first rays of morning sunlight, no shadows slowly moving across the landscape, only an endless night beneath which distant stars shine with an almost perfect stillness. Between these two hemispheres lies a narrow region where light and darkness meet. Scientists call this the terminator zone. According to some planetary climate models, this narrow boundary may possess the most moderate conditions on the entire planet, where the intense heat of the day side and the profound cold of the night side partially balance one another. If humanity were ever to discover life on a tidally locked world, many researchers believe this twilight region would be among the most promising places to search. What makes these planets even more extraordinary are the extreme temperatures found on the side that forever faces the star. On certain ultra-hot super-Earths and ultra-hot rocky planets, temperatures become so intense that not only metals but even silicate rocks, the very material that forms much of Earth's crust, begin to evaporate. If you are hearing this for the first time, it may sound almost impossible to believe. We naturally think of stone as a symbol of permanence and strength. Mountains endure for millions of years. Rock cliffs withstand countless generations of wind and rain. Yet here, simply because the planet orbits so close to its star, even rock can no longer maintain its familiar form. It becomes vapor. Minerals such as silicates, sodium, and magnesium can evaporate into the atmosphere, forming strange mineral clouds. As temperatures shift within atmospheric currents, some of this material may condense once again, falling back to the surface as a kind of rock rain, a chemical process entirely unlike anything we know on Earth. In a very real sense, the skies of these worlds are made of stone, not solid stone, but stone transformed into vapor. It is astonishing to realize that the very same material can exist in completely different forms simply because its surroundings have changed. Perhaps this is precisely where Carl Gustav Jung's words quietly return. Who looks outside, dreams. Who looks inside, awakes. If we look only outward, we see extraordinary planets with skies of stone and worlds forever divided between endless day and endless night. But if we allow these images to settle gently within us, they begin to resemble beautiful symbols of our own inner lives. Throughout analytical psychology, Jung often spoke of the opposites that exist within every individual: consciousness and the unconscious, persona and shadow, reason and emotion, light and darkness. Yet Jung never regarded one side as entirely good and the other as entirely bad. For him, psychological maturity does not arise from eliminating the darkness. It emerges from learning to recognize and ultimately reconcile both. Perhaps tidally locked planets are quietly telling us exactly the same story. One hemisphere forever bathed in light, the other forever immersed in darkness. If there were only light, the world would become so hot that even stone would evaporate. If there were only darkness, temperatures might fall to unimaginable extremes. Yet it is precisely the narrow meeting place between these two opposites that may offer the greatest possibility for balance. Our own lives often work in much the same way. We naturally try to preserve only pleasant emotions while rejecting every difficult feeling. Yet Jung believed this was nearly impossible. The more we deny one part of ourselves, the more deeply it continues to exist within the unconscious. He once wrote, "One does not become enlightened by imagining figures of light, but by making the darkness conscious." Perhaps no sentence captures the heart of Jungian psychology more clearly. Light alone is not enough to create wholeness. It is by becoming conscious of the darkness that we gradually mature. Seen in this way, a planet divided between eternal day and eternal night becomes an unexpectedly beautiful image, not because it literally resembles the human mind, but because it reminds us that genuine balance is born from allowing opposing realities to coexist. Even distant planets are not made entirely of light. They also need darkness. What I love most about these extraordinary worlds is not their unimaginable temperatures or their skies of vaporized stone. It is the quiet feeling that they gently remind us of the beauty found in diversity itself. Some places never lose the light. Some have never known daylight at all. Some transform stone into clouds. Some build their skies from the very substances that lie quietly beneath our feet here on Earth. The universe has never promised that every world would resemble Earth, just as life has never promised that every human being would resemble one another. Perhaps that is the gentle gift these tidally locked planets wish to offer us tonight. Difference is not nature's mistake. It is simply one of nature's countless expressions of abundance. And as you slowly close your eyes, allowing images of skies made from stone, of one hemisphere bathed forever in light, and another resting endlessly beneath quiet darkness, to drift softly through your imagination, perhaps you may also begin to feel that your own soul contains places of light and places of shadow. There is no need to erase one in order to cherish the other. It is enough to gently recognize that both belong. Together, they make us whole. Just as the delicate boundary between day and night quietly allows a distant world to continue its silent journey through the endless ocean of stars, the most extreme climates in the universe. If there is one lesson our journey has quietly offered so far, perhaps it is this: Earth is not the standard by which the universe is measured. It is simply one possibility among countless others that nature has created throughout more than 13 billion years of cosmic history. We grew up beneath blue skies. We became familiar with cool breezes, white clouds, and rain carrying the gentle scent of the earth. Because of that, it is easy to believe that weather everywhere must resemble our own, at least in some small way. Yet the more astronomers study distant exoplanets, the more they discover worlds where the very idea of weather no longer means what it does on Earth. Tonight, as your breathing becomes slower and your thoughts begin to settle into stillness, imagine our spacecraft quietly drifting among some of the most extreme climates humanity has ever discovered. These are not places where creatures like us could survive. Yet it is precisely their extremity that makes them such remarkable chapters in the universe's endless story. Around certain stars, giant gas planets endure astonishing amounts of radiation every second. The energy is so overwhelming that the outer layers of their atmospheres can no longer remain securely bound. Instead, the gases become intensely heated. They expand and slowly begin escaping the planet's gravity altogether. Through powerful telescopes, astronomers have observed that in some cases, this escaping gas stretches far behind the planet, forming a long, faint tail. At first glance, the image reminds many people of a comet, but this time, it is not a comet. It is a planet, a giant world, leaving behind a trailing stream of gas as though it were slowly dissolving into the darkness of space. It is not a sign of life. It is the visible evidence of a quiet struggle between the planet's own gravity and the relentless energy pouring from its parent star. Yet instead of seeing only loss, perhaps we can also recognize the beauty of transformation. The universe does not preserve everything forever. It continually redistributes matter, energy, and form. Part of a planet's atmosphere drifting away today may someday become part of the interstellar medium in a future unimaginably far beyond our own. Leaving behind those remarkable tailed planets, our imaginary spacecraft continues onward into regions where wind is no longer the gentle moving air we know on Earth. The most extreme climates in the universe. On many ultra-hot exoplanets, especially those that are tidally locked, the temperature difference between the hemisphere that always faces its star and the hemisphere locked in perpetual darkness can reach thousands of degrees Celsius. To redistribute this immense heat, their atmospheres generate enormous global circulation patterns. But enormous here refers to more than their scale. It also refers to their speed. Atmospheric models and spectroscopic observations suggest that on some of these worlds, winds may race at several thousand, even more than 10,000 kilometers per hour, far exceeding the speed of sound under local conditions. These are supersonic winds, more powerful than any storm ever experienced on Earth. Imagine a wind that does more than bend trees. Imagine a wind powerful enough to carry vaporized rock, metal, and mineral particles continuously, from the eternal day side to the everlasting night side of an entire planet. In places like these, wind is no longer simply moving air. It becomes part of the very process that shapes the sky. Here on Earth, when we look upward, we see clouds made of tiny droplets of water or delicate crystals of ice. But on some exoplanets, completely different temperatures and chemical compositions give rise to clouds that sound more like fantasy than astronomy. Some atmospheric models suggest that these clouds are composed of silicate particles, the very materials that make up much of Earth's sand and rock. That means that, from a safe distance, the sky of such a world could be filled with clouds made of sand. On other planets, silicate compounds may condense into microscopic particles resembling molten glass. Driven by supersonic winds, these particles may produce storms or even rainfall made of silicate crystals. In popular science, this phenomenon is often described as glass rain. It is worth remembering that this phrase is a simplified way of illustrating the nature of the condensed material. The actual atmospheric processes occurring on these distant worlds are still being investigated through theoretical models and spectroscopic observations. Even so, simply imagining rain made not of water but of blazing mineral particles is enough to leave us quietly astonished. Then there is hail. Not the hail we know on Earth, where frozen water falls from thunderclouds, but particles condensed from entirely different compounds, forming under pressures and temperatures that stretch far beyond ordinary human imagination. Farther still, on rocky planets orbiting extremely close to their stars, the intense heat prevents the surface from remaining solid. The rocks melt. The crust becomes an ocean of glowing magma. The waves there are not made of water. They are made of liquid stone. Whenever I think about all of these worlds together, I cannot help but feel a profound sense of humility. Here on Earth, we speak of bad weather when heavy rain falls or when summer heat becomes oppressive. Yet somewhere out there are planets whose skies are woven from stone, whose winds outrun the speed of sound, whose seas are made of molten rock, and whose climates operate according to physical conditions our world has never known. Carl Gustav Jung once wrote, "The pendulum of the mind oscillates between sense and nonsense, not between right and wrong." Perhaps what makes this thought so fascinating is its reminder that the boundary between what seems reasonable and what seems impossible shifts as our understanding grows. If someone living 2,000 years ago had heard about clouds made of rock or supersonic planetary winds, they might have dismissed them as myths. Today, science does not claim that every detail has been directly observed. Yet growing evidence suggests that nature is indeed capable of producing phenomena remarkably close to what once existed only in human imagination. Jung was deeply interested in how people respond when confronted with experiences that lie beyond familiar patterns of thought. He believed that whenever we encounter a symbol larger than the conscious mind can easily explain, something within the unconscious begins to stir. Perhaps that is why the universe moves us so deeply. Not because it deliberately hides its secrets, but because it is simply far greater than the mental frameworks we normally use to understand reality. Seen as symbols, these extraordinary planets also seem to reflect the inner climates of our own minds. There are days when the mind is as peaceful as a still lake. There are days when emotions surge like supersonic winds. Sometimes our thoughts become as sharp as shards of glass. At other times, anger quietly simmers beneath awareness like an ocean of molten magma hidden below the surface. From Jung's perspective, the important thing is not to deny these inner weather systems. It is to observe them. Just as astronomers do not try to stop the winds of a distant exoplanet, they patiently seek to understand the laws that govern them. Perhaps we too can learn to observe the changing weather of our own inner world with curiosity instead of fear. As our imaginary spacecraft quietly leaves behind these planets of unimaginable climates, space gradually becomes peaceful once again. Behind us remain worlds with comet-like tails, skies woven from sand, storms of mineral rain, and oceans of glowing magma. Ahead still lie countless mysteries waiting to be discovered. And perhaps, as you slowly drift deeper toward sleep, what lingers with you will not be the image of violent cosmic storms, but a gentle realization that every storm, whether on a distant planet or within our own hearts, follows its own quiet laws. When we understand that, we no longer need to struggle against every movement of life. We can simply observe, as though gazing into a sky filled with stars, where even the most turbulent worlds continue their silent journeys within the vast harmony of the universe. Planets born from death, as our imaginary spacecraft continues its quiet journey through the endless darkness, you may have begun to notice that the universe rarely tells simple stories. Every planet we visit feels like a chapter in an immense book where beginnings and endings are never completely separate. Some worlds are born within cold clouds of cosmic dust. Some are slowly being torn apart by the gravity of their stars, and others carry within them the remnants of the most violent explosions our galaxy has ever witnessed. Tonight, we arrive at one of the most beautiful ideas modern astronomy has revealed. Sometimes, a new planet is born from the death of a star. For us, death often feels like an ending, a door closing, something that can never return. But viewed through the eyes of the universe, the story is different. In nature, very little truly disappears. Matter simply changes form. Energy merely changes the way it is expressed. A star may come to the end of its life, yet the atoms that once composed it continue participating in new stories for billions of years to come. Let us begin with white dwarfs. Most stars in our galaxy, including our own sun, in the unimaginably distant future, will not end their lives in spectacular supernova explosions. Instead, after exhausting their nuclear fuel, they will swell into red giants, before gently casting their outer layers into space. What remains is an incredibly small yet astonishingly dense object known as a white dwarf. Imagine something no larger than Earth, but carrying nearly the entire mass of the Sunday. Its density is so extraordinary that a teaspoon of white dwarf material would weigh thousands of tons if it could somehow be brought to Earth. Yet the real wonder is not only the star itself. The wonder is that, even after the star's brilliant life has seemingly come to an end, planets may continue to exist around it. Some worlds survive the violent red giant phase. Others may form from disks of material left behind during the star's evolution. Scientists are still studying the details of these processes, but years of observations have confirmed that planetary systems around white dwarfs do indeed exist. There is something profoundly quiet about that image. A star has lost the brilliance of its youth, yet around it, worlds continue to move. Much like a forest that quietly prepares for spring after every autumn, without ever feeling the need to hurry. Carl Gustav Jung once wrote, "Life really does begin at 40. Up until then, you are just doing research." Although this quotation is often shared with a touch of humor, it also reflects an idea that runs throughout Jung's work. Maturity is not the end of youth. It is the beginning of a deeper way of living. Perhaps the universe is much the same. A star entering its white dwarf stage may no longer shine as brilliantly as before, yet its story is far from over. If white dwarfs evoke the peaceful silence that follows a long stellar lifetime, then pulsars tell a far more dramatic story. Pulsars, the rhythms left behind by dying stars. A pulsar is a rapidly spinning neutron star. Usually formed after a massive star ends its life in a spectacular supernova explosion. Within just a few seconds, most of the star's structure collapses under its own immense gravity. The remaining core shrinks into an incredibly small yet extraordinarily dense object, spinning dozens or even hundreds of times each second, while emitting steady beams of radio waves that sweep across space like the rhythmic ticking of a cosmic clock. What astonished astronomers is that even around such violent celestial objects, planets can still exist. In fact, one of the very first exoplanets ever discovered, in 1992, was found orbiting a pulsar PSRB 1257+12. That discovery completely changed the way we think about planetary formation. Before then, very few scientists believed that a planetary system could survive or be reborn after the devastating violence of a supernova. Yet once again, the universe proved itself more imaginative than we had ever expected. There are worlds born from explosions we once believed could leave behind only destruction. There are new orbits emerging from the ashes of dead stars. Perhaps this is one of the closest astronomical images to what Carl Gustav Jung described as the process of individuation. In analytical psychology, profound personal transformation often begins when an old structure of the ego is no longer capable of containing who we are becoming. Part of the self must come to an end before a larger, more integrated self can emerge. Jung did not see this as failure, but as growth. He once wrote, "There is no coming to consciousness without pain. This is not a celebration of suffering. Rather, it is an acknowledgement that many of life's most important shifts in awareness arrive alongside changes that initially feel difficult to accept." In much the same way, a supernova marks the end of a star's life, but it also creates the conditions that scatter heavy elements, such as iron, calcium, gold, and uranium, throughout space, providing the raw materials from which future generations of stars and planets will eventually form. Even more extraordinary is the possibility of diamond planets. Under the extreme pressures and temperatures surrounding certain stellar remnants and exotic binary systems, scientists have proposed that some planets may contain enormous amounts of carbon crystallized into diamond-like structures on a planetary scale. One of the best-known candidates is PSRJ 1719, 1438b, often referred to in popular media as the Diamond Planet. While this nickname is a simplification and its exact composition remains under investigation, current models suggest that it may be the carbon-rich core left behind after a star lost its outer layers through interactions with its pulsar companion. It is fascinating to think that on Earth, a single diamond has long symbolized beauty, endurance, and permanence. Yet somewhere in the universe, there may exist an entire world fashioned from the exposed heart of a dead star. That thought brings to mind one of Jung's most beautiful observations. In all chaos there is a cosmos, in all disorder a secret order. Perhaps nowhere is this idea reflected more clearly than in the life cycles of stars. What we call the death of a star is, from the universe's perspective, simply one stage in the endless recycling of matter. No atom truly disappears. No story is ever completely finished. There are only new forms of existence waiting to be written. Seen this way, planets born from stellar remnants are not merely fascinating astronomical objects. They are quiet reminders that endings and beginnings are sometimes nothing more than different names for the same unfolding process. Some seasons of life must come to a close before others can begin. Some old dreams must be gently released so that new aspirations have room to grow. Some earlier versions of ourselves must quietly fade away so that tomorrow's self can become wiser, deeper, and more complete. Of course, this is only a symbolic parallel. Astronomy studies stars through the language of physics, while Jung explored the human mind through analytical psychology. Neither discipline proves or replaces the other. Yet sometimes the images offered by the universe allow us to feel movements within the human soul that are otherwise difficult to describe. As our imaginary spacecraft slowly leaves behind the white dwarfs, the pulsars, and the planets born from the remnants of ancient stars, countless distant lights continue shining softly behind us against the darkness. And perhaps the greatest gift of this part of our journey is not the vision of enormous diamonds drifting through space, but a far gentler realization. In the universe, as in life, endings are not always the opposite of beginnings. Sometimes what seems to have been lost quietly becomes the foundation for an entirely new world, a new understanding, or a deeper version of the person we are gradually becoming. Planets with no solid ground. As our journey carries us deeper among the universe's strangest worlds, we begin to realize that many things we once considered universal are, in fact, true only here on Earth. We are accustomed to every step landing upon solid ground. We build our homes on rock. We plant seeds in soil. We sit beside the sea, comforted by the quiet certainty of the planet beneath our feet. Since the day we were born, the feeling of having solid ground below us has been so natural that we rarely stop to think about it, but travel far enough beyond Earth, and we encounter worlds where the very idea of ground almost disappears. Tonight, let our imaginary spacecraft drift gently toward the giant gas planets, worlds that, from a great distance, appear as beautifully perfect spheres floating silently in the darkness. They possess clouds, storms, magnificent bands of color wrapped around their equators. At first glance, they seem like places where we might someday land and begin exploring. Yet beneath that familiar appearance lies a profoundly different reality. If you could approach a world like Jupiter, Saturn, or one of the many giant exoplanets beyond our solar system, you would never discover a solid surface in the way we understand it. There are no fields, no rocky mountains, no beaches, no place to take a very first step. Instead, there are immense layers of gas stacked one upon another, extending tens of thousands of kilometers deep into the planet's interior. The farther you descend, the greater the pressure becomes. The gas grows denser, hotter, heavier. The boundary between gas and liquid gradually fades away, and matter enters states that scarcely exist anywhere on Earth. One of the most fascinating aspects is that even scientists cannot point to a clearly defined surface on these worlds. There is no sharp line where one could confidently say, below this point, the ground begins. Instead, everything changes gradually, through an unbroken transition between layers of matter, under increasingly extreme pressures and temperatures. If a spacecraft could descend into the atmosphere of one of these giant planets, it would never suddenly touch solid ground. It would simply continue sinking and sinking. The pressure would continue rising, the temperature would continue climbing, until eventually the spacecraft itself could no longer withstand the unimaginable forces surrounding it. It is a strangely beautiful thought. A world many times larger than Earth, yet with nowhere to stand. Perhaps it is precisely this paradox that gives giant gas planets such a unique emotional quality. They remind us that what we have always considered the foundation of existence may simply be a local experience, something true only on the particular world we happen to call home. Carl Gustav Jung once wrote, "Every form of addiction is bad, no matter whether the narcotic be alcohol, morphine, or idealism." At first glance, this quotation seems unrelated to astronomy. Yet read more slowly, it points toward one of the mind's deepest habits, our tendency to cling. We naturally seek familiar patterns, stable structures, foundations that make us feel safe. When confronted with planets that possess no solid ground, we experience an instinctive unease, because the reference point upon which our consciousness depends simply no longer exists. Perhaps the same thing happens within our inner lives. There are seasons when we feel as though we are walking upon firm ground. Everything has a plan. Everything seems predictable. But there are also times when life resembles drifting through the atmosphere of a giant gas planet. No clear answers remain. No familiar foundation exists. We no longer know where our own ground is. In analytical psychology, Jung did not see such periods as entirely negative. He believed that many profound transformations begin precisely when the old structures of the ego are no longer capable of explaining our experience. During these moments of apparent uncertainty, we are given the opportunity to discover deeper dimensions of ourselves. The study of giant planets follows a remarkably similar path. At first, astronomers could see only clouds. Then spectroscopy revealed the composition of their atmospheres. Later came models describing their temperatures, pressures, and internal structures. The deeper we explore, the more mystery we encounter. Yet it is precisely that mystery that makes exploration worthwhile. Hidden within the dense interiors of giant planets lies one of the strangest forms of matter known to science. Under immense pressure, hydrogen, the lightest element in the universe, can transform into what physicists call metallic hydrogen. It no longer behaves like the familiar gas we know on Earth. Instead, it becomes an electrically conductive fluid. Scientists believe that this remarkable layer plays a central role in generating Jupiter's extraordinarily powerful magnetic field. There is something deeply fascinating about that. Even the simplest element in the periodic table can become something entirely different when its environment changes enough. Perhaps human beings are not so different. Circumstances may not alter our deepest nature, but they often reveal possibilities that would otherwise remain forever asleep. Jung once wrote, "The privilege of a lifetime is to become who you truly are. This is not advice to become someone else. Quite the opposite. It is a reminder that the work of a lifetime is not to build a perfect mask, but to slowly uncover our authentic self." The giant planets tell a remarkably similar story. From the outside, they resemble familiar worlds. Yet, the deeper we journey into them, the more every assumption begins to dissolve. What seemed to be a surface turns out to be only clouds. What seemed to be gas gradually becomes liquid. What appeared to be the end of the atmosphere is merely the beginning of even deeper layers of matter. Perhaps the human psyche possesses a similar architecture. We know the outermost layers quite well. Our daily thoughts, our easily named emotions, our social roles, the persona, as Jung called them. But as we descend farther inward, We encounter regions less frequently illuminated by consciousness, memories, symbols, the personal unconscious, and deeper still, the collective unconscious, where Jung believed humanity's archetypal images have dwelled since ancient times. There is no sharp boundary between these layers, just as there is no clearly defined ground inside a giant gas planet. Everything changes gradually, naturally, almost imperceptibly. Perhaps that is why these extraordinary worlds fill me not with fear, but with peace. They remind us that not everything requires a visible foundation in order to endure. Some worlds remain stable without solid ground. Some planets continue orbiting their stars for billions of years without ever possessing a surface upon which anyone could stand. And perhaps our own lives are sometimes like that. There are moments when we do not need immediate answers. We do not need to understand everything at once. We do not need to know exactly where our own ground lies. We need only continue moving, continue observing, continue trusting that, like the giant planets drifting silently through the universe, true stability sometimes comes not from having firm ground beneath our feet, but from recognizing that we already belong to a far greater orbit. And perhaps, with that thought gently settling into the mind, the burdens of the day become a little lighter, floating away like the vast cloud layers slowly drifting across the endless skies of a world that has never known solid ground. Records of time. If there is one lesson the universe has been quietly teaching us since the beginning of this journey, it is this: time is not a single, universal river. Here on Earth, we are accustomed to the rhythm of sunrise and sunset, of 4 changing seasons, of years measured by our orbit around the Sunday. We organize our lives with calendars, clocks, birthdays, and anniversaries. A year is 365 days. A human lifetime spans only a few decades. Everything seems clear, familiar, and wonderfully stable. But once we leave our small home and begin looking toward distant planetary systems, we discover that the very idea of time is every bit as diverse as the universe itself. Tonight, let our imaginary spacecraft drift quietly among worlds that hold some of the most extraordinary records of time ever discovered. There are planets whose entire year passes more quickly than a full night's sleep. There are worlds that have existed since nearly the dawn of our galaxy. And there are planets that still quietly radiate the leftover warmth from the day they were born, as though the memory of their creation continues to glow deep within them. Let us begin with planets whose years are astonishingly short. On Earth, we require more than 365 days to complete one orbit around the Sunday. That defines what humanity has called a year for thousands of years. Yet some exoplanets orbit so extraordinarily close to their stars that they complete an entire revolution in only a few hours, or roughly a single Earth day. One remarkable example is K2137b, a rocky exoplanet that circles its star in just over 4 hours. That means while you leisurely read a book one quiet evening, that distant world has already experienced almost an entire year, at least by an astronomer's definition. At first, this may seem like nothing more than an interesting number, but if we pause for a moment, it gently reminds us that a year has never been an absolute unit of time. It is simply the time required for a planet to complete one orbit around its star. For Earth, that journey lasts about 365 days. For some exoplanets, only a few hours. For worlds orbiting far from their stars, a single year may stretch across hundreds or even thousands of Earth years. Suddenly, the measurements we once believed to be fixed become wonderfully fluid. Carl Gustav Jung once wrote, "Time is a child playing like a child playing a board game. The kingdom belongs to the child." When Jung quoted these words, he was drawing upon the philosophy of the ancient Greek thinker Heraclitus to reflect on the ever-changing nature of existence. Whether viewed through philosophy or astronomy, the idea quietly suggests something beautiful. Time is more than numbers on a clock. It is inseparable from motion. from change, and from the perspective of the one observing it. Leaving behind these worlds with astonishingly brief years, our spacecraft continues toward a planet of an entirely different kind, a world so ancient that it almost defies imagination. Within our galaxy exists a planet believed to be more than 12 billion years old, PSRB 1626b, often called Methuselah, after the biblical figure renowned for his extraordinary longevity. Current estimates place its age at approximately 12.7 billion years, making it one of the oldest known planets in existence. Try to imagine that. When Earth did not yet exist, when our sun had not yet been born, when our solar system was nothing more than scattered atoms drifting through the Milky Way, that distant planet was already quietly following its orbit. It has witnessed countless generations of stars being born and fading away. It has traveled through eras when our galaxy itself was still young. It existed long before Earth's first oceans formed. There is something profoundly peaceful about that thought. A planet quietly circling for billions of years, without needing anyone to know its name, without needing praise, without needing to be remembered. It simply continues moving according to the quiet laws of the universe. It reminds me of one of Jung's most memorable reflections. The least of things with a meaning is worth more in life than the greatest of things without it. Perhaps meaning is not measured by how long something exists, but by how every existence contributes to the larger story of the universe. An ancient planet is not precious merely because of its age. It is precious because it reminds us that the history of the cosmos extends unimaginably farther than the history of humanity. Its quiet existence expands our sense of time, making many of our everyday worries seem just a little smaller. Yet another remarkable story remains. Some planets, despite forming billions of years ago, continue radiating heat left over from the very process of their birth. When a giant planet forms, enormous amounts of material fall inward under gravity. That process releases tremendous energy, heating the young planet. Afterward, it cools only very slowly, much like a large ember that continues glowing long after the fire itself has faded. For especially young and massive planets, this internal heat remains so strong that modern telescopes can directly observe their infrared glow. In a sense, these worlds still carry the thermal memory of the day they were born. There is something deeply beautiful about that idea. A planet carrying the warmth of its past across millions of years. Not because it refuses to let go, but because what once happened continues, quietly, to shape what it is today. Perhaps human beings are not so different. None of us is entirely separate from our past. Childhood memories, meaningful encounters, moments of joy, moments of grief, all leave their quiet traces within us. Jung did not believe the past was a prison. Rather, he believed that recognizing the unconscious influence of our past is an essential part of becoming whole. He once wrote, "Until you make the unconscious conscious, it will direct your life, and you will call it fate." This does not mean that the past completely determines the future. It simply reminds us that what remains unseen within us can continue shaping our choices until we become aware of it. Viewed through that lens, planets still glowing from their formation become gentle symbols. They are not living in the past, yet the past still exists within them, transformed into lingering warmth. Human beings do not need to reject their own histories. We simply need to understand them, just as astronomers study infrared light to uncover the story of a planet's birth. We can listen to our memories, our dreams, and the symbols rising from within, to better understand the journey of our own lives. Perhaps this is the most beautiful lesson these cosmic records of time have to offer. A year may last only a few hours. A planet may survive for more than 12 billion years. A world may still carry the warmth of the day it was born. Time is not measured by a single universal ruler. Every planet lives according to its own rhythm, and perhaps every human life does as well. No one grows according to the same schedule. No one needs to bloom during the same season. No one is required to compare the pace of their journey with anyone else's. As our imaginary spacecraft quietly leaves these remarkable worlds behind, countless silent stars still stretch across the darkness ahead. And perhaps, as you slowly drift towards sleep tonight, what remains with you will not be the numbers billions of years or merely a few fleeting hours, but a gentle feeling of peace. In this vast universe, every world moves according to its own measure of time, and every soul follows its own quiet path, growing, transforming, and gradually becoming who it is meant to be, neither too early nor too late, but precisely in the moment that life has quietly chosen. Strange worlds beneath the surface. After journeying together through planets where time flows according to vastly different rhythms, perhaps it is now time for an even quieter voyage, not outward, into the endless reaches between the stars, but inward, into the hidden interiors of the planets themselves. For sometimes, the greatest wonders of a world are not found upon the landscapes our eyes can see, but are quietly concealed within depths that no ray of light has ever reached. Human beings have always been fascinated by surfaces. We look at mountains, oceans, and clouds, believing we understand a planet. Yet just as Carl Gustav Jung repeatedly reminded us that consciousness represents only a small portion of the human psyche, modern astronomy has revealed that much of a planet's true story lies in places we cannot observe directly. Tonight, imagine our imaginary spacecraft not flying through an atmosphere, but gently descending into the heart of a distant world. At first, we pass through layers of clouds. Then the atmosphere grows steadily denser. Pressure rises. Little by little, temperature quietly changes. The deeper we travel, the more familiar forms of matter begin transforming into states that scarcely exist anywhere on Earth. One of the most remarkable examples is the existence of high-pressure ice. When we hear the word ice, we naturally think of cold, floating icebergs near the poles, snow resting upon mountain peaks, ice cubes slowly melting in a glass on a warm summer afternoon. But elsewhere in the universe, water has far more than one way of becoming ice. Hundreds or even thousands of kilometers beneath the oceans of water-rich planets, pressure increases so enormously that water molecules are forced into extraordinary crystalline arrangements. What makes this especially fascinating is that these transformations do not necessarily require freezing temperatures. Under immense pressure, water can exist as exotic crystalline phases such as Ice VI, Ice 7, and several others, even at temperatures far above the freezing point we know on Earth. It is a remarkable thought. The substance is still water, yet simply because the surrounding conditions have changed, it exists in an entirely different form. Perhaps human beings are not so different. Life's experiences do not necessarily change our deepest nature, but they can profoundly change how that nature expresses itself. Someone who has endured great hardship no longer responds to the world exactly as they once did, not because they have become someone entirely different, but because the pressures of life have quietly rearranged what was always present within them. Carl Gustav Jung once wrote, "I am not what happened to me, I am what I choose to become." Although these words are often remembered as a declaration of inner freedom, they also remind us that circumstances never tell the whole story of who we are. Just as water remains water beneath enormous pressure, even while existing in a completely different structure, as we continue descending, we encounter another extraordinary class of exoplanets, known as hot Jupiters. In our own solar system, Jupiter orbits more than 700 million kilometers from the Sun, and the outer layers of its atmosphere remain comparatively cool. Hot Jupiters, however, circle astonishingly close to their parent stars, so close that an entire year may last only a few days. At such distances, these planets endure unimaginable amounts of stellar energy. Their atmospheres are continually heated. Supersonic winds relentlessly transport heat from the permanent day side to the eternal night side. In many cases, the immense gravitational pull of the nearby star even distorts the planet itself, stretching it away from a perfectly symmetrical shape. At first glance, we often imagine that a planet simply travels around its star, but the relationship is far deeper than that. A star does far more than provide light. It shapes climate. It shapes temperature. It shapes atmospheric structure. It shapes the very pace of a planet's evolution. In some extreme systems, gravity even strips material away from the planet itself, drawing it slowly toward the star. This brings us to one of astronomy's most beautiful ideas: gravitational interaction. We often picture gravity as an invisible force pulling objects together. In reality, gravity is an ongoing conversation between celestial bodies. Every object influences another. The planet affects the star. The star affects the planet. Every movement leaves its trace. Every orbit represents the accumulated result of interactions unfolding across millions of years. That reminds me of one of Jung's most famous observations. The meeting of two personalities is like the contact of two chemical substances. If there is any reaction, both are transformed. Jung was speaking about human relationships, yet it is fascinating to realize that something remarkably similar unfolds throughout the universe. No planet exists entirely apart from its star. No star remains completely untouched by the worlds orbiting around it. Each participates in an ongoing relationship in which both contribute to the balance of the entire system. Perhaps people are much the same. Every encounter leaves behind a trace. Some people enter our lives for only a single day. Others remain beside us for years. Some bring peace. Some bring challenge. But very few encounters leave both people exactly as they were before. Jung repeatedly emphasized that we mature through relationship, not by isolating ourselves from the world, but by becoming conscious of how we are continually changing through our connections with others. Viewed this way, the internal structures of planets become gentle symbols. From the outside, many worlds may appear remarkably similar, yet inside, each carries an entirely unique history. Some possess rocky cores. Some conceal vast layers of high-pressure ice. Some contain enormous oceans of metallic hydrogen. Some still preserve the lingering warmth from the day they first formed. No two planets are exactly alike. The same is true of human beings. Two people may grow up in the same city, within the same family, even experience events that appear almost identical. Yet the architecture of their inner worlds is never truly the same. Every memory, every dream, every fear, every hope quietly shapes the unique core of each soul. Carl Gustav Jung once wrote, "Who looks outside, dreams. Who looks inside, awakes." Perhaps that is why these words have returned again and again throughout our journey. Because every time we discover another distant world, the greatest mystery is never merely its sky, or its storms, or the beauty visible upon its surface. Tidally locked worlds. Perhaps, throughout our journey so far, no worlds have invited me to pause for quite as long as the tidally locked planets. Not because they are the most violent places we have visited, nor because they hold the universe's most astonishing records. What makes them unforgettable is something quieter. A silence that has endured for millions, even billions of years. A world where time itself seems to have forgotten how to create sunrise and sunset. Here on Earth, we rarely stop to appreciate the quiet miracle of the daily cycle between light and darkness. Each morning, the sun slowly rises above the horizon. Its light spreads gently across treetops, rooftops, and roads still glistening with the night's dew. By evening, the sky softens into gold and crimson, before darkness gradually embraces the world once again. This rhythm has repeated itself billions of times since Earth first formed. It has become so familiar that we scarcely recognize it as one of nature's greatest wonders. Yet somewhere among the distant stars, there are planets that have never known such a rhythm. These worlds orbit remarkably close to their parent stars. Over millions of years, the star's powerful gravity gradually slowed the planet's rotation until it reached a perfect balance. Since that moment, one hemisphere has remained forever facing its star, while the other has remained forever turned away. Astronomers call this phenomenon tidal locking, and it is thought to be common among many of the exoplanets discovered in recent decades. Imagine standing upon the hemisphere that always faces the star. You would never witness a sunrise, because the star has never set. It hangs motionless in the sky, day after day, millennium after millennium. There is no morning to awaken the world, no afternoon announcing the close of another day, only endless light. Beneath that relentless radiation, the ground, if the planet is rocky, may become so hot that stone itself begins to soften, while minerals evaporate into the atmosphere. On gaseous worlds, fierce convection currents and supersonic winds endlessly carry heat from the eternal day side toward the eternal night side. Here, light is no longer the gentle promise of a peaceful morning. It is an inexhaustible source of energy, unceasing, unresting, unyielding. But as our imaginary spacecraft slowly crosses toward the opposite hemisphere, everything changes. The star disappears, not because it has set, but because, from this side of the planet, it has never risen. Ahead lies only profound darkness. No dawn, no first rays of sunlight, no shadows slowly shifting with the passage of time. On many tidally locked planets, temperatures on the night side may fall hundreds of degrees below zero. If the atmosphere is thin enough, that hemisphere may become a world locked in perpetual ice. Gases may even freeze onto the surface itself. Movement slows beneath the quiet reign of endless darkness. What is extraordinary is that these two vastly different worlds, one blazing with eternal light, the other frozen beneath eternal night, exist upon the very same planet, separated by only a few thousand kilometers, yet as different as two entirely separate universes. Perhaps that image brings to mind one of Carl Gustav Jung's most important insights. He never viewed human beings as creatures made only of light, nor did he believe darkness was something to be eliminated. Throughout his writings, Jung emphasized that the human psyche is shaped by opposing forces held together in dynamic balance. He once wrote, "One does not become enlightened by imagining figures of light, but by making the darkness conscious." Perhaps no astronomical image illustrates this idea more beautifully than a tidally locked world. One hemisphere lives forever in light, the other lives forever in darkness. If we looked only at the illuminated side, we would never understand the whole planet. If we stood only in the darkness, we would know only half its story. To understand the world completely, we must accept the existence of both. Jung described this as the movement toward wholeness, not by erasing the difficult parts of ourselves, but by recognizing them, accepting them, and learning to live alongside them. Of course, astronomy does not prove psychology, just as psychology does not explain gravity. The two disciplines explore entirely different realities. Yet the images offered by the universe sometimes help us feel more deeply what unfolds within our own inner lives. There are days when we resemble the sunlit hemisphere, always busy, always moving, always shining, always striving to remain strong. Yet there are other seasons when the mind resembles the dark side of the planet, quiet, reserved, withdrawn, longing for solitude, longing simply to rest after many long months. The beautiful truth is that both states belong to the same person, just as both hemispheres belong to the same world. Climate models suggest that many tidally locked planets possess one particularly fascinating region. It lies between everlasting daylight and everlasting night. Astronomers call it the terminator zone, a narrow belt of perpetual twilight where the star forever rests upon the horizon. It never fully rises. It never completely sets. If the atmosphere is sufficiently thick, this narrow region may offer the planet's most moderate conditions, where warmth from the day side and cold from the night side gently balance one another. There is something quietly beautiful about that. The place between two extremes may be the most hospitable of all. Perhaps human life is much the same. We often search for answers at the extremes, perfect or broken, strong or weak, right or wrong. Yet Jung repeatedly suggested that psychological maturity does not come from choosing one extreme while rejecting the other. It arises through integration, through our capacity to hold the tension between opposites without rushing to destroy either one. He once wrote, "The pendulum of the mind oscillates between sense and nonsense, not between right and wrong." Perhaps that gentle rhythm resembles the eternal twilight of a tidally locked world. Not endless daylight, not endless darkness, but a quiet place where opposites meet, where balance is possible, where understanding slowly grows, and where, perhaps, both planets and people discover the deepest kind of peace. Red dwarf stars. Perhaps the mind is much like a pendulum, forever swinging between different states. The important thing is not to force it into stillness, but to learn to observe its movement with quiet calm. Whenever I think about tidally locked planets, I find them deeply peaceful. There is no sunrise, no sunset, no obvious transition between day and night. Yet none of this makes them any less extraordinary. They simply exist according to a rhythm unlike anything Earth has ever known. Perhaps that is the gentle gift this part of our journey wishes to offer you before sleep draws a little closer. You do not have to live in the light all the time, nor do you need to fear the darker regions of your own soul. Just as a tidally locked planet continues its steady orbit around its star for billions of years, every human being carries both light and shadow within. And perhaps the most peaceful place does not lie entirely on either side, but within the gentle twilight between them, where we slowly learn to embrace ourselves completely, with kindness, and no longer feel the need to wage war against our own hearts. Red dwarf stars. When we look up at the night sky on a clear evening, most stars appear as soft white points of light. To the naked eye, it is difficult to recognize that each star possesses its own unique character. Some are dozens of times larger than our Sunday. Others quietly shine with only a small fraction of its energy. And then there are the tiny red stars that, if placed beside the sun, would resemble a small lantern standing next to a great lighthouse. Tonight, our imaginary spacecraft drifts quietly toward the red dwarfs, the most common type of star in the Milky Way. It is fascinating to realize that most stars in our galaxy are not like our Sunday. They are red dwarfs, smaller in mass, cooler at the surface, and much dimmer in visible light. At first glance, they might seem gentle, quiet, and remarkably calm. But, as with so many things in the universe, appearances never tell the whole story. Although they are smaller than the Sun, many young red dwarfs possess extraordinarily powerful magnetic activity. They frequently unleash violent stellar flares, releasing enormous amounts of X-rays, ultraviolet radiation, and high-energy particles into space. For planets orbiting close enough to receive sufficient warmth and light, these bursts of radiation can present a significant challenge. Imagine standing on a planet orbiting one of these red stars. The star overhead is not as brilliant as our Sunday. Its light glows with a soft crimson hue. At first, the landscape might feel wonderfully peaceful. Then, without warning, the star erupts, not with a sunrise, but with an immense explosion of energy. Within moments, the planet may receive many times the radiation it normally experiences. If it lacks a strong magnetic field or a sufficiently thick atmosphere, its atmospheric molecules could gradually be stripped away over time. This is one of the reasons astronomers pay such close attention when evaluating the habitability of planets orbiting red dwarfs. It is important to remember, however, that this does not mean planets around red dwarfs cannot support life. Quite the opposite. Because red dwarfs burn their fuel incredibly slowly, potentially surviving for trillions of years, according to current stellar models, they remain among the most promising places in the search for habitable worlds. The real question lies in achieving the right balance between orbital distance atmospheric protection, planetary magnetic fields, and the activity level of the star itself. Perhaps this offers us another gentle reminder that, in the universe as in life, a gentle appearance does not always reveal an object's true nature. Carl Gustav Jung once wrote, "Knowing your own darkness is the best method for dealing with the darknesses of other people." Jung was speaking about human beings, not stars. Yet his words invite a similar reflection. The goal is not to deny the powerful energies that exist within us, but to understand them. A red dwarf is not bad because it produces violent stellar flares. That is simply how it exists according to the laws of physics. Human beings are much the same. Each of us carries different emotional energies within. Only by understanding them can we truly live in harmony with ourselves. As our journey continues, we encounter another fascinating phenomenon: planetary migration. Many of us learned as children that planets form and remain forever where they were born. Over the past few decades, however, astronomers have discovered that reality is far more dynamic. Many planets do not stay where they first formed. During the early stages of a planetary system, gravitational interactions with the surrounding disk of gas and dust, or with neighboring planets, can dramatically reshape planetary orbits. A giant planet may begin life far from its star before slowly spiraling inward over millions of years. This process is known as planetary migration. There is something beautiful about that idea. A world does not have to remain forever where it was born. It can move. It can discover an entirely different orbit. It can become part of a new celestial arrangement. One of the most famous results of this process is the existence of the hot Jupiter's gas giants, comparable to or even larger than Jupiter, that orbit astonishingly close to their stars. According to current models, most of them probably did not form where we see them today, since regions so close to a star generally lack the conditions needed to build giant gas planets. Instead, they likely formed in colder, more distant regions, before gradually migrating inward. This discovery transformed our understanding of planetary systems. Our solar system is no longer viewed as the universal template. Every stellar system may possess its own unique history. Every planet may have traveled an extraordinary journey before arriving at the orbit we observe today. Perhaps that is not so different from the story of every human life. We often meet someone in the present and unconsciously assume they have always been this way. But, like a hot Jupiter, every person carries a long history behind them. Moments of change, unexpected turning points, partings, difficult choices, quiet decisions that gradually guided them toward the place where they now stand. Carl Gustav Jung once wrote, "The privilege of a lifetime is to become who you truly are." Notice that Jung did not say we are simply born as our true selves. He chose the word become. It is a process, not an instant destination. In analytical psychology, maturity unfolds through the continual transformation of consciousness, through confronting the unconscious and slowly integrating the many different parts of ourselves. In a way, planets tell a remarkably similar story. They do not always remain where they began. They move, they interact, they reshape their orbits, and through those quiet journeys, they create the astonishing diversity of planetary systems scattered throughout our galaxy. What I love most about red dwarf stars is not their color, it is their patience. A red dwarf may live far longer than the current age of the universe itself. While massive stars blaze brilliantly before exhausting their fuel in a relatively short time, red dwarfs consume their energy slowly, quietly, and with extraordinary endurance. Perhaps that is the gentlest lesson they offer us before the night grows deeper. Not everything of value must shine brilliantly. Not every journey must unfold quickly. Some stars glow softly for trillions of years. Some planets spend millions of years drifting before finally finding a stable orbit. And perhaps human beings are much the same. You do not need to measure your pace against anyone else's. You do not need to rush toward a perfect version of yourself. Like planets patiently finding their place within invisible fields of gravity, each of us is gradually discovering the orbit that truly belongs to us. That journey may take longer than we once hoped, yet perhaps that is precisely what gives it such depth. As that thought settles quietly into your mind, the sky, filled with countless red stars, begins to feel wonderfully peaceful, as though each tiny light is gently reminding us that every life unfolds according to its own rhythm, and that no light is ever too small, so long as it continues to shine faithfully within the vast darkness of the universe. Exomoons and crowded planetary systems. When we gaze into Earth's night sky, perhaps the celestial companion closest to our hearts is the moon. For tens of thousands of years, humanity has looked upon it with countless emotions. As the gentle lantern of the night, as the silent clock that measures the tides, the seasons, and the rhythm of ancient stories. Across many cultures, the moon has never been merely a celestial body. It has also become a symbol of intuition, dreams, and the quietest corners of the human soul. Perhaps that is why, when astronomers first began asking whether moons might exist beyond our solar system, the question carried more than scientific curiosity. It awakened a beautiful possibility that distant worlds, too, might have silent companions, just as Earth does. Tonight, our imaginary spacecraft takes us to one of the newest frontiers of modern astronomy: exomoons. Moons that orbit planets beyond our solar system. To this day, scientists have confirmed thousands of exoplanets. Yet, the search for exomoons remains extraordinarily difficult. The reason is simple. If an exoplanet is already incredibly small and unimaginably distant, then its moons are even harder to detect. Astronomers continue to study several promising candidates, including the signal associated with Kepler 1625b. But so far, the existence of exomoons still awaits definitive confirmation through additional observations. That means we now find ourselves standing at one of the most fascinating boundaries in astronomy, the place where established knowledge meets ongoing discovery. And perhaps it is precisely along that boundary that human imagination flourishes most beautifully. Imagine a moon orbiting a giant planet thousands of light years from Earth. Suppose, purely as an exercise of imagination, that an observer stood upon that distant moon. Looking upward, they might see an enormous planet suspended overhead, many times larger than the moon appears from Earth. That giant world might not rise and set across the sky as our moon does. If the moon itself were tidally locked, its parent planet could remain almost motionless above the horizon. The reflected light from that colossal world would create nights unlike any we have ever known. Different rhythms of time, and perhaps entirely different myths, if a civilization had ever existed beneath that sky. The thought alone makes the universe feel infinitely larger. Yet there is another planetary system even more extraordinary. A place where worlds do not simply exist beside one another. They almost seem to live together. That place is TRAPPIST-1. Located about 40 light-years away, this remarkable red dwarf system is famous for hosting 7 rocky planets, roughly comparable in size to Earth. What astonished astronomers was not merely the number of planets, but how closely they orbit one another. In our own solar system, immense distances separate the planets, but within TRAPPIST-1, all 7 planets orbit so close to their star that the entire system could fit comfortably inside Mercury's orbit if it were placed within our solar system. Pause for a moment and imagine that. If you were standing on one of the TRAPPIST-1 planets and looked into the sky, the neighboring worlds might appear far larger than Venus or Mars ever does from Earth. They would not simply be tiny points of light. At the right moments, they could appear as unmistakable worlds, their disks clearly visible as they drift gracefully across the heavens. Perhaps such a sky would make its observer feel that they were never truly alone. Every world would see the others. Every planet would become part of another planet's sky. Even more remarkable is the way these planets move. Their motions are not chaotic. Instead, they participate in one of astronomy's most elegant phenomena: orbital resonance. This means that the planet's orbital periods are linked through beautifully balanced ratios. As one planet completes a certain number of revolutions, another completes its own according to a corresponding rhythm. That intricate resonance helps preserve the long-term stability of the entire planetary system. Whenever I think about this, I cannot help but feel as though I am listening to a symphony. Each planet is like a musical note. No note performs entirely alone. No note tries to overpower the others. Together, they exist because of the harmony of the entire composition. Carl Gustav Jung once wrote, "The meeting of two personalities is like the contact of two chemical substances. If there is any reaction, both are transformed." He was speaking about human beings. Yet it is difficult not to think of systems like TRAPPIST, one while reading those words. No planet truly exists in complete isolation from the others. The gravity of every world quietly influences its neighbors. Every movement leaves its mark. Every orbit is the result of an exquisitely delicate balance. Our own lives are not so different. No one truly grows alone. Every meeting, every conversation, every friendship, every farewell quietly alters the orbit of a human life. Of course, this is only a symbolic comparison. Planets obey the laws of physics, while human beings are shaped by psychology, culture, relationships, and lived experience. The two fields neither prove nor explain one another. Yet sometimes, the images offered by the universe help us feel the beauty of connection more deeply. Jung devoted much of his work to the concept of the self, the integrated wholeness of the human psyche. He believed that a person is not merely a collection of disconnected parts, but a living system constantly seeking balance among its many dimensions. Whenever I think about that idea, I remember TRAPPIST. 1. A crowded planetary system. A system that appears almost impossibly compact, yet not chaotic. Quite the opposite. Its harmony emerges precisely because of resonance. Perhaps life is much the same. Many of us imagine that peace comes only when life becomes simple. But sometimes peace does not arise because little is happening. It arises because the many things that are happening have found a way to exist together in harmony. Jung once wrote, "In all chaos there is a cosmos, in all disorder a secret order." Perhaps no quotation captures the beauty of systems like TRAPPIST. One more perfectly. At first glance, 7 planets orbiting so closely together might seem like a recipe for instability. Yet the mathematics of gravity transforms that apparent complexity into a stable architecture capable of enduring for billions of years. What I love most about this part of our journey is not the orbital periods or the astronomical distances. It is the quiet realization that the universe has never encouraged isolation. Even planets exist only through relationships with other celestial bodies. Moons accompany planets. Planets accompany stars. Stars gather into galaxies. Galaxies become part of the immense cosmic web stretching across the universe. Perhaps humanity belongs within that same grand symphony. No one is truly an island. No one becomes who they are entirely alone. Every word of encouragement, every embrace, every meaningful encounter acts like a tiny force of gravity, gently adjusting the orbit of a human life. As our imaginary spacecraft slowly leaves the TRAPPIST, one system behind, those 7 remarkable planets will continue circling their small red star in the graceful rhythm they have maintained for billions of years. And perhaps, as sleep gradually draws nearer, what remains with you will not be technical terms like exomoon or orbital resonance, but a quiet sense that this vast universe is woven together by countless invisible connections. Just as the human soul, even in moments when it feels profoundly alone, is always held gently and silently by the unseen orbits of love, memory, and the encounters that have gradually shaped us into the people we are still becoming. Planets around dying stars. Perhaps no chapter in the story of the universe leaves us feeling both so small and so peaceful as watching the aging of the stars. Here on Earth, We usually measure time by the span of a human life. A lifetime lasts only a few decades, and only rarely stretches beyond a century. But for stars, time is measured in billions of years. They, too, have their youth, their brightest years, and eventually they quietly enter old age. What is remarkable is that even as a star approaches the end of its journey, the story of the planets surrounding it is far from over. Tonight, we will visit worlds that still live beneath the light of aging stars, places where beauty and fragility exist together in a slow and graceful symphony of the cosmos. Let us begin with the image of a red giant star. Astronomers tell us that when a star like our Sun gradually exhausts the hydrogen fuel in its core, it does not simply fade away. Instead, its outer layers begin to expand, its surface temperature decreases, and its light takes on a softer, orange-red glow. The star grows enormously in size. Seen from afar, it appears to bloom across space slowly, patiently, and irreversibly. One day, roughly 5 billion years from now, our own Sun will enter this stage. When that day comes, the sky of our solar system will be transformed forever. Mercury will almost certainly be engulfed. Venus will most likely share the same fate. As for Earth, its ultimate destiny is still being studied. But there is little doubt that the familiar environment we know today will no longer exist. Many people find that thought unsettling. Yet viewed through the immense timescale of the universe, it is not a tragedy. It is simply another chapter in the natural life cycle of stars. Around many distant stellar systems, astronomers have already observed evidence suggesting that some planets orbit stars which have entered the red giant phase. In certain cases, the star's expanding atmosphere and changing gravitational interactions gradually shrink the planet's orbit until the planet is ultimately swallowed by the star's extended outer layers and destroyed. A planet that once traveled peacefully around its star for billions of years now slowly approaches its own ending. Not because it made a mistake, not because it wandered from its orbit, but because the star at the center of its system has entered a new stage of life. There is something profoundly quiet about that image. It reminds us that not every change begins within ourselves. Sometimes the world around us is changing as well. Carl Gustav Jung once wrote, "Life calls not for perfection, but for completeness." Throughout Jung's work, wholeness mattered far more than perfection. A star does not fail when it becomes a red giant. It is simply completing the journey that the laws of physics have prepared for it. Perhaps the same is true for us. Some seasons of life are not meant to preserve the appearance of youth forever, but to invite us into another kind of maturity, one that is deeper, quieter, and more peaceful. Not every planet, however, follows an orbit as nearly circular as Earth's. Some worlds travel along highly elongated elliptical paths. That means the distance between the planet and its star changes dramatically over the course of a single year. At its closest approach, the planet receives an immense flood of radiation. Temperatures rise sharply. If an atmosphere exists, storms may become far more violent. If there is ice, it may melt with astonishing speed. Yet when the planet reaches the farthest point in its orbit, everything changes once again. The light grows weaker, temperatures fall. Regions that were once intensely hot may gradually become bitterly cold. If seasons exist on such a planet, they would resemble nothing we have ever experienced on Earth. Not merely 4 familiar seasons, but enormous climatic cycles in which an entire world alternates between scorching heat and deep cold over immense spans of time. What is fascinating is that the laws of physics do not consider these orbits unusual. They are simply one of many ways gravity allows planets to move. This reminds me of another well-known observation by Jung: the shoe that fits one person pinches another. There is no recipe for living that suits all cases. Jung was speaking about human life. Yet if we listen carefully, his words seem equally at home in astronomy. There is no single perfect orbit for every planet, no universal pattern of seasons for every world. Each planetary system writes its own history. Some planets move along nearly circular paths. Others live through dramatic cycles of constant change. Both are entirely natural possibilities within the universe. Perhaps our own lives are much the same. We often compare our pace with someone else's. Some people seem to grow quickly. Others require many years before discovering the path that truly belongs to them. Some experience long seasons of peace. Others move from one transformation to another. Yet, like planets, no journey must resemble another in order to have meaning. Jung believed that every individual's psychological development is unique. The process of individuation follows no universal formula. It unfolds according to the rhythm of each person, just as every planet follows an orbit that belongs only to itself. What I love most about planets circling aging stars is not the drama of their transformations, it is their patience. Nothing happens in a single day. A star requires millions or billions of years to become a red giant. A planet slowly adapts to its changing environment. Even endings unfold gradually, quietly, almost like autumn leaves drifting gently to the ground. Carl Gustav Jung once wrote, "There is no coming to consciousness without pain." This is not a celebration of suffering. Rather, Jung reminds us that every profound transformation asks us to let go of something old so that something new may emerge. The universe is no different. A star grows old. A planet changes. A stellar system enters another chapter. And from the material released during those transformations, future stars and future planets will eventually be born. Nothing truly disappears. Stories simply continue in new forms. Viewed through the eyes of science, this is the evolution of celestial bodies. Viewed through Jung's perspective, it may also become a symbol of the transformation of the human spirit. Of course, astronomy does not prove psychology, nor does psychology explain stellar evolution, yet both share a quiet beauty. They invite us to accept that change is a natural part of existence. As our imaginary spacecraft slowly departs from these aging stars, their gentle crimson light continues to spread across the vastness of space. Their planets still follow their elongated orbits, passing through seasons of heat and seasons of cold, through cycles far longer than any human memory. And perhaps, as your eyes slowly close and sleep draws near, what remains with you will not be the image of a planet drifting ever closer to its aging sun, but a quiet reassurance that even in the final chapters of a journey, the universe never ceases to create beauty. Just as in our own lives, change is not always a sign of loss. Sometimes, it is simply the gentle way life guides us toward the fullest version of who we are meant to become. Extreme geology. As our imaginary spacecraft continues its quiet voyage across the ocean of stars, perhaps you have begun to notice that every planet carries its own unique story. Some worlds are covered by oceans too deep to measure. Others remain locked in eternal darkness. Some experience rain made of metals, while others possess skies woven from vaporized rock. But tonight, we lower our gaze beneath the surfaces of these extraordinary worlds, into places where ancient forces continue their silent work. These are the forces of geology of molten interiors, immense pressures, and processes so slow that no human lifetime could ever witness them in full. On Earth, we often think of volcanoes as the ultimate symbol of nature's power. Rivers of glowing lava, towering columns of ash, and thunderous eruptions remind us how small we are before the forces of our planet. Yet compared with many other worlds in the universe, Earth is surprisingly gentle. Some celestial bodies have never truly stopped being geologically active, not for years, not for thousands of years, but for millions, even billions of years. One of the most extraordinary reasons for this ongoing activity is tidal heating. At first, the concept may sound abstract, yet it begins with something surprisingly familiar. Gravity. Here on Earth, the Moon's gravity raises the tides in our oceans. Elsewhere in the universe, and even within our own solar system, as in the case of Jupiter's moon Io, the powerful gravity of a giant planet, combined with the gravitational influence of neighboring moons, repeatedly stretches and squeezes a world. Imagine bending a metal wire over and over again. Eventually, mechanical energy is converted into heat. The same thing happens on a planetary scale. A celestial body does not need to be close to its star in order to become intensely hot. Sometimes its warmth is generated from within, by the constant motion created through gravity itself. There is something quietly beautiful about that idea. Sometimes warmth does not come from the outside. Sometimes it is born from gentle movements deep within. In worlds profoundly shaped by tidal heating, the rock beneath the surface is continually warmed from within. Magma is constantly generated, searching for pathways upward. The result is a landscape where volcanoes remain almost perpetually active, erupting again and again across immense geological timescales. If you could stand upon such a world only as an exercise of the imagination, you might never grow accustomed to the view before you. The horizon would never be completely still. In the distance, towering columns of glowing material would continually rise toward the sky. The ground would tremble with the slow heartbeat of the planet itself. The air would shimmer with the heat of rivers of molten rock moving beneath the surface. It would not be a catastrophe. It would simply be the pulse of the planet. Carl Gustav Jung once wrote, "There is no birth of consciousness without pain." This quotation is often understood as another expression of an idea Jung returned to throughout his work. Genuine growth in consciousness is always accompanied by transformation. He was not praising suffering. Rather, he observed that profound change rarely unfolds in complete stillness. Perhaps these geologically extreme worlds are telling a similar story. It is their ceaseless inner motion that continually reshapes their surfaces. It is the heat within that keeps them evolving. Without that movement, the planet would gradually cool into silence. As our journey continues, we encounter minerals unlike anything that can remain stable on Earth. Under extraordinary pressures and immense temperatures, familiar elements arrange themselves into entirely new crystal structures. New mineral phases emerge, existing deep inside giant planets or rocky worlds crushed beneath unimaginable pressures. Many of these exotic materials have so far been predicted only through theoretical models or recreated briefly inside laboratories capable of producing such extreme conditions. This reminds us that nature's creativity does not exist only on the scale of stars. It exists even at the scale of atoms. Change the pressure, change the temperature, and an entirely new structure may appear. Perhaps human beings are much the same. Different circumstances do not necessarily alter who we truly are. Instead, they allow different qualities already within us to emerge. Some people discover courage only when facing hardship. Others recognize their capacity for compassion only after experiencing loss. Not because they become someone entirely different, but because life's conditions reveal the hidden minerals that have always existed within their inner world. Jung once wrote, "The privilege of a lifetime is to become who you truly are." The word "become" in that sentence has always stayed with me. It suggests that we are not finished sculptures from the beginning. We are more like planets still in the process of formation, with their deepest layers quietly evolving beneath the surface. On some rocky planets orbiting extremely close to their stars, temperatures become so high that solid ground can no longer exist. Stone melts into vast oceans of magma, stretching for hundreds or even thousands of kilometers. Mountains and seas lose their familiar distinction. The entire surface becomes a glowing ocean of molten rock, flowing in slow, magnificent currents. Remarkably, even night on such worlds is never completely dark, not because they possess many moons, not because of shimmering auroras, but because the lava itself radiates light. Seen from far away in space, such a planet might resemble a glowing ember drifting silently through the darkness. Its beauty is both fierce and serene. That image reminds me of another of Jung's well-known observations. Knowing your own darkness is the best method for dealing with the darknesses of other people. Perhaps the most beautiful thing about these planets is that they make no attempt to conceal what is happening within them. Their inner energy shines openly upon their surface. Their glowing lava resembles the deep emotions that sometimes quietly illuminate a human life. Those emotions may be powerful. They may burn intensely. Yet, when they are understood rather than feared, they need not become destructive. They can instead become the source of creativity, of courage, and of transformation. Of course, this is only a symbolic comparison. Molten rock and human emotion belong to entirely different domains. Astronomy studies matter and energy. Analytical psychology explores the inner life of the human mind. Yet sometimes the images offered by the universe help us express experiences that ordinary language struggles to describe. What I love most about these geologically extreme worlds is not their eruptions or their astonishing temperatures. It is the simple fact that they are still alive. A planet is not merely a motionless sphere of rock. It has a history. It carries memories. It contains deep currents flowing within. Its heartbeat is measured across spans of geological time. Perhaps people are like that as well. Outwardly, we may appear perfectly calm, yet deep within us, hidden currents continue to flow. There are dreams still unspoken, sorrows that have quietly settled, longings that continue to glow like magma beneath layers of stone. And perhaps those unseen movements are precisely what give a human being life. As our imaginary spacecraft slowly leaves behind the worlds where rivers of lava illuminate the endless night, space gradually becomes quiet once again. Yet within that silence, perhaps you carry with you a gentle realization that neither the universe nor the human soul is ever truly motionless. Deep currents are always moving beneath the surface. There is no need to hurry. No need for noise. Only the patient, quiet persistence of a planet that has guarded its inner fire for billions of years, allowing it to radiate its own unique light, even in the endless darkness of the cosmos. Ocean worlds. There is something profoundly special about water. Something that people from every civilization seem to have sensed. From the rivers that nourished the earliest human cultures to the oceans that cover most of Earth's surface, water has always been associated with life, memory, and the vast unknown waiting to be explored. Perhaps that is why, when astronomers began discovering worlds where water might exist in forms entirely unlike anything on Earth, humanity's imagination expanded almost instantly. Tonight, our imaginary spacecraft will carry you to the ocean worlds, places where water, ice, and rock together tell one of the universe's most beautiful stories of diversity. Seen from great distances, many icy planets and moons appear almost perfectly still. Their frozen surfaces reflect the faint light of distant stars, making them resemble silent spheres of ice drifting peacefully through space. Yet modern science reveals another picture. Beneath ice shells, tens or even hundreds of kilometers thick, vast oceans of liquid water may exist, kept warm either by heat escaping from the planet's interior or by the steady energy produced through tidal heating. Within our own solar system, worlds such as Europa and Enceladus have become leading candidates for hidden subsurface oceans. Beyond the solar system, astronomers believe there may be countless ocean worlds, where water is not merely one feature of the landscape, but the dominant ingredient shaping the entire structure of the planet itself. Imagine such a world. Above you stretches a silent sky. Beneath your feet lies an ice shell so thick that no ray of sunlight can ever penetrate it. And deeper still, an endless ocean. There are no wind-driven waves, no sky reflected upon the water, only a vast, dark ocean, moving silently beneath the gentle warmth rising from the planet's interior. It is remarkable to imagine that within what appears to be the coldest and most motionless place, movement never truly stops. Perhaps that is what brings to mind one of Carl Gustav Jung's central ideas about the inner life. He believed that beneath the surface of consciousness, lies a far greater realm, the unconscious. It is neither loud nor obvious, yet it quietly nourishes our dreams, our symbols, and the hidden possibilities we have not yet discovered within ourselves. Jung once wrote, "Who looks outside, dreams. Who looks inside, awakes." Perhaps those words become especially vivid when we imagine oceans hidden beneath sheets of ice. The most important part of the world is not always on the surface. Sometimes it lies far below, where only patience can reach it. Scientists call such places ocean worlds not merely because they contain water, but because water may compose most of their internal structure. According to some planetary models, these oceans may extend hundreds of kilometers deep. As one descends farther into them, pressure rises to extraordinary levels, gradually transforming liquid water into exotic forms of high-pressure ice. What is especially fascinating is that this ice does not necessarily rest upon the surface as it does on Earth. Instead, it may form beneath the ocean itself, creating a layer between the liquid water above and the rocky core below. In other words, water can exist in several different forms within the same world. Liquid water, high-pressure ice, water vapor, all existing together in a structure that nature has quietly shaped over billions of years. Yet water is not the only wonder waiting beyond our imagination. Some planets may also be extraordinarily rich in carbon. In astronomy, the term carbon planet describes a hypothetical world where carbon may be far more abundant than oxygen. Although such planets remain largely theoretical and have not yet been directly confirmed, the idea opens an intriguing possibility. Under the right chemical conditions, a planet's entire internal structure could be fundamentally different from Earth's. Instead of a crust dominated by silicate rocks, portions of these worlds might consist largely of carbon compounds. Under enormous pressures and temperatures, carbon could crystallize into diamond, while in regions of lower pressure it might exist as graphite. There is something wonderfully surprising about that. Here on Earth, both diamond and graphite are made from exactly the same element, carbon. The only difference lies in how the carbon atoms arrange themselves. One arrangement creates the hardest natural material known. The other is soft enough to leave marks across a sheet of paper with an ordinary pencil. It reminds us that sometimes the greatest differences do not arise from our essential nature. They arise from how that nature is organized. Carl Gustav Jung once wrote, "The privilege of a lifetime is to become who you truly are." What has always fascinated me about this sentence is the word become. Jung never suggested that human beings are born complete. He believed each of us is continually arranging and rearranging ourselves, much as carbon can form entirely different structures under different conditions. Of course, this remains only a symbolic comparison. Psychology cannot be explained by chemistry, nor can chemistry explain the human spirit. Yet the images offered by the universe sometimes help us understand the quiet beauty of transformation. What I love most about ocean worlds is not the question of whether life exists there. Science is still searching for that answer. What moves me more deeply is the thought that an entire world may hide its greatest beauty beneath a cold shell of ice. From the outside, everything appears silent, yet deep below, an immense ocean is forever in motion. Perhaps people are like that as well. We usually see only one another's surface, a smile, a glance, a handful of words. Yet beneath those small moments lie vast oceans of memory, hope, fear, and dreams that have never been spoken aloud. Jung called this the journey into the unconscious, not to discover something mystical, but to recognize that every human being is far larger than the portion illuminated by conscious awareness. He once wrote, "Until you make the unconscious conscious, it will direct your life, and you will call it fate." Perhaps we might approach ourselves with the same patience that astronomers bring to the study of an ocean world. They do not stop at the frozen surface. They continue asking what lies beneath. They search for the faintest clues to understand the hidden structure of an entire world. Perhaps we owe ourselves that same patience, not rushing to judge, not stopping at appearances, but quietly listening for the deeper currents moving within our own hearts. As our imaginary spacecraft gently leaves behind the hidden oceans beneath frozen ice, the carbon-rich worlds, and the immense layers of diamond forged under unimaginable pressures, countless unexplored planets still await beyond the darkness. Yet perhaps the greatest gift this part of the journey offers is not the vision of endless oceans or glittering gemstones buried deep within alien worlds. Perhaps it is the quiet reminder that both the universe and the human soul always contain far more than the eye can see. And sometimes, it is the deepest and quietest places that safeguard the greatest beauty of all. Planets stripped bare. When we observe a planet from afar, the first things to capture our attention are usually its outer features. Swirling cloud bands, colorful atmospheres, sunlight glimmering from ice or oceans, these are the images that make each world appear unique. But the universe has never told its stories through appearances alone. Sometimes its strangest chapters begin when a planet slowly loses its outer layers, revealing a hidden interior that remained concealed for billions of years. Tonight, our imaginary spacecraft will visit what astronomers sometimes describe with a striking image: planets, stripped bare worlds that are gradually losing their atmospheres and exposing what lies beneath. On Earth, the atmosphere is like an invisible blanket. It shields us from much of the sun's harmful radiation. It moderates our climate. It paints our familiar blue sky. We rarely stop to appreciate this delicate envelope because it has always been there. Yet when astronomers study exoplanets orbiting extremely close to their stars, they discover that not every world is fortunate enough to keep this protective cloak. At such close distances, planets endure relentless stellar winds, streams of charged particles, and high-energy radiation flowing continuously outward from their host stars. If a planet lacks a sufficiently strong magnetic field or enough gravity to hold onto its atmosphere, its outer layers gradually begin to escape into space. This is not a process that happens in a single day, or even a single year. It unfolds across millions, sometimes billions, of years, as slowly and patiently as a wind that never stops blowing. Imagine such a process. Not a violent storm, not an explosion, only an invisible stream of particles, day after day, century after century, patiently carrying away one thin layer of atmosphere after another, until one day, the planet no longer resembles the world it once was when it first came into existence. Some of the exoplanets astronomers observe today may be passing through exactly this stage. Spectroscopic data reveal material escaping from their atmospheres, forming long streams of gas stretching out into space. These observations remind us that planets are not unchanging objects. They evolve, they age, and they are continually reshaped by the environments in which they exist. Even more remarkable is what may happen as an atmosphere gradually disappears. The planet's core may slowly begin to reveal itself. Some researchers propose that certain rocky exoplanets orbiting extremely close to their stars could actually be the exposed cores of giant gaseous planets that once existed. In this scenario, immense envelopes of hydrogen and helium have been gradually stripped away over vast stretches of time, leaving behind the denser material that once lay hidden at the center. Objects like these are sometimes described as the remnants of giant planets. Although the precise history of each individual world remains an active area of scientific research, there is something profoundly moving about that thought. A world that was once far larger, once wrapped in atmospheric layers tens of thousands of kilometers thick, now reduced to its inner core. Yet it is that very core that tells the truest story of where the planet came from. It is here that I find myself remembering one of Carl Gustav Jung's most familiar reflections. The privilege of a lifetime is to become who you truly are. Jung was not speaking about planets. He was speaking about people. Yet somehow those words seem to echo naturally as we imagine worlds that have lost their outer layers, revealing the deepest part of themselves. Within analytical psychology, Jung devoted great attention to the concept of the persona, the social mask each of us wears in order to live and work with others. The persona is not something negative. It allows us to communicate, to cooperate, and to function within society. But Jung also warned that when we identify ourselves entirely with that mask, we risk forgetting the deeper reality that exists beneath it. He once wrote, "Who looks outside, dreams. Who looks inside, awakes." Perhaps no quotation feels more fitting for tonight's journey. A planet stripped of its atmosphere invites us to look inward. Perhaps life sometimes does the same for us. There are seasons when unexpected events gradually remove the masks we have worn, not to weaken us, but to give us the chance to discover what has always existed underneath. Of course, this remains only a symbolic comparison. There is no scientific evidence suggesting that planets and the human mind operate according to the same mechanisms. Yet, the images offered by the universe sometimes allow us to express our inner experience with remarkable gentleness. What I admire most about these planets is their patience. Nothing is removed all at once. Every transformation happens slowly, one layer at a time, little by little, as though time itself were quietly touching everything it encounters. Perhaps our own lives unfold in much the same way. Very few people change overnight. We mature across many years, through moments of joy, through disappointment, through encounters with others, through partings. Each experience resembles a gentle wind. Some carry away a portion of our fear. Some remove a little of our pride. Some quietly lift away a mask we once believed would remain forever. Carl Gustav Jung once wrote, "Knowing your own darkness is the best method for dealing with the darknesses of other people." These words do not encourage us to seek darkness. They simply remind us that genuine self-understanding begins with honesty. A planet that has lost its atmosphere can no longer conceal its true structure. Perhaps people are much the same. There come moments in life when what remains is no longer reputation or status or the roles we play before the world. What remains is the deepest quality of the soul itself. Perhaps that is the true core of a human being. What is especially fascinating is that astronomers do not regard stripped planets as failures of nature. Quite the opposite. They are extraordinarily valuable because they allow us to understand more about how planetary systems evolve. A world that loses something is not simply a story of loss. It also becomes a source of knowledge, a doorway leading toward a deeper understanding of cosmic history. Perhaps life works in much the same way. The things we lose do not merely leave empty spaces behind. They may also leave understanding, humility, and the ability to see the world with gentler eyes. Jung once wrote, "In all chaos there is a cosmos. In all disorder a secret order." Perhaps even planets slowly eroded by stellar winds are following such an unseen order. An order that is not always immediately visible, yet one that has always been there. As our imaginary spacecraft quietly departs from these worlds that are gradually revealing their hidden cores, the vast darkness ahead once again opens into countless silent stars, and perhaps, as your eyes slowly close and sleep gently approaches, what remains with you will not be the image of stellar winds carrying away the atmosphere of some distant planet. Instead, perhaps what remains is a quiet reassurance that neither the universe nor the human soul is defined by its outer layers. Sometimes, only after years of being gently shaped by time, by hardship, and by life itself, does the truest and most beautiful part of a world finally emerge, silent, enduring, and waiting patiently for the light of the stars to reach it. Strange orbits. If there is one thing the earliest centuries of modern astronomy once believed, it was that planetary systems would probably resemble our own solar system. Planets born from the same swirling disk of gas and dust would orbit their star along nearly the same plane, orderly, graceful, and stable. For a long time, that assumption seemed perfectly reasonable. But then, as telescopes became more powerful and thousands of exoplanets were discovered, The universe quietly reminded us once again that nature has always possessed a richer imagination than any theory we could create. Tonight, our imaginary spacecraft drifts towards some of the strangest planetary orbits ever discovered. Worlds that do not travel along the paths we once considered normal. Worlds that seem to rewrite the very meaning of stability among the stars. Here on Earth, we rarely think about our own orbit. Every year, our planet completes one gentle revolution around the Sun, along a path that is nearly circular and closely aligned with the orbital plane shared by most of the planets in our solar system. That remarkable stability has helped shape our climate, our seasons, and ultimately, the conditions that allowed life to flourish. But not every planetary system has been so fortunate. Astronomers have discovered many exoplanets whose orbits are tilted dramatically compared with the rotation of their host stars. Some even travel along paths that are almost perpendicular to the star's equator. At first, that can be difficult to imagine. Picture a spinning dinner plate. Normally, small marbles rolling across it would move around the rim in roughly the same direction. Now imagine one marble racing almost straight across the plate instead. That is something like what astronomers see when they discover planets with highly inclined orbits. Even more fascinating, some planets appear to follow what scientists call polar orbits. Instead of circling around the star's equatorial region, they travel over its poles, moving along paths that are nearly perpendicular to the star's axis of rotation. These discoveries reveal that the history of planetary systems can be far more complicated than we once imagined. Gravitational interactions with neighboring planets, companion stars, or even the original disk of gas and dust may gradually reshape a planet's orbit over millions of years. Nothing is completely fixed. Even paths that appear eternal may slowly change. Carl Gustav Jung once wrote, "Everything that irritates us about others can lead us to an understanding of ourselves." Jung was speaking about people, yet perhaps his words also carry a quiet lesson for science. Whenever the universe reveals something different from what we expected, scientists do not become discouraged. Instead, they gain an opportunity to better understand their own assumptions. Again and again, it is the exceptions that open the largest doors to knowledge. Our journey continues. Ahead lies another collection of worlds whose histories were shaped by violent encounters with gravity itself. During the early formation of a planetary system, while planets are still growing and migrating through the surrounding disk, powerful gravitational interactions may occur. Sometimes a planet is pulled into a completely new orbit. Sometimes two planets exchange positions. And in rarer cases, a planet gains enough energy to be thrown entirely out of its own stellar system. Pause for just a moment and imagine that. A world that once had a sun, once experienced sunrise, once followed a peaceful, predictable orbit. Then, after countless gravitational encounters spread across millions of years, it slowly drifts away. No central star, no familiar daylight, no year as it once understood time, only the immense darkness between the stars. Astronomers call these remarkable worlds rogue planets, or free-floating planets. Unlike ordinary planets, they orbit no star at all. Instead, they wander alone through interstellar space. Today, astronomers have identified numerous candidates using techniques such as gravitational microlensing and infrared observations. Although determining exactly how many rogue planets exist remains one of the exciting questions of modern astronomy. Whenever I think about these wandering worlds, I feel something unexpectedly gentle. A planet still exists, yet it no longer has a home in the way we usually imagine one. And still, it continues its journey. It does not stop. It does not disappear. It simply keeps drifting through the galaxy. It is here that I remember another of Jung's well-known reflections. I am not what happened to me. I am what I choose to become. Of course, planets make no choices. Their paths are governed entirely by the laws of physics. But if we allow rogue planets to become symbols for a moment, Perhaps they remind us that circumstances do not always define the full value of an existence. Throughout analytical psychology, Jung emphasized that human beings are not merely products of their past. We are also shaped by the ways we encounter, understand, and gradually transform our experiences. Naturally, this is only a symbolic comparison. Astronomy and psychology explore entirely different realities. Yet sometimes the universe offers images that help us express experiences too subtle for ordinary language. What I love most about rogue planets is not their loneliness. It is their freedom. No longer bound to a fixed orbit, no longer circling a single star. They become travelers of the galaxy itself. Perhaps millions of years from now, one of them will drift past another stellar system. Perhaps a new gravitational embrace will gently alter its path once more. Perhaps one day, a wandering planet will even be captured into an entirely new orbit. The universe has never been a place that closes every possibility. Carl Gustav Jung once wrote, "In all chaos there is a cosmos. In all disorder, a secret order." Perhaps no words describe these extraordinary orbits more beautifully. At first glance, a tilted planet, a polar orbit, or a world flung out of its own star system might seem like symbols of chaos. But through the eyes of physics, every one of these worlds still obeys remarkably precise laws. No motion is truly random. Only the causes are sometimes beyond what we currently understand. Perhaps life is a little like that as well. There are seasons when we feel that we are walking a path very different from everyone else's. Moments when it seems as though we have drifted away from the familiar orbit we once knew. Times when we feel like wanderers crossing an immense and silent space. And yet, perhaps it is precisely those unexpected turns that reveal landscapes a straight road could never have shown us. Jung believed that the process of individuation, the lifelong journey of becoming one's true self, was never about living like everyone else. It was about discovering the orbit that resonates most deeply with one's own nature. As our imaginary spacecraft slowly leaves behind the planets with extraordinary orbits, the worlds that circle above their stars' poles, and the lonely rogue planets that no longer know the warmth of a sun, countless quiet stars continue to stretch across the darkness ahead. And perhaps, as you gradually drift towards sleep, what remains with you will not be the image of unusual orbits, but the peaceful realization that, in this vast universe, not every path needs to resemble another in order to have meaning. Just as every soul follows its own quiet journey, sometimes it is the most unusual orbits that carry us toward horizons we never imagined were possible. Wandering worlds that may still harbor life. Perhaps from the very beginning of our journey, we have quietly associated life with light. Whenever we imagine a habitable planet, the first picture that comes to mind is usually a gentle sun shining overhead, oceans reflecting the colors of dawn, and seasons returning year after year. Here on Earth, sunlight truly is the primary source of energy for most life. For that reason, astronomers have spent decades searching for planets that lie within the habitable zone, the region around a star where liquid water could exist on a planet's surface. But the more we explore the universe, the more we discover that nature continually expands the limits of human imagination. Tonight, our imaginary spacecraft visits a possibility that is both mysterious and quietly hopeful. Worlds that wander through the galaxy without orbiting any star. Yet perhaps they are not completely lifeless. In the previous chapter, we encountered rogue planets, worlds ejected from their original star systems after powerful gravitational encounters. Once they leave their parent star behind, they no longer receive sunlight or external warmth. Our intuition might immediately tell us that any life, if it ever existed there, must quickly disappear. But science gently reminds us to be careful with conclusions that seem obvious. A planet without a sun, no sunrise, no summer, no daylight. Does that truly mean life is impossible? The most honest answer we have today is remarkably simple. We do not yet know. And perhaps that uncertainty is one of the most beautiful qualities of science itself. Researchers have proposed models suggesting that, under certain conditions, a rogue planet might retain internal heat for an extraordinarily long time. One important source of that energy is radioactive decay. From the moment rocky planets form, they contain small amounts of naturally occurring radioactive elements, such as uranium, thorium, and potassium. 40. As these elements slowly decay over billions of years, they release heat. Here on Earth, that internal heat helps sustain activity within the mantle and the core even today, which means that even after a planet loses the warmth of its star, its interior may continue producing heat, not from outside, but from deep within itself. There is something profoundly gentle about that thought. A world that appears completely lost in darkness, yet far below its frozen surface. Its inner fire still burns. Carl Gustav Jung once wrote, "Who looks outside, dreams. Who looks inside, awakes." Of course, Jung was not speaking about geothermal energy or rogue planets, but as a symbol, his words feel unexpectedly appropriate. Some sources of strength do not come from light outside us. They arise from the deepest layers of our own existence. Another possibility that fascinates scientists is the presence of an exceptionally thick atmosphere. If a rogue planet possessed an atmosphere rich in hydrogen, or simply one dense enough to trap heat efficiently, it could act like a vast insulating blanket surrounding the entire world. Heat rising from the interior would escape much more slowly into space, allowing the surface, or at least the deeper layers beneath it, to remain significantly warmer than we might expect. This does not mean such a planet would resemble Earth, but it opens a remarkably intriguing possibility. Somewhere beneath thick ice, or deep below the surface, liquid water might still survive. And whenever liquid water enters the conversation, scientific curiosity awakens once again. If a rogue planet contained a hidden underground ocean, warmed by radioactive heat, and protected beneath layers of ice or a dense atmosphere, could simple forms of life exist there? Today, we have no evidence confirming that possibility. For now, it remains a scientific hypothesis. Yet it is not speculation without foundation. It is built upon everything we have learned from physics, geology, and biology here on Earth. Even on our own planet, countless microorganisms thrive deep underground and around hydrothermal vents on the ocean floor, living almost entirely without direct sunlight. Instead, they obtain energy from the chemistry of their surroundings. And that naturally leads scientists to ask one of the most beautiful questions of all. Could life exist without sunlight? Could the truly essential ingredients be something else entirely? Long-lasting liquid water and a steady source of energy? The honest answer is that we still do not know. And perhaps that is one of the most beautiful things about science. Sometimes, the questions that remain unanswered are the very ones that keep discovery moving forward. Carl Gustav Jung once wrote, "The least of things with a meaning is worth more in life than the greatest of things without it." Perhaps what makes rogue planets so extraordinary is not the certainty that they harbor life. It is that they expand the very way we define life itself. For centuries, humanity quietly assumed that where there is life, there must also be a sun. Now, science gently reminds us that nature may be far more creative than we have ever imagined. Seen through Jung's symbolic lens, these wandering worlds also carry a quiet meaning. There are seasons in life when we feel like rogue planets ourselves. No familiar place to stand, no encouragement that once surrounded us, no light shining from outside. Yet that does not necessarily mean that all life within us has disappeared. Sometimes what allows a person to keep moving forward is not the world around them, but the quiet fire still burning inside. Of course, this is only a symbolic comparison. A planet has no inner psychological life as a human being does, and psychology cannot be proven through astronomy. Yet the images offered by the universe sometimes help us express experiences that ordinary language struggles to describe. Jung often emphasized that growth does not arise only during life's brightest seasons. It also emerges from darkness, from silence, from the quiet periods when it seems as though nothing at all is happening. Perhaps rogue planets tell a similar story. On the outside, cold, dark, silent, yet deep beneath thick layers of ice, an entire ocean may still be slowly moving. Perhaps that is one of the greatest gifts science has given us. It does not promise, it does not claim certainty, but neither does it rush to close the doors of possibility. Carl Gustav Jung once wrote, "In all chaos there is a cosmos, in all disorder a secret order." Perhaps even the loneliest planets in our galaxy still belong to that hidden order. They continue preserving warmth deep within their interiors. They continue drifting quietly through the vast darkness between the stars, carrying with them the possibility that somewhere beneath eternal ice, liquid water, energy, and perhaps even a form of life, unlike anything we have ever known, may still endure. As our imaginary spacecraft slowly leaves these wandering worlds behind, the darkness of interstellar space no longer feels quite as frightening as it once did. Because now we understand that darkness is not always the end. Sometimes, beneath a frozen crust, beneath a sky that has forgotten the Sunday, or deep within the human soul, an unseen ocean still quietly protects the warmth of life. And perhaps the greatest miracle of the universe is not found in the brightest places. Perhaps it is its patient ability to nurture hope where we once believed nothing could possibly survive. Two suns and strange skies. From the time we are children, most of us quietly assume that a sky should have only one Sunday. Each morning, light appears along one horizon. Each evening, it gently disappears beyond the opposite one. That rhythm has shaped life on Earth so completely that we rarely stop to ask a simple question. Could there be worlds somewhere in the universe where the sky follows an entirely different rhythm? Tonight, our imaginary spacecraft carries us towards some of the most extraordinary planetary systems ever discovered. Places where sunrise may arrive from two sources of light at once, where two shadows stretch across the ground, where daylight follows patterns unlike anything we have ever known, and where the sky itself tells a story completely different from Earth's. For centuries, humanity believed that our solar system represented the typical architecture of planetary systems. One star, many planets. But today, astronomers know that a large fraction of the stars in the Milky Way actually belong to binary or even multiple star systems. That means countless planets throughout our galaxy may have been born beneath two suns instead of one. From the very beginning, while still forming inside immense clouds of gas and dust, binary star systems can shape their surrounding protoplanetary disks through complex gravitational interactions. Instead of forming a single, perfectly flat disk like the simple illustrations found in textbooks, the material may become warped, tilted, or even divided into different regions with different orientations. Within those changing disks, planets slowly begin to form, which means these distant worlds grow up beneath skies unlike anything Earth has ever known. Imagine standing on such a planet at sunrise. The eastern horizon gradually brightens. Then, not one, but two suns slowly emerge, one larger, one smaller. Their light blends together, painting colors the human eye has never witnessed on Earth. If you stood there at that moment, you would not cast a single shadow. You would cast two, each stretching gently in a different direction, every step accompanied by the light of two suns. It sounds almost like mythology, yet it is a very real possibility in astronomy. One of the best-known examples is Kepler 1.6b, the first confirmed planet found orbiting both stars in a binary system. Since that discovery, astronomers have identified many more similar systems, showing that skies with two suns belong not only to science fiction, but to the real universe. There is something quietly beautiful about that realization. It reminds us that ideas once considered impossible sometimes become ordinary simply because science has learned to look a little farther. Yet not every strange sky exists because of two suns. Some stars continually change their own brightness. Astronomers call them variable stars. Unlike our sun, whose brightness remains relatively stable over human timescales, many variable stars brighten and dim in repeating cycles. Sometimes this happens because the star itself expands and contracts. Sometimes because physical processes inside its outer layers change over time. And sometimes because, in binary systems, one star periodically passes in front of the other from our point of view. If a planet orbited such a changing star, its sky would follow a rhythm unlike our own. The daylight would never be completely constant. There would be seasons when the star shone more brilliantly, and other times when its light softened into something quieter. If oceans or an atmosphere existed there, the entire world would quietly feel the rhythm of its star's breathing. Not because the star was unstable, but because that is simply its nature. Carl Gustav Jung once wrote, "Everything that irritates us about others can lead us to an understanding of ourselves." Perhaps what surprises us about these unusual skies is not that they are wrong, but that they are different from what we have always known. Again and again, science teaches us that different does not mean abnormal. It simply expands our understanding of what is possible. Our journey now carries us toward one of the strangest objects in the universe, a pulsar. A pulsar is the incredibly dense core left behind after a massive star ends its life in a supernova explosion. Tiny by cosmic standards, yet unimaginably compact. It spins dozens, hundreds, or even thousands of times every second. Powerful beams of radiation stream outward from its magnetic poles. Whenever those beams sweep across Earth, astronomers detect remarkably regular pulses, like the steady ticking of a cosmic clock. Now imagine the sky above a planet orbiting such an object. No gentle golden sunlight, no familiar sunrise. Instead, invisible beams of radiation sweep across space with extraordinary precision. A sky unlike anything humanity has ever experienced. There is something deeply wonderful in realizing that even after the death of a star, planets may still continue to exist around what remains. These planetary systems remind us that the universe is always finding new ways to continue its story. Carl Gustav Jung once wrote, "In all chaos there is a cosmos, in all disorder a secret order." Perhaps no quotation suits these extraordinary skies more beautifully. At first glance, two suns, double shadows, variable stars, and pulsars appear to be exceptions. Yet the deeper we look, the more clearly we discover that each follows the precise laws of physics. There is no chaos, only patterns humanity had not yet learned to recognize. Seen through Jung's symbolic perspective, these unusual skies also carry a gentle lesson. Human beings often long for simplicity. One path, one answer, one source of light. Yet life is rarely so uncomplicated. Sometimes we are influenced by many relationships at once, many responsibilities, many inner voices, many different suns illuminating our lives. The challenge is not to keep only one source of light. It is to learn how to maintain our own orbit while living among them all. Of course, this is only a symbolic comparison. Binary star systems and the human psyche do not obey the same laws. Yet the universe often gives us beautiful images through which we can appreciate the richness of diversity. Jung once wrote, "The privilege of a lifetime is to become who you truly are." Perhaps that journey resembles a planet orbiting two suns. It does not need to choose only one source of light. It simply learns how to preserve its own orbit while responding to many different gravitational influences. What I love most about these extraordinary skies is not their uniqueness. It is the reminder that the universe has never been limited by human imagination. There are dawns beneath two suns, double shadows stretching across distant landscapes, stars whose light gently rises and falls, planets circling the remnants of stars that died long ago. And somehow, all of them belong to the same galaxy we continue to explore. As our imaginary spacecraft slowly leaves these remarkable skies behind, the light of two suns gradually fades into the quiet darkness. The twin shadows disappear beyond the horizon of a distant world. And perhaps, as you close your eyes and drift towards sleep, what remains will not be the image of rare astronomical phenomena. Instead, perhaps you will carry a peaceful realization that the universe has always been larger than the patterns we once believed were complete. Just as the human soul grows whenever it opens itself to what is different, beauty is found not only in what is familiar, but also in every possibility that life patiently continues to place before us. The tragic fates of planets. When we gaze into the night sky, the universe often feels wonderfully still. The stars seem to remain in the same places. The planets quietly follow their familiar paths. Everything appears calm, steady, and almost eternal. Yet the deeper astronomers have looked, the more they have discovered that beneath this peaceful appearance lies a universe in constant motion. Stars are born, they grow old. Planets form, they evolve. Some worlds spend billions of years in remarkable stability. Others experience transformations so dramatic that their very existence is placed in jeopardy. Tonight, our imaginary spacecraft visits planets whose destinies may seem among the most tragic in the cosmos. But if we listen carefully, perhaps this is not really a story about despair. It is a story about transformation, something both astronomy and Carl Gustav Jung regarded with profound respect. Let us begin with one of the most powerful events nature has ever created, a supernova. When a massive star reaches the end of its life, its core can no longer withstand the overwhelming force of gravity. Within moments, the star collapses before exploding with unimaginable energy, briefly shining brighter than entire galaxies. It is among the most violent events in the universe. At first, it seems almost impossible that any planet could survive such a catastrophe. Yet nature is always more subtle than our intuition. If a planet happens to be far enough away or under particularly favorable circumstances, it may survive. Its orbit will almost certainly be transformed, but the planet itself may remain. In several remarkable systems, astronomers have discovered planets orbiting pulsars, the dense, stellar remnants left behind after supernova explosions. The exact histories of these systems are still being investigated. Some planets may have survived the explosion itself. Others may have formed later from the material left behind. What matters most is this: even after one of the most violent events in the universe, the story is not necessarily over. Perhaps that is the first lesson nature quietly offers us. The end of one chapter is not always the end of the entire book. Carl Gustav Jung once wrote, "There is no coming to consciousness without pain." Jung was never glorifying suffering. He simply observed that profound transformation often follows life's greatest upheavals. Seen through science, a supernova is a physical event. Seen symbolically, it reminds us that dramatic change sometimes opens possibilities that could never have existed before. Yet not every planet receives another beginning. Some worlds orbit so close to their stars that, as those stars age and expand into red giants, the stars' swollen outer atmospheres gradually reach the planets themselves. Imagine a world that has traveled peacefully around its star for billions of years, returning faithfully to the same place with every orbit, following the same path again and again. Then one day, its star slowly begins to grow. The distance that once guaranteed safety is no longer enough. The planet gradually sinks into the star's expanding atmosphere. There is no violent collision, no sudden explosion, only a process that unfolds almost imperceptibly, slowly, quietly, until that world disappears within the very star that once sustained it. Whenever I imagine such a scene, it feels both heartbreaking and strangely beautiful. Because in the universe, the very thing that gives life may also be what gently brings one chapter to its close. Our voyage continues. Ahead lie planets experiencing gravitational forces so intense that their very shapes begin to change. This often occurs among planets orbiting extraordinarily close to their stars. The side nearest the star feels a stronger gravitational pull than the far side. Gradually, the entire planet stretches toward its star. Instead of remaining nearly spherical like Earth, it begins to resemble something closer to an elongated egg. In even more extreme cases, if the planet moves beyond the Roche limit, the distance where its own gravity can no longer hold it together, tidal forces from the star slowly begin to tear it apart. Its material is pulled into long streams that gradually disperse into the surrounding space. It is not an instant destruction. It is a slow unfolding, the tragic fate of planets. But the process cannot be reversed. What is remarkable is that astronomers do not see this as a tragedy in the emotional sense. It is simply the consequence of the laws of gravity. The universe is not biased. It simply follows its laws. That quiet impartiality reminds me of one of Carl Gustav Jung's reflections. Life calls not for perfection, but for completeness. Some planets endure for an astonishingly long time. Others meet their end much sooner. Yet every world fulfills the story that the laws of physics have written for it. The life of a planet is not measured by how long it survives forever. It is measured by the role it plays in the greater tapestry of the universe. Some planets undergo another transformation, one that is incredibly slow, yet deeply fascinating. Their atmospheres are gradually stripped away. Under the relentless assault of intense radiation and stellar winds, the lightest gases slowly escape the planet's gravitational pull. Millions of years pass. The atmosphere grows thinner. A world once wrapped in thick layers of gas gradually begins to reveal its true structure. This phenomenon does not occur only on exoplanets. Even within our own solar system, Mars serves as an example of how the gradual loss of an atmosphere can dramatically reshape a planet over geological time. Although the mechanisms and the scale differ from those affecting many exoplanets orbiting extremely close to their host stars, Carl Gustav Jung once wrote, "Knowing your own darkness is the best method for dealing with the darknesses of other people." Read slowly. That thought evokes a beautiful image. Sometimes, only after the outer layers have been stripped away do we begin to see what truly lies within. Of course, this is only a symbolic analogy. A planet losing its atmosphere is a physical process. Human growth is a psychological one. Neither field explains the other. Yet both share a powerful image of revealing one's true nature. What I love most about the so-called tragic destinies of planets is that they do not leave me feeling hopeless. Quite the opposite. They leave me feeling humble, because everything in the universe is changing. No star is immortal. No planet lasts forever. And yet it is through the deaths of stars, through supernova explosions and other extraordinary cosmic events that many of the heavy elements are forged and scattered into space, becoming the raw material for new generations of stars, planets, and ultimately, life itself. Carl Gustav Jung once wrote, "In all chaos, there is a cosmos. In all disorder, a secret order." Perhaps nowhere does that thought feel more appropriate than in this chapter. What we perceive as tragedy from a human perspective is often only a tiny part of the universe's far greater cycle of creation. A planet comes to an end. A star grows old. A planetary system changes. And from that change, new stories quietly begin. As our imaginary spacecraft gently leaves behind these worlds facing such difficult destinies, the silence of space slowly returns. The stars continue to shine. The planets continue their quiet journeys along their orbits. And perhaps, as you slowly drift towards sleep, what remains with you will not be the image of worlds stretched by gravity, torn apart by tidal forces, or consumed by their aging stars. Perhaps what remains is a quiet sense of peace that in the universe, just as in life, no ending is ever entirely without meaning. Every transformation becomes part of a much larger story, where even loss can quietly prepare the way for a beginning we have not yet lived long enough to see. Reading atmospheres through light. Perhaps the greatest miracle of science is not that humanity has built enormous telescopes or extraordinary machines. Perhaps the greater miracle is that we have learned to listen to things that seem completely silent. A single particle of light leaves a star hundreds of light years away, crosses the immense emptiness of the galaxy, and carries with it unimaginably tiny clues. From that light alone, we can tell whether a distant planet contains water vapor, whether sodium is present in its atmosphere, whether clouds drift across its skies, or even whether enormous storms are quietly unfolding high above its surface. Tonight, our imaginary spacecraft will not land on any planet. Instead, we will remain far away, quietly observing a beam of light, discovering how humanity learned to read worlds it has never touched. Long ago, when our ancestors looked up at the night sky, they could only guess at the true nature of the stars. They were far too distant to reach, far too small to reveal any details. Then science uncovered something extraordinary. Light does more than allow us to see an object. Light carries the story of the object itself. When a planet passes in front of its host star, a tiny fraction of the starlight filters through the planet's atmosphere before reaching telescopes on Earth. Along that journey, molecules within the atmosphere absorb specific wavelengths of light. Every atom, every molecule, leaves behind its own unique fingerprint in the spectrum. This is the foundation of transmission spectroscopy, one of the most important techniques astronomers use to study the atmospheres of exoplanets. It is astonishing to think that no one has touched that planet. No one has collected a sample of its air. No one has ever stood upon its surface. And yet, from nothing more than light, humanity can discover what exists there. Perhaps this is one of curiosity's most beautiful victories. One of the molecules scientists are especially interested in is water vapor. Detecting water vapor in the atmosphere of an exoplanet does not necessarily mean that the planet has oceans or life. In many cases, water vapor exists on worlds that are far too hot or far too cold for liquid water to survive on the surface. But every detection teaches us something new about that world's history, its chemical composition, and the physical conditions that shape it. Whenever I think about that, I picture a single drop of water, tiny, transparent, yet capable of telling the story of an entire planet. Next comes carbon dioxide, CO2. Today, thanks to powerful observatories such as the James Webb Space Telescope, astronomers have detected the signatures of carbon dioxide in the atmospheres of several exoplanets. This discovery does not mean those planets are Earth-like. Instead, it allows scientists to build better models of their atmospheric composition, their evolutionary history, and the chemical balance that governs those distant worlds. Then there is sodium. In the early years of the 21st century, astronomers detected sodium in the atmosphere of the exoplanet HD 209458b, marking one of the very first direct detections of a chemical element in the atmosphere of a world beyond our solar system. How remarkable! An element we encounter every day in ordinary table salt exists as well on a planet hundreds of light years away from Earth. That realization somehow makes the distance between worlds feel a little smaller, because it turns out that the very atoms that make up Earth are the same atoms scattered throughout the universe. Carl Gustav Jung once wrote, "In all chaos there is a cosmos, in all disorder a secret order." Perhaps nowhere does that thought become clearer than in spectroscopy. At first glance, light appears to be nothing more than a continuous band of color, but when examined carefully, tiny dark lines begin to emerge. And every one of those lines tells the story of an element, a molecule, a fragment of a world's history. What first appears to be chaos is, in fact, a remarkably precise order. Water vapor and carbon dioxide are only the beginning. On many extremely hot exoplanets, astronomers have also detected the signatures of metals in their atmospheres. At temperatures reaching thousands of degrees Celsius, iron, magnesium, titanium, and other elements can exist as vapor, participating in chemical reactions and atmospheric circulation in ways entirely unlike anything we experience on Earth. There are worlds where the skies contain more than clouds of water. They may also be filled with clouds of minerals. tiny silicate particles, crystals condensed from materials that, on Earth, we know only as solid rock. Current atmospheric models also suggest that many exoplanets possess enormous storms, stretching for thousands of kilometers, with gases racing at extraordinary speeds between different atmospheric layers. These are not storms that last only a few days, as they often do on Earth. Some may persist for extraordinarily long periods, sustained by the immense energy of their host star and the unique structure of the planet itself. The more carefully astronomers observe, the more they discover that an exoplanet's atmosphere is rarely a single, uniform layer. Instead, it is made up of many layers, each with its own temperature, its own pressure, its own chemical composition, its own clouds. Just as Earth's atmosphere is divided into the troposphere, the stratosphere, and many other layers, numerous exoplanets also possess astonishingly complex atmospheric structures. That thought makes me think about human beings, not as a scientific conclusion, but as a symbolic image, because perhaps each of our inner lives resembles an atmosphere with many layers. There is the layer of conscious awareness, the layer of memory, emotions that remain close to the surface, and deeper layers that even we ourselves rarely reach. Carl Gustav Jung once wrote, "Until you make the unconscious conscious, it will direct your life, and you will call it fate." Read slowly. That sentence reveals something beautiful. Jung was inviting us to do something remarkably similar to what astronomers do, not merely to look at the surface, but to learn how to read the faintest signals, a dream, a symbol, a passing emotion, just as scientists read a spectrum to understand the atmosphere of a distant planet. Jung believed that human beings could learn to listen to the subtle language of the unconscious in order to understand themselves more deeply. Of course, this is only a symbolic analogy. Spectroscopy and analytical psychology belong to entirely different fields. Yet they share something profoundly beautiful: patience, the willingness not to rush toward conclusions, not to stop with what is immediately visible, but to quietly search for meaning within the smallest traces. Perhaps what I love most about this part of our journey is realizing that light is not only something we see, it is also something that tells stories. A single beam of light can carry the history of an entire planet. It can speak of water vapor, of carbon dioxide, of sodium, of metals, of cloud layers, of immense storms, of an entire world where no human being has ever set foot. Carl Gustav Jung once wrote, "Who looks outside, dreams. Who looks inside, awakes." Perhaps tonight, those two journeys meet in one beautiful place. We look outward to understand the universe, and inward to understand ourselves. Both begin in exactly the same way, by learning to observe, by learning to listen, by trusting that even the smallest signals may contain an entire world. As our imaginary spacecraft quietly departs from these planets, whose stories can be told only through light, the vastness ahead becomes peaceful once again. Like an endless cosmic ocean, the rays of light continue their journey across the galaxy, carrying messages that began traveling long before humanity ever existed. And perhaps, as you slowly close your eyes and drift towards sleep, what remains with you will not be terms like spectroscopy or layered atmospheres. Perhaps what remains is a quiet sense of peace that both the universe and the human soul are always whispering to us through the smallest of signals. And if we are patient enough to listen, we may discover that even the faintest ray of light can tell the story of an entire world. Worlds beyond the reach of language. The farther we journey among the stars, the more humbling one truth becomes. Human language was born from life on Earth. We have words for the scent of rain after a long summer, the blue of the ocean, the whisper of leaves in the wind, and the warmth of morning sunlight. But what happens if, one day, we stand before a world unlike anything humanity has ever experienced? How would we describe a sky where rock evaporates into clouds, How could we speak of winds carrying glowing particles of molten metal? Or a planet so light that it seems to defy everything our intuition tells us about matter? Tonight, our imaginary spacecraft will carry us to places that science can measure, but where language itself sometimes falls silent. In everyday life, scent is deeply tied to memory. The smell of wet grass after rain can return us to childhood. The fragrance of a familiar flower can awaken memories we believed had long since faded. Smell is one of the oldest languages of the human brain. Yet somewhere, among the distant planets, if we could somehow experience their atmospheres, what we encountered would almost certainly be unlike anything we have ever known. Scientists cannot literally smell the atmosphere of an exoplanet. However, by studying its chemical composition through spectroscopy, they can infer that some atmospheres may contain sulfur compounds, hydrogen sulfide, sulfur dioxide, and many other molecules. If a human could somehow stand within such an environment, which in reality would usually be impossible because of the extreme conditions, the odor might remind us of sulfur, rotten eggs, or other pungent compounds familiar on Earth. But that is only an act of imagination. No one has ever stood upon those worlds. No one has ever truly breathed their air. Science offers us not direct experience, but the ability to imagine, guided by evidence. On extremely hot planets, where temperatures are high enough for many elements to exist as vapor, the atmosphere may contain iron, magnesium, sodium, and other metallic gases. We cannot know exactly how such an environment would smell to a human being, because nothing like it exists within ordinary human experience. Yet, simply imagining an atmosphere filled with materials that exist as solid metals on Earth is enough to stretch the imagination. There are worlds where even the air itself is unlike anything we have ever known. And suddenly, words begin to feel too small. That thought reminds me of Carl Gustav Jung. Throughout his life, Jung often spoke about the limitations of language when we attempt to describe the deepest experiences of the human soul. For him, symbols, dreams, and images often conveyed truths that ordinary words could never fully express. He once wrote, "The dream is a little hidden door in the innermost and most secret recesses of the soul." Perhaps the same is true of the universe. There are worlds that cannot be understood merely with words like hot, cold, wind, or rain, because every one of those ideas was born from Earth. As our journey continues, we encounter phenomena that even astronomers describe with great care. The weather on many exoplanets is not simply different from Earth's. It reaches beyond our very definition of weather. On Earth, weather means clouds, rain, wind, snow, and storms. But on some scorching exoplanets, clouds may be composed of silicate minerals or condensed metallic compounds. Rain may consist of molten droplets or falling mineral particles. Winds may race across the planet at thousands of kilometers per hour, and the sky itself may bear no resemblance to Earth's familiar blue. Scientists still use words like cloud and rain because they are the closest comparisons our language can offer. Yet in reality, what happens on those distant worlds may be profoundly unlike anything humanity has ever experienced. Perhaps this is where science becomes most humble, not because it knows everything, but because it is always willing to admit when its own language is no longer sufficient. Carl Gustav Jung once wrote, "Thinking is difficult. That's why most people judge. When confronted with something entirely unfamiliar, our instinct is often to force it into familiar categories." Science teaches us something different. Sometimes the wisest response is simply to acknowledge that we do not yet possess the right words to describe a new reality. Then our imaginary spacecraft carries us toward another extraordinary kind of world, one that challenges our intuition about matter itself. These are the super-puff planets. Some exoplanets are nearly as large as Jupiter, or even larger, yet possess only a fraction of its mass. As a result, their average density is astonishingly low, lower than water, and in some cases, far lower than anything we instinctively associate with a planet. These remarkable worlds have earned the charming nickname superpuffs. At first glance, the idea seems impossible. How can a planet so enormous be so light? Current models suggest that their remarkably low density may result from extremely thick atmospheres and unusual internal structures, although many questions remain unanswered. These planets remind us that even concepts like heavy and light do not always agree with the intuition we developed here on Earth. There is something beautiful about that. The universe does not try to resemble what humanity already understands. It simply exists as itself. Carl Gustav Jung once wrote, "The privilege of a lifetime is to become who you truly are." Seen as a symbol, perhaps these delicate worlds are telling a gentle story. They do not need to resemble Jupiter. They do not need to resemble Earth. They do not need to resemble anything else. They simply exist in the way nature has shaped them. Perhaps human beings are much the same. Many of our anxieties arise from trying to resemble someone else's ideal. The successful person, the strong person, the perfect person. But Jung believed that the most important journey is never becoming someone else. It is discovering who we truly are. Of course, this is only a symbolic analogy. A planet has no consciousness, and psychology cannot be derived from astrophysics. Yet sometimes the images offered by the universe allow us to express truths that lie deep within the human spirit. Perhaps what I love most about this part of our journey is the feeling that language itself slowly reaches its limits. Not because knowledge has come to an end, but because wonder has begun to exceed what words can contain. It is like standing beneath a sky filled with stars, or beside the ocean on a moonless night. Some moments are so beautiful that silence alone becomes enough. Carl Gustav Jung once wrote, "Who looks outside, dreams. Who looks inside, awakes." Perhaps the more we explore worlds beyond the reach of language, the more we discover that both the universe and the human soul are vastly larger than the vocabulary we possess. And perhaps it is precisely where language ends that contemplation truly begins. As our imaginary spacecraft quietly drifts deeper into the silent reaches of space, the sulfur-scented worlds, the skies filled with metallic clouds, and the feather-light planets slowly disappear into the endless darkness. Yet the sense of wonder they leave behind remains, a gentle reminder that not every miracle needs a name. Some forms of beauty are meant simply to be felt in silence, like a dream, like the night sky, or like the deepest part of the human soul that Carl Gustav Jung spent a lifetime learning to hear. Young planets. There is something fascinating about the way human beings think about time. We often imagine a planet as a finished world, one with a sky, a solid surface, and stable cycles that have endured for billions of years. But the truth is that planets have a childhood of their own. They do not appear instantly in the form we recognize today. Like stars, they are born from vast clouds of gas and dust. Like stars, they pass through turbulent, fiery, and unstable beginnings before gradually maturing. Tonight, our imaginary spacecraft will journey backward through time, returning to worlds that are still very young, where each planet still carries the warmth of the day it was born. If you could observe a newly formed planet from nearby, you might be surprised. It would not resemble Earth. It would not resemble Jupiter. In fact, it would not yet fully resemble the future version of itself. Current models of planetary formation suggest that after accumulating material from the disk of gas and dust surrounding a young star, many planets retain an enormous amount of internal heat. That heat is the result of countless collisions, gravitational compression, and the accumulation of material during their earliest stages of formation, which means a newborn planet still carries the memory of its own creation. It is still radiating heat, still cooling, still changing. During this stage, many young planets appear unusually swollen, not because they continue gathering large amounts of material, but because their internal heat prevents them from contracting completely. Over time, as they gradually radiate that heat into space, they shrink, and slowly settle into a more stable state. That may sound highly technical, but if we listen carefully, there is something remarkably gentle hidden within it. A young planet does not rush to become perfect. It needs time to cool, to settle, to become itself. Carl Gustav Jung once wrote, "The privilege of a lifetime is to become who you truly are." Perhaps no astronomical image reflects those words more beautifully than the youngest planets. Jung never suggested that human beings are born complete. He spoke instead of a journey, a process, a gradual unfolding. Planets are much the same. No world appears fully finished from the very beginning. They grow with time. What makes young planets especially fascinating is that they remain hot long after they are born. Ordinarily, astronomers discover exoplanets using indirect methods, such as measuring the tiny dimming of a star when a planet passes in front of it, or detecting the minute wobble in the star's motion caused by the planet's gravity. But for some very young planets, the story is different. They are still so warm, in fact, that they emit enough infrared radiation for modern telescopes to detect them directly. That is why a handful of young planets have become some of the very few exoplanets humanity has ever photographed directly. Of course, these images look nothing like the detailed photographs of Earth taken from orbit. They usually appear as tiny points of light beside their host stars. Yet the simple fact that humanity can directly observe the glow of a planet located dozens or even hundreds of light years away is an extraordinary achievement. How remarkable! Not because the planet shines more brightly, but because it is still so young, still carrying the warmth of its cosmic childhood. One of the best-known examples is the HR 8799 system, where astronomers have directly imaged several young giant planets by detecting the infrared radiation they emit. Observations like these have opened an entirely new window into understanding how planets form and evolve. That light does not come from a sun. It comes from the planet itself, a very faint light, yet one strong enough to travel across hundreds of light years of space. That thought reminds me of another line from Jung: "Who looks outside, dreams. Who looks inside, awakes." Seen as a symbol, perhaps young planets are doing something similar. Their light is not yet entirely dependent upon their star. During this early stage, they still carry heat generated from deep within themselves. This does not mean that people are like planets. It is only a metaphor. Yet sometimes the images of the universe remind us that the most enduring sources of energy do not always come from outside ourselves. Some fires are nourished from deep within. In astronomy, infrared telescopes are especially important for studying young worlds. The human eye can perceive only a tiny portion of the electromagnetic spectrum, but in the infrared, planets that still retain the heat of their formation become far easier to detect, which means, sometimes, to see something clearly, we must learn to look with different eyes, not because the universe has changed, but because our way of observing it has changed. Carl Gustav Jung once wrote, "Everything that irritates us about others can lead us to an understanding of ourselves." If we broaden the meaning of those words, perhaps Jung is reminding us that every new perspective has the power to reveal a part of reality we had never noticed before. Science works the same way. When humanity built infrared telescopes, the universe did not create new planets. Those worlds had been there all along. We had simply learned how to see them. Perhaps human growth is not about becoming someone entirely different. Perhaps it is about gradually discovering what has always existed within us. What I love most about young planets is not their size, nor their temperature. It is the feeling that they are still becoming. Not yet complete, not yet settled, not yet finished. And that is perfectly natural. In life, many of us worry because we are not yet skilled enough, not yet strong enough, not yet successful enough. But if we look up at those young planets scattered across the universe, we begin to see that nature itself is never in a hurry. A world takes millions of years to mature. A star requires tens of millions of years before it reaches stability. The universe has never demanded that perfection happen overnight. Carl Gustav Jung once wrote, "Life calls not for perfection, but for completeness." Perhaps that is the gentlest gift these young planets offer us. You do not have to be perfect today. You simply need to keep growing, keep learning, keep transforming, just like a planet that still carries the warmth of the day it was born. As our imaginary spacecraft slowly leaves behind those worlds still glowing with the heat of their youth, space becomes quiet once again, like an endless ocean without shores. Those planets will continue to cool over millions of years, silently maturing among the stars. And perhaps, as you gradually drift into sleep, what remains with you will not be the image of infrared radiation or giant telescopes, but a quiet sense of peace, that both the universe and every human being have the right to grow at their own pace. No one needs to rush toward a perfect version of themselves, for sometimes the truest beauty is found in the quiet journey of becoming the person we were always meant to be. The most distant planets. The deeper we journey into the universe, the more we realize that distance cannot be measured by numbers alone. There are worlds so distant that their light requires hundreds, thousands, or even tens of thousands of years to reach us. Some planets orbit at the very edges of enormous stellar systems, quietly following paths where a single orbit may take tens of thousands of Earth years to complete. Others are so remote that no human eye has ever seen them directly. We know they exist only because of the faintest and most delicate clues. Tonight, our imaginary spacecraft will carry us to the most distant planets humanity has ever discovered. Worlds that remind us that patience is as essential to science as it is to understanding ourselves. Here on Earth, we are accustomed to the rhythm of a single year, 365 days, spring, summer, autumn, winter. But out there, some planets orbit so far from their stars that the familiar meaning of a year almost disappears. A single revolution may last hundreds, thousands, or even far longer, depending on the distance from the star and the star's mass. Imagine such a world. If someone lived there only as an exercise of imagination, they might spend their entire lifetime without ever witnessing their planet complete one full orbit around its sun. A single season could last longer than the history of entire civilizations on Earth. Time itself would not pass more slowly. It would simply be experienced according to a different rhythm. There is something deeply peaceful about that thought, because the universe has never been in a hurry. Every planet keeps its own pace. Astronomers have also found that planets orbiting extremely far from their host stars raise fascinating questions about how planetary systems form. According to traditional models, building a giant planet at such great distances may be difficult because the protoplanetary disk contains much less material than far from the star. For that reason, the origins of some distant planets remain an active area of research. Some models suggest that they formed where they are today. Others propose that they were born closer to their stars before gradually migrating outward through gravitational interactions. What matters is not that we already possess the final answer. What matters is that science is willing to admit how much remains unknown. Perhaps that is the greatest beauty of knowledge. Not certainty, but the courage to continue asking questions. Carl Gustav Jung once wrote, "The least of things with a meaning is worth more in life than the greatest of things without it." Perhaps every distant planet carries that kind of meaning for astronomers. A single world that refuses to fit our current models can reshape our understanding of how entire planetary systems come into being. But how do we discover planets that lie so unimaginably far away? That is where we encounter one of the most elegant predictions of Einstein's general theory of relativity: gravitational microlensing. Albert Einstein showed that mass bends space-time. When one star passes directly in front of a much more distant star, its gravity acts like a natural magnifying glass, temporarily brightening the background star. If the foreground star happens to have a planet, that planet creates an even smaller disturbance in the light curve. From that tiny change, astronomers can infer the existence of an entirely new world. How extraordinary. No one sees the planet directly. No one touches it. We observe only a tiny change in light, and from that delicate signal, an entire world reveals itself. Perhaps this is one of science's most beautiful lessons. The greatest discoveries sometimes leave only the smallest traces. Carl Gustav Jung once wrote, "Who looks outside dreams. Who looks inside awakes." Seen symbolically, gravitational microlensing resembles the journey of self-discovery. The deepest truths rarely announce themselves with noise. Instead, they leave the gentlest of signals, a passing emotion, a dream, an intuition, like a distant planet that alters the light of its star for only a brief moment. Of course, this is only a metaphor. Gravity belongs to physics. Analytical psychology belongs to an entirely different discipline. Yet sometimes the universe offers us beautiful images through which we can better understand ourselves. Alongside gravitational microlensing, one of the best-known techniques for discovering exoplanets is the transit method. When a planet passes in front of its host star from Earth's point of view, the star's brightness decreases by an almost imperceptible amount. Because this dimming repeats with each orbit, astronomers can detect the planet and calculate many of its properties. This is the method that enabled missions such as Kepler and TESS to discover thousands of exoplanets. What is remarkable is this: a planet that is almost completely invisible can still be discovered, simply because it blocks the tiniest fraction of starlight. Not because of its own light, but because of the shadow it leaves behind. Perhaps life is much the same. Not everything that matters shines beneath bright lights. Sometimes, the deepest influences arrive almost silently. A single conversation, one unexpected meeting, one small act of kindness. Each is like a planet crossing the face of a distant star. It creates only the slightest change. Yet that small change can alter the orbit of an entire life. Carl Gustav Jung once wrote, "Everything that irritates us about others can lead us to an understanding of ourselves." If we read those words slowly, we discover that Jung continually invites us to notice subtle signals rather than dramatic events. It is often the smallest details that lead us toward the deepest understanding of ourselves. What I love most about the most distant planets is not their distance. It is the simple truth that, no matter how far away they are, they can still be found. Not because they try to stand out, but because humanity has learned to observe with greater patience and greater sensitivity. Perhaps that, too, is the journey of growing older. We do not always need to search for the biggest answers. Sometimes, all we need is to learn how to look more carefully at the small things unfolding each day. Carl Gustav Jung once wrote, "The privilege of a lifetime is to become who you truly are." Perhaps that journey is much like the work of astronomers searching for the most distant planets. It is not a race. It is a practice of patience, observing, listening, waiting, trusting that even the faintest signal may one day lead to a remarkable discovery. As our imaginary spacecraft quietly leaves behind the planets at the outermost edges of their orbits, and the distant worlds revealed only by the slightest glimmer of light, the vastness ahead opens once again without any visible end. And perhaps, as you slowly drift into sleep, what remains with you will not be terms like gravitational microlensing or the transit method, but a gentle feeling that, in both the universe and in life, distance is not always what separates us from the truth. If we are patient enough to observe and still enough to listen, even the most distant worlds will one day send us their very first signal, a whisper carried softly across the endless ocean of stars. How humanity discovered exoplanets. For many nights now, we have journeyed together through worlds where iron rains from the sky. Oceans lie hidden beneath eternal ice. Planets orbit beneath the light of two suns, and lonely rogue worlds drift through the galaxy without a home. But perhaps by now, a very natural question has begun to emerge. How do we know any of this? When these planets lie dozens, hundreds, or even thousands of light years away, how can we be certain that they truly exist? Tonight, instead of landing on another distant world. Our imaginary spacecraft will return to Earth itself, where we will listen to one of science's most beautiful stories. The story of how humanity learned to see what is almost invisible. If I had to choose a single word to describe that journey, it would be patience. Because exoplanets do not shine like stars. They are small, dim, and almost completely overwhelmed by the brilliant light of their host stars. If you placed Earth beside the Sun and observed the system from dozens of light years away, trying to detect our planet would be like searching for a tiny grain of dust circling an enormous lighthouse. Yet humanity refused to give up. Instead of trying to look directly at the planet, astronomers began looking for the traces it leaves behind, rather like watching a tree branch sway and realizing that an invisible breeze has just passed. One of the earliest and most successful techniques is called the radial velocity method. At first, the name sounds rather technical, but the idea itself is remarkably elegant. We often say that a planet orbits a star. That is true, but it is not the whole story. In reality, both the planet and the star orbit their shared center of mass. That means the star never remains perfectly still. It gently wobbles, a motion so incredibly small that no human eye could ever detect it. Yet modern spectrographs can. When the star moves slightly toward Earth, its light shifts ever so slightly toward the blue. When it moves away, its light shifts gently toward the red. This phenomenon is known as the Doppler effect. From these almost imperceptible changes, astronomers can estimate a planet's minimum mass, its orbital period, and many other properties. It is extraordinary. We never actually see the planet. We see only a star trembling ever so slightly. And from that subtle motion, an entire world emerges. Carl Gustav Jung once wrote, "Everything that irritates us about others can lead us to an understanding of ourselves." If we think of this symbolically, perhaps life works in much the same way. Not everything reveals itself directly. Often, we perceive only the influence something leaves behind. Just as an invisible planet can still make its star gently sway. Continuing our journey, our spacecraft now turns toward the infrared. The human eye can perceive only a tiny fraction of the electromagnetic spectrum, yet the universe shines in many forms of light beyond our natural vision. Young planets still retain enormous amounts of heat left over from their formation. Because of this, they emit much stronger infrared radiation than older planets. Using modern infrared telescopes, astronomers have succeeded in directly imaging a handful of these young worlds, particularly those orbiting far enough from their host stars that the overwhelming starlight no longer completely hides them. That reminds us of something simple. Sometimes, to truly see something, we must first learn to look with different eyes. The object itself does not need to change. Rather, it is the way we observe that must change. Carl Gustav Jung once wrote, "Who looks outside dreams. Who looks inside awakes." Perhaps science is following a remarkably similar journey, not through intuition, but by expanding the very senses of humanity. Telescopes become new eyes, spectrographs become new ears, and through them, the universe gradually tells us more of its stories. Yet perhaps what moves me most is the way astronomers study dust. Ordinarily, dust makes us think of something insignificant, something easily overlooked. But in astronomy, dust is where planets begin. Surrounding young stars are protoplanetary disks, vast disks of gas and dust. Within these disks, countless microscopic grains collide, stick together, and slowly grow over millions of years, eventually becoming planets. Today, observatories such as ALMA have captured breathtaking images of these protoplanetary disks. They appear as elegant concentric rings separated by striking gaps. The remarkable part is this: those empty gaps are often the footprints of planets that are still forming. We do not see the planet itself. We see the path it has carved. There is something deeply poetic about that idea. A world not yet complete, yet already leaving its mark. gas tells a similar story. Within these protoplanetary disks, hydrogen, carbon monoxide, and many other molecules move under the influence of gravity. By studying those motions, astronomers learn about the disk's structure, the rate at which planets are forming, and the gradual birth of entirely new worlds, clouds of dust, streams of gas, concentric rings, narrow gaps. At first glance, they seem almost ordinary. Yet through the eyes of science, they become maps of worlds that have not yet been born. Carl Gustav Jung once wrote, "In all chaos there is a cosmos. In all disorder, a secret order." Perhaps nowhere does that sentence feel more appropriate than within a protoplanetary disk. At first, it appears to be nothing more than chaotic dust. But deep within, gravity is quietly arranging everything. Tiny particles collide. They cling together. They grow. And eventually, they become planets. Perhaps our own lives unfold in much the same way. There are seasons that feel impossibly chaotic, scattered thoughts, emotions we cannot yet name, experiences whose meaning remains unclear. And yet, somewhere beneath the surface, everything may already be arranging itself into a wiser, more complete version of who we are becoming. Of course, this is only a symbolic comparison. Planet formation is a physical process. Human growth belongs to psychology. Neither explains the other. Yet both share a remarkably similar beauty. The belief that everything truly great begins with something very small. What I love most about humanity's search for exoplanets is not the thousands of worlds we have discovered. It is how we discovered them, not through force, not through noise, but through careful observation, through patience, through learning to read the faintest whispers carried by light, dust, and gas. Carl Gustav Jung once wrote, "The least of things with a meaning is worth more in life than the greatest of things without it." Perhaps science has always begun that way. A tiny wobble, a grain of dust, a barely perceptible shift in a spectrum, a narrow gap within a disk of gas. And little by little, an entire universe unfolds before us. As our imaginary spacecraft quietly departs from the great telescopes still gazing toward the night sky, millions of stars continue shining, as they have for billions of years. Yet now we know that around many of those stars are worlds invisible to the naked eye. And perhaps, as you slowly drift towards sleep, what remains with you will not be terms such as radial velocity or protoplanetary disks, but a gentle sense of peace that humanity's greatest discoveries have always begun with the quiet ability to observe. For both the universe and the human soul rarely reveal themselves all at once. They unfold only little by little before those who are patient enough to listen for the smallest of signals. The symphonies of gravity. When we think about the universe, we often imagine a place of absolute silence. There is no wind, no crashing waves, none of the familiar sounds of Earth. And that is entirely true. In the vacuum of space, sound cannot travel as it does here on our planet. Yet if there truly is a kind of music among the stars, it is not composed of sound carried through air. It is the symphony of gravity, a composition that no one hears with their ears, yet one that can be perceived through mathematics, through light, and through the astonishing precision of planetary motion. Tonight, our imaginary spacecraft will not visit a particular world. Instead, we will quietly listen to the invisible rhythm that binds billions of celestial bodies throughout the universe, as though every one of them were performing together in nature's greatest orchestra. If you have ever watched rowers lifting their oars in perfect unison, or an orchestra in which dozens of musicians perform together without a single instrument falling out of time, then you already understand that harmony possesses a beauty all its own. The remarkable thing is that, far away in the cold vastness of our galaxy, planets move together with that same kind of harmony. Astronomers call this phenomenon orbital resonance. Orbital resonance occurs when the orbital periods of two or more planets are related by simple whole number ratios, such as 2:1, 3:2, or 4:3. In other words, While one planet completes 2 orbits around its star, another completes exactly 1. Or after one planet has completed 3 revolutions, its neighbor has completed precisely 2. At first glance, these appear to be nothing more than numbers. Yet hidden within those numbers lies an astonishingly delicate balance. No planet tries to move faster than the others. No planet struggles to move ahead. Each world simply moves according to its own rhythm. And it is precisely that quiet faithfulness that creates stability for the entire system. One of the most beautiful examples is the TRAPPIST-1 system, where 7 rocky planets form an almost perfect chain of orbital resonances. Their gravitational relationship allows the system to remain remarkably stable over immense spans of time, even though the planets orbit much closer together than the planets in our own solar system. Whenever I read about systems like this, I cannot help but imagine an old mechanical clock, not one powered by batteries, but one driven by finely crafted gears, hundreds of tiny wheels, each turning at its own speed. Yet together, they keep a single measure of time. Perhaps that is why astronomers sometimes describe these resonant systems with such a beautiful image. Gravitational clocks. No one winds them. There is no conductor. There is only gravity. And gravity alone has kept these celestial bodies moving together in near-perfect rhythm for millions, even billions of years. Carl Gustav Jung once wrote, "In all chaos there is a cosmos, in all disorder a secret order." Perhaps few astronomical phenomena reflect those words more clearly than orbital resonance. At first glance, the sky seems filled with planets moving in every direction. But if we watch long enough, we begin to recognize a profound order beneath it all. An order that is not imposed, but one that nature creates for itself. Continuing our journey, we arrive at one of the most subtle techniques humanity has ever used to discover exoplanets. It is called transit timing variation, or simply TTV. Earlier, we explored the transit method, in which a planet passes in front of its host star, causing the star's brightness to dim ever so slightly. If the planet's orbit were perfectly regular, every transit would occur exactly on schedule. But nature is rarely so simple. When several planets share the same system, their mutual gravitational pull gently perturbs one another's orbits. As a result, one transit may occur a few minutes earlier than expected. The next may arrive slightly later. The difference is often incredibly small, yet from those tiny variations, astronomers can infer the existence of additional planets' worlds that have never been observed directly. It is extraordinary. An invisible planet, giving off no light, never crossing in front of its star, never appearing in a telescope, and yet, simply by causing its neighboring planet to arrive a few minutes early or late, it leaves behind a signature that humanity can detect. That idea always reminds me that not every influence has to be dramatic to be meaningful. Some changes are almost imperceptible, yet they reveal an entire world. Carl Gustav Jung once wrote, "The least of things with a meaning is worth more in life than the greatest of things without it." Perhaps that is also the spirit of the TTV method. Just a few minutes, just the smallest discrepancy, yet carrying immense significance. Throughout analytical psychology, Jung paid close attention to the subtlest signals of the inner life. A dream that appears meaningless, a symbol that returns again and again, a fleeting emotion. He believed that these seemingly insignificant moments often become the doorway to a deeper understanding of ourselves. Of course, this is only a symbolic comparison. Gravitational perturbations have nothing to do with the human unconscious, yet they beautifully illustrate the quiet power of subtlety. Perhaps life unfolds in much the same way. Not every important moment arrives as a dramatic event. Sometimes, a brief conversation, a word of encouragement, a passing glance, a chance encounter, they alter the rhythm of our lives only slightly. Yet years later, we realize that those tiny moments quietly changed the entire course of our journey. Carl Gustav Jung once wrote, "The meeting of two personalities is like the contact of two chemical substances. If there is any reaction, both are transformed. If we replaced the words two personalities with two planets, the sentence would sound almost like a poetic description of gravity itself. Two worlds do not need to collide to change one another. They need only come close enough. From that moment on, their orbits begin to shift. Human lives are much the same. Some encounters make no great noise. They do not transform everything overnight. Yet, over time, they quietly redirect the course of an entire life. What I love most about these symphonies of gravity is not their mathematical precision. It is the feeling that the entire universe is moving together. Nothing exists in complete isolation. No celestial body truly stands alone. Every planet influences another. Every orbit is shaped by countless invisible relationships. Perhaps that is also what Jung meant whenever he spoke of wholeness. Human beings do not exist as isolated islands. We are continually shaped by relationships, by memories, and by the quiet interactions we share with the world around us. As our imaginary spacecraft gently departs from these planetary systems, moving like immense gravitational clocks, the vastness ahead remains as silent as it has been since the earliest days of the universe. No sound echoes between the stars. And yet somewhere beyond our hearing, a symphony continues to unfold through gravity alone. And perhaps, as you slowly drift into sleep, what stays with you will not be terms such as orbital resonance or transit timing variation, but a quiet feeling of peace that both the universe and our own lives move according to profound rhythms that ordinary eyes cannot see. If we are patient enough to listen, we may discover that even the smallest movements help compose the magnificent music of existence. Planetary systems that were once chaotic. If we look up at the night sky with the naked eye alone, it is easy to believe that the universe has always been peaceful. The stars shine quietly. The planets silently follow their orbits. Everything seems as though it has been perfectly arranged since the beginning of time. But the deeper astronomers explore, the more they discover a profoundly humbling truth. Many planetary systems that now appear calm and orderly once endured unimaginably violent beginnings. There were colossal collisions, orbits thrown into disarray, planets hurled out of their stellar systems, worlds that merged together, others that were shattered beneath the immense power of gravity. And yet, strangely enough, it was from that very chaos that many planetary systems eventually found a stability lasting billions of years. Tonight, our imaginary spacecraft will travel backward through time to witness those turbulent first chapters of distant worlds, and perhaps, in doing so, understand a little more about how growth itself often begins amid the greatest disorder. Today, when astronomers study exoplanets, they do not examine only what those worlds are now. They also try to read their past, rather like an archaeologist studying layers of Earth to reconstruct the history of a forgotten civilization. Every orbit, every inclination, every distance may preserve the memory of events that unfolded billions of years ago. During the earliest stages of a young planetary system, millions of small bodies occupied a space that was still wildly chaotic. They collided, merged together, or had their paths dramatically altered by gravity over immense spans of time. Countless interactions gradually built the planets we see today. That means the peace we witness now may have been forged through countless collisions long ago. One of the leading explanations for the origin of Earth's moon begins with precisely such an event. According to the giant impact hypothesis, the young Earth may have collided with a Mars-sized body, commonly known as Theia. The material ejected by that collision eventually gathered together, forming the Moon. If this hypothesis is correct, then the companion that has orbited Earth for billions of years was born from extraordinary violence. There is something profoundly moving about that thought, a great beauty. Born from a collision, beyond our own solar system, many planetary systems also bear signs of turbulent pasts. Some planets follow highly eccentric or strongly inclined orbits. Others occupy positions that are difficult to explain using simple models of planetary formation. These observations suggest histories filled with powerful gravitational encounters, orbital migration, and chaotic interactions during the earliest days of their systems. Carl Gustav Jung once wrote, "In all chaos there is a cosmos. In all disorder, a secret order." Few astronomical images illustrate those words more beautifully than the history of planetary systems. At first, there is only chaos, collisions, destruction, transformation. Yet billions of years later, a new order quietly emerges. Continuing our journey, our spacecraft now arrives at another remarkable process: merging. During planetary formation, small bodies do not always destroy one another. If their speed and angle are just right, they may stick together, forming a larger world. Across millions of years, countless mergers like these gradually built the planets we observe today. How extraordinary! A planet is not a single object born all at once. It is the result of countless encounters, countless fragments of matter, countless moments of connection, countless small stories, woven together into one world. That thought reminds me of another quotation from Jung. "The meeting of two personalities is like the contact of two chemical substances. If there is any reaction, both are transformed." Jung was speaking about people. Yet, as a symbol, planets seem to tell a remarkably similar story. Every encounter, every collision, every meeting leaves behind a transformation. No celestial body remains exactly as it was before. Even more remarkable is this: not every planet disappears during these chaotic beginnings. Some survive. They continue orbiting their stars, carrying within their orbits, their internal structures, or their atmospheres, the lasting marks of ancient history. In many ways, astronomers become detectives. They never witness these primordial collisions directly. Instead, they examine the evidence left behind: an unusual orbit, an unexpected inclination, a planet missing part of its mass, a mysterious gap within a planetary system. From these scattered clues, the history of an entire system gradually comes into focus. That reminds me of human memory. None of us can return to the past. Yet the past never truly leaves us. It remains in the way we respond, in the things we love, in our fears, in our hopes. Jung once wrote, "Until you make the unconscious conscious, it will direct your life and you will call it fate." Perhaps he meant that every person carries within themselves an invisible history. Much like a planetary system, the surface may appear peaceful, yet beneath it lie countless stories that shaped the person we have become. Of course, this is only a symbolic comparison. Astronomical collisions and psychological development do not operate according to the same laws. Yet both reveal something deeply beautiful. The past is not merely something that happened, it is something that continues to shape the present. What I love most about planetary systems that were once chaotic is not the violence they endured. It is their capacity to recover. Over millions of years, their orbits gradually become stable, their planets find their places. Chaotic motions slowly transform into steady rhythms, as though the universe itself knows how to heal. Carl Gustav Jung once wrote, "There is no coming to consciousness without pain." Perhaps those words belong not only to human beings, at least when understood as a symbol. The planetary systems themselves also seem to pass through countless upheavals before finally reaching equilibrium, not because suffering is always necessary, but because growth is often the result of a long journey. Some things can only be arranged by time. Some wounds require millions of years to soften, and some forms of chaos reveal themselves as part of a greater order only when viewed from far enough away. Carl Gustav Jung once wrote, "The privilege of a lifetime is to become who you truly are." Perhaps a planetary system is following that very journey, not becoming another star system, not becoming our solar system, but gradually finding the balance that belongs to its own unique history. As our imaginary spacecraft slowly leaves behind those planetary systems that once endured tremendous collisions, the silence of the stars unfolds once more before us. It is difficult to believe that beneath such tranquility lies a history filled with extraordinary upheaval. And perhaps, as you slowly drift toward sleep, what remains with you will not be the image of violent impacts or disrupted orbits, but a gentle reassurance that both the universe and the human soul possess an extraordinary ability to rediscover balance after seasons of chaos. Sometimes the peace we experience today does not exist because there were never storms, but because the storms have already passed, and we continue to move forward quietly, faithfully, along the unique orbit that belongs to us alone. Young worlds. When we gaze into the night sky, it is easy to imagine that every planet has existed for an unimaginably long time. They appear before us as complete, peaceful worlds that seem almost unchanged. But if the history of the universe could be rewound like an enormous film, we would witness something entirely different. Planets, too, once had a childhood. They began as unstable masses of matter, hot, turbulent, and constantly changing. They were not born with oceans, mountains, or familiar skies. Every world began with a long story written by dust, gas, heat, and time. Tonight, our imaginary spacecraft will travel back to those earliest days, where we will quietly meet the youngest planets of all worlds, still learning how to become themselves. If you could stand close enough to see a planet just after its birth, the sight would probably be nothing like what you imagine. There would be no blue sky, no forests, no oceans, only a great mass of glowing material, still blazing with immense internal heat. During the earliest stages of planetary formation, many young worlds remain partially or even almost completely molten. Their heat comes from several different sources. The continual impacts of material during planetary accretion, the immense compression caused by gravity, and the radioactive decay of naturally occurring elements. When the interior becomes hot enough, rock can no longer remain solid as it does on present-day Earth. Instead, the entire surface may become a vast ocean of magma. Imagine such a world. There is no sound of waves, only rivers of molten rock, no white clouds, only skies thick with dust and mineral vapor, no peaceful sunrise, only the deep crimson glow reflected across oceans of lava. And yet, from worlds as harsh as these, one day, gentler planets may eventually emerge. Perhaps that is the first story nature wishes to tell us. Peace is rarely the beginning. More often, it is the destination of a very long journey. Carl Gustav Jung once wrote, "There is no coming to consciousness without pain." Jung was not speaking about planetary geology, but viewed as a symbol. His words seem remarkably close to these young worlds. They do not mature overnight. They need time to cool, to settle, to discover the stable structure that belongs uniquely to them. Continuing our journey, our spacecraft now enters the protoplanetary disks surrounding young stars. These enormous rings of dust and gas are places where billions of tiny particles constantly collide. At first, each grain is no larger than a speck of sand, but after countless encounters, they begin to stick together, forming pebbles, then planetesimals, then protoplanets, and eventually fully formed planets. The remarkable thing is, there is no blueprint, no builder, no guiding hand, only gravity and time. Two forces so quiet, yet together capable of creating entire worlds. Modern observatories such as ALMA have captured breathtaking images of these protoplanetary disks, revealing bright, concentric rings separated by striking gaps. Those gaps are widely interpreted as evidence that young planets are already taking shape, sweeping material away as they travel along their growing orbits. That means that today, we are not only studying fully formed planets, we are also able to observe the very nurseries where new worlds are being born. There is something deeply moving about that thought. Humanity, a species living on one small planet, has learned to glimpse the birthplaces of entirely different worlds. Carl Gustav Jung once wrote, "Who looks outside, dreams. Who looks inside, awakes." Perhaps science and psychology meet in that very spirit. Neither is interested only in the final result. Both seek to understand the process of becoming. Astronomers ask, how is a planet born? Jung asks, how does a human being become who they truly are? They are different questions, yet both point toward origins. From a scientific perspective, the formation of a planet unfolds over millions of years. Giant molecular clouds collapse to give birth to stars. Around those newborn stars, disks of gas and dust begin to form. Within these cosmic cradles, planets gradually accumulate material, collide, grow larger, heat up, and eventually cool down. Some become rocky worlds, others grow into giant gas planets. Some are destroyed or ejected from their planetary systems altogether. No two planetary systems are exactly alike. That thought reminds me of people. No two of us share the same childhood. No two of us follow the same path toward adulthood. No two of us grow along the same orbit. Of course, this is only a symbolic comparison. Planet formation belongs to physics. Human development belongs to psychology and society. Neither field explains the other. Yet both remind us that every existence carries a history uniquely its own. Carl Gustav Jung once wrote, "The privilege of a lifetime is to become who you truly are." Perhaps the most beautiful thing about young planets is that they are unfinished. They are still changing, still moving, still learning how to become stable, and nature does not regard that as a flaw. On the contrary, it is the most natural thing in the universe. In our own lives, we sometimes worry too much because we are not yet mature enough, not knowledgeable enough, not strong enough. But if we look toward those young planets scattered across the cosmos, we discover that even the universe allows millions of years for a world to learn how to become itself. No one expects a newborn planet to possess oceans immediately. No one demands perfection. It simply continues to exist, continues to cool, continues to change. Carl Gustav Jung once wrote, "Life calls not for perfection, but for completeness." Perhaps that is the gentle message these young worlds wish to share with us. You do not need to hurry. You do not need to compare yourself with those who have traveled much farther along their path. Every planet has its own timescale. Every star follows its own rhythm. And every human being has a journey of growth that belongs to them alone. What I love most about these youthful planets is not their heat. It is their hope. The hope that continents may someday emerge from oceans of magma, that entire worlds may arise from drifting dust, that order may slowly grow from chaos. The universe has never been in a hurry, yet it has never stopped creating. As our imaginary spacecraft slowly leaves behind these worlds, still glowing red in the dawn of their existence, the silence of the cosmos stretches out before us once again. Those planets will continue changing for millions of years before reaching greater stability. And perhaps, as your eyes gently close and sleep begins to find you, what will remain is not the image of molten oceans or immense disks of cosmic dust, but a quiet sense of peace, that neither the universe nor the human soul is born in a state of perfection. Both grow little by little, both transform little by little, and perhaps it is that patient journey itself that gives every form of life its deepest beauty. Habitability is not simple. Throughout our journey among the extraordinary planets of the universe, one question has quietly accompanied us all along. Could life exist somewhere beyond Earth? It is one of humanity's oldest questions. Whenever astronomers discover a new exoplanet, one of the first questions people ask is, could this planet be habitable? Yet the deeper science explores, the more it realizes that the answer is far from simple. There is no single formula, no single requirement. A planet may orbit at exactly the right distance from its star and still be utterly inhospitable to life. Meanwhile, another world in what seems to be an impossibly frozen realm may quietly hide vast oceans beneath an ancient shell of ice. Tonight, our imaginary spacecraft will guide us toward one of the most beautiful ideas in modern astronomy. Habitability is not a destination. It is a delicate balance created by countless conditions working together. For many decades, scientists have often referred to a concept known as the habitable zone. It is the region around a star where, under certain assumptions, temperatures on a planet's surface may allow liquid water to exist. The idea sounds wonderfully simple. If a planet is too close to its star, its water will evaporate. If it is too far away, its water will freeze. Somewhere in between, liquid water might exist, and from there, perhaps life could emerge. For many years, this concept served as a compass, guiding astronomers in their search for potentially habitable worlds. But once again, the universe invited humanity to be humble, because distance alone is not enough. Two planets, orbiting at exactly the same distance from their star, can experience completely different destinies. One world may be temperate and gentle, another may be as hot as a blazing furnace. The difference lies in many other factors. One of the most important is the atmosphere. Earth is not suitable for life simply because it orbits at the right distance from the Sun. We also possess an atmosphere that retains heat, moderates our climate, and shields the surface from much of the sun's harmful radiation. If an atmosphere is too thin, heat escapes too quickly. If it is too thick and rich in greenhouse gases, the planet may become so hot that liquid water can no longer survive. That means a planet needs more than the right location. It also needs the right protective cloak. There is something quietly beautiful in that thought. A world's fate is determined not only by where it is, but also by how it preserves itself. Carl Gustav Jung once wrote, "Life calls not for perfection, but for completeness." Perhaps those words also resonate beautifully with astronomy. No single condition is enough to create a habitable world. Only the harmonious combination of many different factors makes such a possibility possible. Continuing our journey, we encounter clouds. On Earth, clouds both reflect sunlight and trap part of the heat radiated from the surface. They play a vital role in the water cycle and have a profound influence on climate. On exoplanets, the role of clouds can be even more diverse. Some are made of water, some of ammonia, others of silicate compounds. On extremely hot planets, clouds may even form from minerals that, on Earth, we know only as solid rock. A cloud, at first glance, it seems so light, yet sometimes it determines the destiny of an entire world, because a small change in the amount of sunlight reflected or heat retained can dramatically transform a planet's climate. Then there are oceans. Across many human cultures, water has always been a symbol of life. It is no coincidence that when scientists search for life beyond Earth, they pay special attention to the presence of liquid water. Yet even water is not the complete answer. A planet may contain enormous amounts of water, perhaps even too much. Current models suggest that water-rich planets may exist worlds where water makes up much of the outer layers, under conditions of extremely high pressure and temperature. However, water does not necessarily exist as familiar oceans like those on Earth. Instead, it may become superheated steam or transition into other exotic phases of matter, creating environments very different from anything we know. That reminds us of something important. Water alone is still not enough. Perhaps this is one of the most beautiful lessons science has learned. The more we understand, the more we discover how subtle reality truly is. Carl Gustav Jung once wrote, "Thinking is difficult. That's why most people judge. Perhaps many people hope for a simple answer, the right distance, liquid water, oxygen. That should be enough. But nature does not operate according to such simplified formulas. Every planet tells its own story. Every world exists through its own delicate balance. Viewed symbolically, this also makes me think of human life. We often ask ourselves, what creates a happy life? Money? Meaningful work? Family? Health? Love? Perhaps no single answer is sufficient, just like a planet. A human being also requires many different conditions to flourish. Of course, this is only a symbolic comparison. Planetary habitability belongs to science. Inner life belongs to psychology. Neither field explains the other. Yet both share a remarkably beautiful lesson. The things that matter most rarely depend on only one factor. Carl Gustav Jung once wrote, "The privilege of a lifetime is to become who you truly are." Perhaps becoming ourselves also requires a kind of habitable zone within the soul, a place with enough peace, enough genuine relationships, enough quiet moments for reflection, enough challenges to encourage growth, not too cold, not too hot, not too lonely, not too noisy, a balance so delicate, much like the balance through which nature creates worlds capable of nurturing life. What I love most about the concept of the habitable zone is not that it helps us search for exoplanets. It is that it reminds us that life itself is always born from harmony, not from any single extraordinary thing, not from one miraculous condition. Rather, it is born from countless small conditions existing together at exactly the right moment. Carl Gustav Jung once wrote, "In all chaos there is a cosmos. In all disorder, a secret order." Perhaps habitability itself is one expression of that hidden order. An atmosphere, an ocean, a layer of clouds, just the right distance, a suitable geological history. Each element quietly joining with the others, until somewhere in the galaxy, a world is finally able to begin telling the story of life. As our imaginary spacecraft slowly leaves behind the planets that lie within their stars' habitable zones and the hidden oceans still waiting to be explored, the vastness ahead continues to sparkle with countless unanswered stars. And perhaps, as you gently drift into sleep, what remains with you will not be concepts such as the habitable zone or water worlds, but a quiet sense of peace that neither the universe nor life itself is built upon a single condition. The beauty of existence always emerges from the delicate balance of countless small things, silently supporting one another. Perhaps, like the human soul, a world truly becomes a home for life, only when everything it needs learns to exist together in harmony. Worlds, unlike anything on Earth. The farther we travel beyond our own solar system, the more we discover a deeply humbling truth. Earth is not the template of the universe. For a long time, humanity unconsciously used our own planet as the standard by which every other world was measured. We spoke of day and night, of the four seasons, of oceans, of blue skies, of familiar gravity, as though these were universal rules. But one exoplanet after another has gently dismantled those assumptions. There are worlds that never truly cool. Worlds where gravity is so powerful that every movement would feel unfamiliar. Planets where a single day lasts longer than an entire year. And places that exist beneath an endless twilight. Tonight, our imaginary spacecraft will visit worlds so extraordinary that even Earth's language struggles to describe them. Since childhood, we have grown accustomed to the rhythm of time. The sun rises, the sun sets, day follows night, spring becomes summer. Life on Earth has been built upon these repeating cycles. Yet the universe never promised that every planet would follow the same rhythm. Some worlds orbit so close to their parent stars that powerful gravitational forces quickly lock them into a state known as tidal locking. In this configuration, the time required for the planet to rotate once on its axis becomes exactly equal to the time it takes to complete one orbit around its star. The result is remarkable. One hemisphere always faces the star. The other remains in eternal darkness. Even more extraordinary, on such planets, a day in the astronomical sense lasts exactly as long as a year. For anyone standing on the surface, the star would appear almost motionless in the sky, never rising, and never setting, as our sun does. It is difficult to imagine a life without sunrise, without sunset, without morning, without evening, only a sky that scarcely changes at all. And yet, somewhere out there, such worlds may truly exist. Climate models suggest that along the boundary between the permanently illuminated side and the eternal night side of tidally locked planets, there may exist a remarkable region where temperatures are gentler than on either extreme. This transitional region is often called the terminator zone, an everlasting belt of twilight. Imagine standing there, the star forever resting upon the horizon, never climbing higher, never disappearing. Its gentle light lasting without end. No first morning, no final evening, only an eternal sunset. Perhaps it is one of the most beautiful landscapes astronomy has ever inspired us to imagine. Carl Gustav Jung once wrote, "Who looks outside dreams. Who looks inside awakes." Perhaps when we imagine such a sky, we are also being invited to step beyond the familiar patterns of our own thinking. Not every world requires day and night in order to exist. Not every form of beauty must resemble Earth. Continuing onward, our spacecraft approaches worlds that never truly cool. Some young giant planets still retain enormous amounts of heat left over from their formation. Others continually receive immense energy from their parent stars or experience powerful tidal heating, keeping their interiors extraordinarily hot for immense spans of time. On Earth, we grow up believing that everything hot eventually cools. But nature is always more subtle. As long as energy continues to be supplied, the heat remains. This reminds us that the condition of a world depends not only upon itself, but also upon its relationship with everything around it. Perhaps people are not so different. None of us exists entirely in isolation. We are continually nourished, or slowly worn away, by the world surrounding us. Of course, this is only a symbolic comparison. A planet is heated by physical processes. Human beings are shaped by psychology and society. The two belong to different realms. Yet sometimes the universe offers images that help us understand ourselves with remarkable gentleness. Carl Gustav Jung once wrote, "Everything that irritates us about others can lead us to an understanding of ourselves." Perhaps what surprises us most about these extraordinary worlds is not that they are wrong, it is simply that they are different. And it is precisely that difference that expands our understanding of reality. Another feature that makes many exoplanets so remarkable is gravity. Not every planet possesses the same gravitational pull as Earth. On giant planets, gravity may be far stronger. On smaller worlds, it may be significantly weaker. That difference influences almost everything: the atmosphere, the weather, the geology, the way matter itself moves. If humanity were ever able to set foot upon such worlds, every movement would feel unfamiliar. Every step, every jump, every motion would have to be learned all over again. The remarkable thing is, even our sense of our own bodies would no longer be the same. Perhaps that is what I love most about astronomy. It does not merely change how we understand the universe. It changes how we see the planet we already call home. Carl Gustav Jung once wrote, "The privilege of a lifetime is to become who you truly are." Viewed symbolically, these extraordinary worlds seem to embody that very idea. They do not try to become Earth. They do not try to resemble our solar system. They do not try to satisfy human expectations. They simply exist according to the laws that shape them. Perhaps people are much the same. So much of our suffering comes from trying to live according to patterns that were never truly our own. Jung always believed that the most important journey is not becoming like someone else. It is discovering the authentic nature of who we already are. What moves me most about these extraordinary planets is that they remind us how small and yet how fortunate Earth truly is. Day and night, sunrise, sunset, the changing seasons, gravity that is just right, a climate that is just right. None of these familiar gifts should be taken for granted. They are the result of an extraordinary chain of circumstances. Carl Gustav Jung once wrote, "In all chaos there is a cosmos, in all disorder a secret order." Perhaps it is precisely because worlds so completely different exist that we can appreciate our own planet more deeply. Not because Earth is the center of the universe, but because it is uniquely our home, as our imaginary spacecraft quietly leaves behind those planets where twilight never ends, where time flows according to unfamiliar rhythms, and where gravity writes entirely different rules for existence. The infinite silence of the stars stretches out before us once again. And perhaps, as you slowly drift into sleep, what remains with you will not be concepts such as tidal locking or the eternal twilight zone, but a quiet sense of peace that the beauty of the universe does not lie in every world being the same. Its beauty lies in the fact that every planet has its own way of existing, just as every person has their own unique journey toward becoming who they truly are. Perhaps that is what Carl Gustav Jung quietly sought to remind us throughout his entire life. Worlds that resemble cosmic forges. After a long journey across invisible oceans, iron, rain, lonely rogue planets wandering through the galaxy, and skies illuminated by two suns, tonight we arrive at one of the most extreme places the universe has ever created. These are no longer worlds where we can easily imagine life, nor are they places of gentle dawns or tranquil seas. They are more like colossal cosmic furnaces, blazing in the endless darkness of space. Here, temperatures become so extreme that rock melts into liquid, metals evaporate into vapor, and the sky itself glows with colors never seen on Earth. Yet, as with every destination on our journey, the closer we come to the universe's greatest extremes, the more deeply we appreciate both the subtlety of nature and something profoundly meaningful about the human soul. If someone asked where the hottest places in the universe are, most of us would immediately think of stars. That would be an understandable answer. After all, stars are immense nuclear furnaces, producing energy by fusing atomic nuclei deep within their cores. And yet, one of the most fascinating discoveries is that the daytime atmospheres of certain exoplanets can actually become hotter than the surfaces of some red dwarf stars. Small, relatively cool stars compared with our Sunday. This does not mean those planets shine through nuclear fusion like stars do. Their immense heat comes almost entirely from orbiting extraordinarily close to their parent stars, where they are bombarded by overwhelming amounts of stellar radiation. These extraordinary worlds belong to a class known as ultra-hot Jupiters. They orbit astonishingly close to their stars, so close that an entire year may last only a few Earth days. At such distances, the permanently illuminated side of the planet can reach temperatures exceeding 2,000, even 3,000 degrees Celsius. At temperatures like these, rock is no longer rock, metal is no longer metal. Matter begins to change its state. What was once solid becomes vapor. What once seemed permanent begins to melt away. They truly are gigantic furnaces suspended in space. One phenomenon that particularly amazes astronomers is the deep crimson glow emitted by many of these scorching worlds. Of course, most of the light we detect is still reflected starlight, but on planets this hot, their intensely heated atmospheres and surfaces also radiate enormous amounts of thermal energy, especially in the infrared. Some observations suggest that under suitable viewing conditions, the day sides of these planets could even glow with shades of deep red or brilliant orange. Imagine standing far away, surrounded by the cold emptiness of the galaxy. Before you, a world burns with a crimson glow, not because of volcanoes, not because of fire, but because the entire planet itself radiates heat. A whole world, like a massive bar of iron, freshly removed from a forge. There is something about that image that feels both majestic and profoundly lonely. Carl Gustav Jung once wrote, "Who looks outside, dreams. Who looks inside, awakes." Perhaps the more we contemplate these extreme worlds, the more we realize that the universe is always larger than our imagination. There are places where human intuition alone is no longer enough. We are invited to become humble, invited to expand the boundaries of our imagination. On these ultra-hot planets, scientists have also detected evidence of numerous metallic elements existing within their atmospheres as vapor. Iron, magnesium, calcium, titanium, elements that on Earth are associated with solid rock and metal, become active participants in atmospheric cycles, much as water does here on our own planet. Some atmospheric models suggest that extraordinarily powerful winds transport these metallic vapors from the permanently illuminated day side to the cooler night side. As temperatures fall, the vapors may condense into tiny particles or droplets, creating weather systems unlike anything humanity has ever experienced. Suddenly, our entire idea of weather changes. No longer clouds of water, no longer ordinary rain, but atmospheric cycles, made of metal itself. Perhaps Earth's language was never designed to describe places like these. Carl Gustav Jung once wrote, "Thinking is difficult, that's why most people judge." Perhaps, when faced with worlds such as these, the wisest response is not to rush into comparing them with Earth. Instead, we learn to accept that nature has far more ways of existing than we have ever imagined. What I love most about these cosmic forges is that they remind us beauty does not exist only in gentleness. There is also beauty in intensity. A blazing star, a crimson planet, a sky filled with metallic vapor, a world where stone itself has begun to melt. They are all different expressions of the same universe. If we look through Jung's eyes, perhaps these extraordinary planets also carry a beautiful symbolic meaning. In analytical psychology, Jung believed that human beings cannot truly mature by experiencing only comfort. The process of individuation, becoming who we truly are, often requires us to confront powerful emotions, inner conflicts, and even the shadow, the hidden parts of ourselves we instinctively try to avoid. Of course, this is only a symbolic analogy. A blazing hot planet does not represent the human psyche, yet its image gently reminds us that not every source of heat is a force of destruction. Sometimes, heat is what makes transformation possible. Metal must pass through fire before it can take on a new shape. Stone must endure intense heat before it can become something different. Perhaps people are much the same. Not every hardship exists only to make us suffer. Some experiences, however painful, help us become a truer version of ourselves. Carl Gustav Jung once wrote, "There is no coming to consciousness without pain." Perhaps those words feel especially meaningful when standing before planets that resemble the great furnaces of the cosmos. Not because suffering is always necessary, but because transformation rarely happens in stillness. Even nature itself needs heat, needs pressure, needs time to create new worlds. What moves me most after this long journey through hundreds of extraordinary planets is not the staggering numbers or the unimaginable temperatures. It is the endless diversity of existence. There are planets covered by oceans, planets where iron falls as rain, planets wandering alone between the stars, planets glowing like enormous cosmic furnaces. No world is exactly like another. And that is precisely what makes the universe so beautiful. Carl Gustav Jung once wrote, "The privilege of a lifetime is to become who you truly are." Perhaps, if planets could tell their own stories, they would say the very same thing. There is no need to become Earth, no need to become Jupiter, no need to resemble any other world. Simply exist according to the nature that the universe has given you. As our imaginary spacecraft slowly leaves behind those crimson planets glowing like vast celestial furnaces, the stars ahead continue to shine with light that has traveled millions of years to reach us. And perhaps, as you gently close your eyes in the quiet of the night, what remains with you will not be temperatures measured in thousands of degrees, nor skies filled with metallic vapor, but a peaceful realization that the universe has never tried to create two identical worlds. Just as every human soul carries its own unique journey, its own inner fire, and its own way of shining, Perhaps that is the deepest beauty Carl Gustav Jung and the star-filled sky quietly offer us before we drift into a peaceful sleep. After such a long journey, our imaginary spacecraft is finally beginning to leave behind the most distant regions of space that human curiosity has ever reached. Behind us lie hundreds of extraordinary planets, each carrying its own story, its own beauty, and its own unique way of existing. Some worlds are showered with molten iron. Some remain forever, wrapped in eternal darkness. Some wander the galaxy without a sun. Some rise beneath twin suns. Some hide vast oceans beneath ice, tens of kilometers thick. Some glow like gigantic cosmic furnaces. And some are still very young, carrying within them the lingering warmth of the day they were born. Perhaps, when we began this journey, we simply wanted to explore the strangest planets in the universe. But as we traveled farther, we slowly discovered that this journey was never only about planets. It also became a journey into the way human beings understand existence itself. For centuries, humanity believed our solar system was the model for all planetary systems. Then we discovered planets with two suns, planets with no sun at all, planets where rock evaporates, planets where a single day lasts as long as an entire year, planets as light as clouds, worlds that seem to have stepped out of a dream. Each new discovery gently reminds us that the universe is always larger than our imagination. And perhaps that is exactly what Carl Gustav Jung hoped for when he spoke of the growth of consciousness. Not to search for answers that close every door, but to remain humble enough to open new ones. Jung once wrote, "Who looks outside, dreams. Who looks inside, awakes." Throughout this journey, we have looked outward, toward the stars, toward distant worlds. Yet perhaps, while quietly gazing into the universe, something deep within your own soul has also begun to awaken. Perhaps that is the greatest gift the night sky has always offered. It reminds us that we are small, but never insignificant. On the contrary, it is precisely our smallness that connects us to something infinitely greater. Because every atom that makes up our bodies today was once forged deep inside stars that died long before Earth was ever born. The iron in our blood, the calcium in our bones, the carbon in every living cell, all of them are gifts from the universe. Astronomer Carl Sagan once said, "We are made of star stuff." Perhaps no other sentence captures the connection between humanity and the cosmos more beautifully. We do not stand apart from nature. We are part of it. We do not stand outside the universe. We are simply a tiny chapter in a story that has been unfolding for nearly 14 billion years. Jung also wrote, "The privilege of a lifetime is to become who you truly are." After traveling past hundreds of extraordinary planets, I realized something quietly beautiful. No world tries to become another world. An icy planet does not wish to become a world of fire. A gas giant does not long to become a rocky planet. Each one simply exists according to the laws that shaped it. Perhaps we are not so different. We spend so much of our lives comparing ourselves to others, comparing our lives, our achievements, our pace of growth, everything we have or have not yet found. Yet the universe seems to whisper something wonderfully gentle. No two planets are exactly alike. So why should human beings be? Some people shine like stars. Some are deep and quiet like oceans. Some are peaceful like distant planets. Some are powerful like storms. Each of us follows a different orbit, a different rhythm, a different light. Carl Gustav Jung once wrote, "In all chaos there is a cosmos. In all disorder, a secret order." Perhaps that is the final gift the universe offers us tonight. When we look at life from very close, everything can seem chaotic. Our worries, our losses, the questions we still cannot answer, the dreams that remain unfinished. But when we step back, when we look from far away, as though observing a distant planetary system from hundreds of light years across, everything seems to move along its own quiet orbit. Some answers can only be given by time. Some forms of peace arrive only after many long years. Some meanings become visible only to those who are patient enough to wait. Perhaps that is why the night sky has always had the power to calm the human heart. It does not answer every question, but it teaches us not to fear the unknown quite so much, because it is the unknown that has led humanity to every great discovery. If one day we believed we had understood the entire universe, perhaps that would also be the day our journey of discovery came to an end. Fortunately, that day will never come. Beyond us still lie billions of undiscovered planets, billions of unnamed stars, billions of stories whose light is still traveling toward Earth. And perhaps, within the human soul itself, there are still entire galaxies waiting to be explored. Carl Gustav Jung once wrote, "Until you make the unconscious conscious, it will direct your life and you will call it fate." Perhaps the journey into the universe and the journey into ourselves have never truly been separate. The more we understand the stars, the more we understand our own smallness, and the more we accept that smallness, the more deeply we learn to treasure every moment we are alive. The night is growing deeper now. Our imaginary spacecraft is gently slowing down. Far away, the stars continue to shine, just as they have for billions of years, never rushing, never making a sound, simply existing with quiet patience, like the steady breathing of the universe itself. If your eyelids are beginning to feel heavy, if the thoughts of today are slowly becoming still, simply allow yourself to drift with that peaceful silence. There is nothing more you need to think about, no more answers you need to search for tonight. The sky will still be there tomorrow. The stars will continue telling their stories, and perhaps, somewhere inside a peaceful dream, you will continue this journey among distant galaxies, where countless wonders are still quietly waiting to be discovered. Thank you for spending part of your precious time with me on this journey through some of the most extraordinary worlds in the universe. If tonight's story brought you a sense of peace, sparked your curiosity, or simply helped you relax before sleep, I'd be truly grateful if you subscribed to the channel and turned on notifications so you won't miss our next journey together. Every subscription helps this channel continue to grow. But more importantly, it encourages us to keep creating gentle, thoughtful stories about the universe, science, and the remarkable depths of the human soul through the timeless perspective of Carl Gustav Jung. And now, let the worries of today quietly dissolve into the endless sea of stars. Allow your breathing to slow. Let your mind grow lighter. Let sleep arrive naturally. I wish you a peaceful night. May your dreams be gentle beneath a sky filled with stars. And until we meet again on our next journey, where we will continue exploring the endless mysteries of the universe and the hidden landscapes of the human soul, sleep well. Good night.